Okay, good evening, all of you. So shall we start the class?
Yes, sir.
Okay. Today we'll going to discuss about the fuel cell technologies. That is the proton exchange membrane fuel cells, and also solid oxide fuel cells, and alkaline fuel cells. Along with that, we are going to study the hybrid energy storage solutions, combining with your supercapacitor as well as the various types of the batteries. Right. So this is our actual today's topic. The agenda is like this. So we have to study more, focus on the this one, proton exchange membrane fuel cells. Right. So these are the contents. Right. We have to study what are different types of fuel technologies we have, and also the how the functioning of the proton exchange membrane fuel cell will work, and also the oxide fuel cell will work, and also the alkaline fuel cell will work. So these are the topics you have in your syllabus. All right. Along with that, we'll study the combinations of the battery and super capacitor storage, especially in the hybrid energy storage, right? And what are the solutions they have been provided for the combining with the renewable energy, with the thermal, wind, and other kinds of the conventional and non-conventional energy. So from that, how the load can be, we can compensate the loads, right? If there is a lot of peak demands for the demand for the loads, how we can compensate, and what is the reason behind to make the combination of these batteries and along with the capacitors, right? Most of the we use the batteries for the storage purpose, that is the energy storage management system. So like that, we are going to have the hybrid energy storage, right? So it means that we are combining the batteries along with the supercapacitors along with the fuel cells. So like that, that is what we are making the hybrid energy storage solutions. We have to provide the solution for the conventional and non-conventional to meet the load demands, right? To meet the load demands if the generation is a very deficit. Okay, so this is what we have to study in the content number 3, right? That is hybrid energy storage, right? What are the solutions you are going to provide for the conventional and non-conventional energy resources, right? If when there is an excess of the loads, how you are satisfying the load demands, and how this energy management, right? How the energy storage management will work when the combining with two energy storage, that is the batteries and supercapacitors. So along with this, we'll study the basics of the first, how the working principle of the proton exchange membrane fuel cells, right? And also the oxide fuel cells, and also the alkaline fuel cells, which working operations and the applications, right? And what are the fuel cell technologies we have, right? So let us see one by one. So in our syllabus, we have the contents like this, right? In yesterday's class, we have completed up to the supercapacitor design, working principle, and applications, right? So today we'll study the fuel cell technologies. Fuel cells technologies, proton exchange membrane fuel cells, right? Solid oxide fuel cells, and alkaline fuel cells, and also making the combining the two types of energy storage, that is a battery as well as a supercapacitor. How this energy storage will makes an importance in the conventional and non-conventional energy resources, right? So this is what the topics we have to study in the today's sessions. So, all right, so we'll go to the slides one by one. We'll understand the first concepts of the fuel cells, right? So that is how the fuel cell technologies, how the fuel cell technology has been implemented, and what are the many research has been undergone to make the fuel cells to be more advanced, and how many companies, that is how many EV vehicles companies are being come forward to install the fuel cells for your electric vehicles, right? We'll see one by one, step by step. First, we'll understand the fuel cell technologies, right? What are the fuel cell technologies, and how it has been implemented in the electric vehicles. So, all right. So we'll understand how a proton exchange membrane fuel cells makes electricity. So, all right, it is unlike a batteries. See, the battery is completely different, right? And also your proton exchange membrane fuel cells is different, right? So where PMC do not store energy internally, right? So it reacts or supplied continuously from the external source, producing the electricity as long as the hydrogen and oxygens are available, right? As I told in the yesterday's class, the fuel cell, right? In the yesterday's class, I talked about the fuel cell. What the fuel cells will do actually, the fuel cells will be in the running condition, right? When you provide the fuels, isn't it? So when you want to run your bike, right, you want to fill the petrol, then only it will try to run, isn't it? So that is how the fuel cell will work, right? It is not like the batteries, it will store the energy. When you store the energy, then only it can discharge. But the fuel cell is not like that. As I told the example of the reservoir of the hydro plants, right, where if the water is available, then only it is possible to generate the energy from the hydroelectricity, isn't it? So if the water is like, water is just like a fuel for you, isn't it? When water is a fuel, then only the fuel cell will work, right? That is how we are just comparing the fuel cell with the other day-to-day life examples, right? So as I give an example of one thing is that when you want to run the vehicles, please fill the petrol, then only your IC engines will work, right? So after when the fuel gets completed, when the petrol is completed, the vehicle will not run, isn't it? So like that only the fuel cell also work in the similar manners. So other example I told about the reservoir of the dams. If the water is reservoir, in the reservoir there is water, then only you can go for the generation of electricity. If there is no water in the dam, you cannot make the generations of electricity, isn't it? So the water is like a fuel here, isn't it? The petrol is like a fuel, correct? Then only those plants and your vehicles will work, isn't it? So like that we'll understand what is actually the fuel cell, how the fuel cell will work, right? So fuel cell is unlike a battery, it's not like the batteries. So where you can have the chemical reactions, isn't it? So PEMFC do not store energy internally, right? So it will not store internally. Whenever you give the fuels, such as hydrogen, right? You have to. I'll explain this very clearly in the upcoming slides. First, we'll understand what are the agents are required. So what are the agents are required for across the anode and the cathode, right? Say hydrogen is the agent, right? Where it will react and will try to produce the protons, right? That is the H plus, isn't it? And also you have the oxygen. So oxygen will be supplied in the another ends. So there are two ends will be there, isn't it? In yesterday's class I told hydrogen will be provided in one side across the anode and oxygen will be provided across the cathode side, isn't it? So in between you have the we have the electrolyte that we are told about this protons membranes, isn't it? This is called the proton membranes, or you can say there is separation between the two electrodes, isn't it? So like that we have here the proton membranes. So that's why it is called a EM, that is proton exchange membranes. We will understand what exactly it is very clearly, right? So here there are the two agents we have, that is hydrogen and oxygen. Hydrogen is supplied from one end and oxygen is supplied from the other end. So in between you have the proton exchange membranes, okay? So that is reactants are supplied continuously, right? So what are the reactants we have? Hydrogen and oxygen. So these are the reactants are supplied continuously from the external source, right? You have to pump the hydrogen and also oxygen, right? Hydrogen is also very difficult. You cannot make the transportation because it is more inflammables, right? You should take care of the hydrogen also. It is very costly as also. So that's why you have to transport the hydrogen and also the transportation purpose. When you talk about the storage, right? Hydrogen storage, it is more difficulties, right? So that's why even though we are difficulties, we are looking to generate the energy from the hydrogens, right? That is what how the fuel cell will work, right? Fuel cell, in that you require the fuels as a hydrogen is a fuel work and also you have the oxygen over here, isn't it? So these are the two reactants which are supplied continuously from the external source, right? And that these two makes when they mix react, right? So that is what the redox reactions will happen with the help of the catalyst, isn't it? Yesterday I told about the catalyst. So that catalyst will try to improve the reaction the more faster and faster, right? So by producing the electricity as long as hydrogen oxygens are available, correct? As like your fuels are available. If the petrol is available, then only you can go for run your vehicle, isn't it? If the water is available in the reservoir of the dam, then we can go for the generations, right? It is like a just instant. Whenever you have the fuel, then the working is possible, right? When you don't have the fuel, you cannot get any outputs. That is what the fuel cell will try to produce the energy, that is electrical energy it will produce as long as you provide the hydrogen and oxygen from both the ends, correct? So only the byproduct is we have the water and heat. When these two makes a reaction with the help of the chemical equation, we will understand how the production of the byproducts will occur, right? Water and heat, and water will be taken outside, right? And heat will be generated inside the fuel cells. So it is like instantly, right? So it doesn't store energy. It doesn't store any kind of the energy like your lithium batteries. So that's why it is unlike to the comparing with the batteries. It is unlike. It is not like similar to the batteries. I hope you agreed. So it is not very similar to the batteries. That's why we say it is unlike to the batteries, right? It is not like the lithium batteries where you can store the energy for a longer time and discharge for a longer time. It is not like that. It is just like your instant. Right? As soon you give the fuel, no, like hydrogen, oxygen, then it will try to generate the energy, electrical energy. If you don't provide the fuel, no, hydrogen and oxygen, it will not generate the energy, right? So that's why it doesn't store internally. There is no chances of storing the energy in the fuel cells. Okay. So the reactants are hydrogen and oxygen are the two reactants, which has to be supplied continuous manner, right? From the external sources. So that is what they're telling you have to provide the oxygen You have to provide the hydrogen from the two different ends, that is across the anode and the cathode. So in between you have the proton exchange membranes, right? So what is the final product? You are getting the water and heat, and also the production of electrons, right? The production of electrons in the one side and the direction of the current on the other side. That is, we call it as a conventional current. Okay, I hope you understand in the lower class, in the lower studies, in the UG classes, right? So that is how these reactions will happen, right? And there is no combustions and there is no emissions, right? It is not like your batteries. So every time you have to keep on the monitoring for the checking of the solvent, nothing but the water level of your batteries in the just I'm talking about the distilled waters in the batteries, right? You have to check the distilled water in the batteries. If the level has got decreased, no, it means that it will affect on your electrodes, right? The battery won't charge, right? For example, if you take the batteries for your lithium, right? In the Amaron batteries also, right? In Amaron batteries also, when you purchase the Amaron batteries, any kind of the batteries, okay, all right. So you have to check the distilled water in that. Why we have to check the distilled water? Because the water level is getting decreased, no? It will not try to charge or it will not try to discharge the energy from the batteries. Okay, that is, it will not provide the good energy density from the batteries because the water level is being reduced. So that is what you have to see the solvent in the your Amaron batteries of the water levels. That is very most important, right? But we don't have any kind of the problems here. Don't worry, we don't have any kind of the problems over here. We have to see about more about the hydrogen and oxygen. Provide this continuously, okay? Hydrogen and oxygen provide continuously to the inside the fuel cells, so that it will try to generate the electricity, okay? And what is the output? Water and heat is a byproducts, right? And output is a generation of electricity. That is, the electrons are coming from this end to this end, and current will flow from this end to this end, okay? We'll see this working principle in the upcoming slides, right? And what is the final there won't be any combustions, okay? And there is no emissions, right? If you see the fuel like petrol, if you use the petrol engines, no, so what will happen? The engine will try to provide the carbon monoxide, isn't it? It will try to produce your carbon and oxygen levels more and more, which will pollute the environments, isn't it? It will try to produce the environment. It will try to harm the environment, right? Because of the emission from the your vehicles. That is, I'm talking about the IC engine vehicles, okay? So here we don't find, if you use a fuel cell, no, if you use a fuel cell for your electric vehicle, see, there is no emissions, correct? That is one of the benefits over here. And also there is no combustions. There is no combustions could be happens. All right. Now see, this is how the inside this stack, the cells will be, the fuel cells will be connected in the series combination, right? So if I have the series, if you make the series and combinations of n numbers, you may get up around the rating will be very high. Right, you have to make the series and combinations of the cells where you can connect your series and combination cell, right, to get the more voltage and the current. So all right, if you have the connections of the series and the parallel, right, for example, if you want to have the power rating of 6 kilowatt, okay, so the cells will be stacked, means the cells will be stacked like this, okay. This is actually the diagrams where you can see how the fuel cell of your the PEMFC will look, isn't it? So if you want to have the 6 kilowatt of the readings of your fuel cell, right? So probably you have to connect in the series or parallel combinations to get the voltage of around 27 volts. Battery of fuel cell of the ratings will be around 27 volts, and you can get the current of 200 amperes. Right? If you make the cell stacks, if you make the fuel cell stacks, no, if you connect in series and parallel, right? For a rating of around 6 kilowatt of the ratings. So you may have to get the current of 200 amperes, and the voltage will be around 27 voltage. Okay, so that is how the fuel cell stacks will be connected. Okay, so here they have shown very clear the proton through the polymers and electrons through the circuits. Right, so protons are moving through the polymer, that is the exchange membranes. All right, that is what we call it as a proton exchange membranes. Right, proton exchange membranes will tell us about how the protons will try to move. What is a proton over here? What is a proton? H plus. See, in this equation again, see, this is your protons. This is your protons. H plus is the proton. H2. Okay, you are passing hydrogen from one end. Okay. So what is the right hand side equation? 2H plus. So equation is balanced. Here H2 hydrogen, right? 2 times of hydrogen. So then equation is balanced, yes or not? From the hydrogen, you are going to release the electrons. That is 2 times of electrons will be released. Okay. So that is the electrons will be released. That is what I am telling you about how this hydrogen, the protons. So this is actually protons. Okay, this protons nothing but the 2H plus, and release of electrons. Electrons where? Electrons will go to the circuits, yes or not? That is what is happening in the anode reactions. Correct? Similarly, the proton paths. If you see the proton paths, let us see now H plus. Okay, we have the 2 H plus. That is H plus, and we have the another H plus, isn't it? So that is the H plus ions will try to move through the solid polymer membranes. Okay, we call it as electrolytes. In between we have the electrolytes, so that is called the polymer membranes. So it will try to pass from the one end to the another ends, right? So H plus will go towards the anode, sorry, towards the cathodes, right? And electrons will try to attract towards the anodes. So that is what the exchange of electrons. Electrons will move through the circuits, and protons means what? H plus will try to move through the your polymer members, polymer membrane, right? That is what we are talking about, the polymer membranes, where it is going to move towards the your cathode sides, right? So the electrons will travel through the external circuit. When one electron is emitted from the your hydrogen, right? When the electron is emitted from the hydrogen, it will try to move towards the your actual circuit where you connected to deliver the power. Okay, so this is what the actual how the your proton exchange member will looks. Okay, now let us see how this membrane is a superpower, how it will works. Okay, so in this diagram we can see very clearly that there is a proton conductors, we have electron blockers, and also the gas barriers. Okay, so what are the gas you are going to produce? That is, we have to give the hydrogen and oxygen, right? So that is from directly we have to provide, isn't it? So what is the proton conductors? H plus, that is a proton exchange, that is a proton. H plus ions is a proton, right? That is passed through the freely. So that is what, once the reaction is happening through the help of the catalyst, that is we are using the catalyst called as a platinum, right? That is not materials, it is type of the materials which is used for the create the more faster reactions in the your fuel cells, right? So it is just like a catalyst which will improve the which makes the reaction to be more faster. That's what is named as a catalyst. Okay, and also you have the electron blockers, isn't it? The electron blockers is one thing, please understand. Once the electron is generated, it will not try to move on the other ends. It has another path, right? It will only allow the H plus. So that's why it will try to allow the only H plus. H plus na matra kalsutte horta electron na exchange madak bidodilla. Please understand, if you understand the basic concept, what I am telling from the scratch, okay, please try to concentrate properly, right? So H plus ಏನಾಗುತ್ತೆ, H plus na ಮಾತ್ರ allow ಮಾಡುತ್ತೆ, electrons na block ಮಾಡುತ್ತೆ. ಅದಕ್ಕೆ ಇದನ್ನ electron blockers ಅಂತ ಕರೀತಾರೆ. ಅಲ್ಲಿ membrane ಹತ್ರ, what we talk about the membranes, no? So that membranes will try to allow only the H plus. That's why it is a proton exchange membranes. That's why it is a proton exchange membranes. ಅಂದ್ರೆ proton H plus na ಮಾತ್ರ ಅದು exchange ಮಾಡಕ್ಕೆ allow ಮಾಡುತ್ತೆ ಹೊರತು electrons na allow ಮಾಡೋದಿಲ್ಲ. Electrons na block ಮಾಡೋದು. So that is what the freely available electrons, no, the force electrons into the external circuit to the generator. Electrons na ಏನು ಮಾಡುತ್ತೆ, ಆಚೆಗಡೆ ಕಳಿಸಿಬಿಡುತ್ತೆ. It will not make the change. See, electrons will try to move on the other circuit where you can get the power can be generated. You can see there is a power button over here, isn't it? So electrons ಏನಾಗುತ್ತೆ, ಬೇರೆ ಸೈಡ್ ಇಂದ ಹೋಗುತ್ತೆ. ಬಟ್ ಇಲ್ಲಿ ಇರೋ ಹೈಡ್ರೋಜನ್ ಏನಿರುತ್ತೆ, H plus ions na membrane in the one side in the another side, it will try to move. Okay, it will cross the membranes. Okay, so that's why it is called the electron blockers. Electron ಯಾವುದೇ ಕಾರಣಕ್ಕೂ membrane ಮೂಲಕ ಕಳ್ಸಕ್ಕೆ ಬಿಡೋದಿಲ್ಲ. Okay, so that is what you can see at the cathode, right? You can note on the equations also. It will be very better for your understanding purpose. Okay, these are the equations you have to understand. Across anode reaction ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, hydrogen pass ಮಾಡ್ತೀರಾ, hydrogen ಅಲ್ಲಿರೋ electrons ಏನಾಗ್ತಿದೆ, release ಆಗ್ತಾ ಇದೆ. Okay, and also the ions ಕೂಡ release ಆಗ್ತಾ ಇದೆ. You can see there is a 2H, that is 2H plus. Here have the H2, you have the 2 electrons. ಅವಾಗ ಏನಾಗುತ್ತೆ, ions ಕೂಡ release ಆಗ್ತಾ ಇದೆ across the anode. Okay, across, let us see across the cathode. Across the cathode ನೀವೇನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಆಕ್ಸಿಜನ್ ಪಾಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಓಕೆ, ಆಲ್ರೆಡಿ ಏನಾಗಿದೆ ನಿಮ್ಮ ಹತ್ರ, ಹೈಡ್ರೋಜನ್ ಅಯಾನ್ಸ್ ಬಂದ್ಬಿಟ್ಟಿದೆ. ಓಕೆ, ಅಂಡ್ ಆಲ್ಸೋ ಯು ಹ್ಯಾವ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಸಿ, ನಾವು ಇದನ್ನ ಯಾಕೆ ಈ ತರ ಬರೀ, ವಿ ಹ್ಯಾವ್ ಟು ಬ್ಯಾಲೆನ್ಸ್ ದ ಇಕ್ವೇಷನ್ಸ್. ಪ್ಲೀಸ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ಯು ಹ್ಯಾವ್ ಟು ಬ್ಯಾಲೆನ್ಸ್ ದ ಇಕ್ವೇಷನ್ಸ್. ಆಕ್ಸಿಜನ್ ಅದರ್ ಸೈಡ್ ಆನೋಡ್ ಕ್ಯಾಥೋಡ್ ಆಕ್ಸಿಜನ್ ಪಾಸ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಮತ್ತೆ ಹೈಡ್ರೋಜನ್ ಏನಾಗ್ತಾ ಇದೆ, ಆಲ್ರೆಡಿ ರಿಲೀಸ್ ಆಗಿದೆ ಮೆಂಬ್ರೇನ್ ಇಂದ ಎಕ್ಸ್ಚೇಂಜ್, ಮೆಂಬ್ರೇನ್ ಇಂದ ಕ್ರಾಸ್ ಮಾಡಿ ಆ ಕಡೆ ಇಟ್ ಇಸ್ ಕಮಿಂಗ್ ಟುವರ್ಡ್ಸ್ ದಿ ಕ್ಯಾಥೋಡ್ ಸೈಡ್ಸ್, ಅಂಡ್ ಆಲ್ಸೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಸ್ ಆಲ್ಸೋ ಟುವರ್ಡ್ಸ್ ದಿ ಕ್ಯಾಥೋಡ್ ಸೈಡ್ ಓನ್ಲಿ. ಓಕೆ, ಆಲ್ರೆಡಿ ಇಟ್ ಇಸ್ ಕಮಿಂಗ್ ಅಕ್ರಾಸ್ ದಿ ಕ್ಯಾಥೋಡ್ ಸೈಡ್. So this will recombine all these atoms. Okay, oxygen atoms ಆಗಿರ್ಬೋದು, ಹೈಡ್ರೋಜನ್ ಆಗಿರ್ಬೋದು, ಅಯಾನ್ಸ್ ಆಗಿರ್ಬೋದು, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಗಿರ್ಬೋದು, ಇವೆಲ್ಲ ಆಗುತ್ತೆ, ಕಂಬೈನ್ ಆಗುತ್ತೆ. ಕಂಬೈನ್ ಆಗಿಬಿಟ್ಟು ಏನಾಗುತ್ತೆ, it try to produce the water, that is the 2H2O. So you can see there is a 4H, 2 into 2, 4H. Okay, 4H is balanced, correct? O2, 2 times of O. So equation is balanced. Okay, that is what we have to see. The electrolyte is a solid polymer, right? So that is typically we are using a sulfonic acid we are going to use, right? That is called, we call it a nephron. right? That is we have to use in the permeability polymer, solid polymers we are going to use for as electrolytes in the exchange membranes. Okay, so that will try to conduct only the protons. Proton ಮಾತ್ರ allow ಮಾಡುತ್ತೆ, ಅದಕ್ಕೆ ನಾವು ಈ ಮೆಟೀರಿಯಲ್ ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. We are going to use these kinds of the solid polymers, right? It will try to understand only the hydrogen ಮಾತ್ರ allow ಮಾಡುತ್ತೆ. ಬ್ಲಾಕ್ಸ್ ಮಾಡೋದು ಯಾವುದು, ಎಲೆಕ್ಟ್ರಾನ್ ಬ್ಲಾಕ್ ಮಾಡೋದು. ಎಲೆಕ್ಟ್ರಾನ್ ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಮೆಂಬ್ರೇನ್ ಇಂದ ಪಾಸ್ ಮಾಡಕ್ಕೆ ಬಿಡೋದಿಲ್ಲ. ಅದಕ್ಕೆ ನಾವು ಎಕ್ಸ್ಕ್ಲೂಸಿವ್ ಆಗಿ we are going to for select the permeability layers also, right? We are using this kinds of the materials, solid polymers, that is called the parafluorosulfinic use ಮಾಡ್ತಾರೆ. The commercial it is named as a nepheons, right? Chemical name is a nepheons, that is we are going to use this solid polymers for the exchange membranes. Okay, so it will try to block only the electrons. It will not allow for the it will allow only for the hydrogen, that is a H plus ions na ಮಾತ್ರ allow ಮಾಡುತ್ತೆ, electron na block ಮಾಡುತ್ತೆ. Okay, so that is what, right? So is it clear the basics of this? So is it clear, Mamta, Sneha?
Yes, sir. Yes, sir.
Okay, you'll understand in a very better way also. I have given a lot of slides to make you to understand the concept of fuel cells. Okay. Now let us see how this have the voltage reality check, isn't it? So if you see, depends upon the stacks. Stacks are nothing but how we are connecting the cells in series and parallel combinations. Okay, it is based upon your combinations of the cell configurations. It will try to provide the your voltage. Okay, so voltage ಯಾವಾಗಲೂ ಇದು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಬೇರೆ ಸೂಪರ್ ಕೆಪಾಸಿಟರ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ವೋಲ್ಟೇಜ್ ಯಾವಾಗಲೂ ನಿಮಗೆ 1 ವೋಲ್ಟ್ ಗಿಂತ ಕಡಿಮೆ ಇರುತ್ತೆ. ಈಚ್ ಸೆಲ್ ಹ್ಯಾವಿಂಗ್ ದ ಲೆಸ್ ದೆನ್ 1 ವೋಲ್ಟ್. ಪ್ಲೀಸ್ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ದಿ ಆಸ್ಕ್ ಇನ್ ಸಮ್ ಇಂಟರ್ವ್ಯೂದಲ್ಲಿ ಕೇಳ್ತಾರೆ ಫ್ಯೂಯಲ್ ಸೆಲ್ ವೋಲ್ಟೇಜ್ ಎಷ್ಟು ಇರುತ್ತೆ ಅಂತ ಕೇಳ್ತಾರೆ ಫಾರ್ ಈಚ್ ಸೆಲ್ಸ್. ಓಕೆ, ಇಟ್ ಇಸ್ ಆಲ್ವೇಸ್ ಲೆಸ್ ದೆನ್ 1 ವೋಲ್ಟ್ಸ್, 0.7 0.8 ಆ ಥರ ಇರುತ್ತೆ. ಬಟ್ ಸೂಪರ್ ಕೆಪಾಸಿಟಿ ವೋಲ್ಟೇಜ್ ನಾವೇನು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತೀವಿ ಅದರ ವೋಲ್ಟೇಜ್ ಇರೋದಿಲ್ಲ. ಯೂಶಲಿ ಫ್ಯೂಯಲ್ ಸೆಲ್ ವೋಲ್ಟೇಜ್ ವಿಲ್ ಬಿ ವೆರಿ ಲೆಸ್ ದೆನ್ 1 ವೋಲ್ಟೇಜ್. ಓಕೆ, ಪ್ಲೀಸ್ ರಿಮೆಂಬರ್ ದಿಸ್. ಯೂಶಲಿ ಇನ್ ದ ಇಂಟರ್ವ್ಯೂ ಎಲ್ಲಾದ್ರೂ ಬಗ್ಗೆ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ ವಾಟ್ ಇಸ್ ದ ಸೆಲ್ ವೋಲ್ಟೇಜ್ ಆಫ್ ದ ಫ್ಯೂಯಲ್ ಸೆಲ್ಸ್. ಓಕೆ, ಸೊ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್. ಓಕೆ, ಫಾರ್ ಈಚ್ ಸೆಲ್ಸ್ ವಿಲ್ ಬಿ ಅರೌಂಡ್ ಆಫ್ 0.7 to 0.8 voltage. Okay, so that is what this is single cell. Okay, single cell voltage ಇದ್ದಾಗ ನೋಡಿ it is almost 0.7. Okay, cell 10 cell ನ ನೀವೇನ್ ಮಾಡಿದ್ರೆ ಇವಾಗ you are connected in series. Okay, so current will be very less and voltage will be very high. ನೋಡಿ voltage ಏನಾಯ್ತು, almost it is 5 or approximately is coming to the 10. Yes or not? It is approximately coming to the 10. Correct? So here also you can see there is a increasing in the voltage. So cell ನೀವು ಯಾವ ತರ ಮಾಡಿದ್ರೆ ಕಾನ್ಫಿಗರ್ ನ you are connected in series combinations. Okay, current will remain same and voltage will be very high across all the cells. The voltage gets added up. Okay, this is how the cell stack will be arranged. Okay, to get the voltage realities. Voltage ಯಾವ ತರ ಬರುತ್ತೆ ಅನ್ನೋದು ಅವರು ತೋರಿಸಿದ್ದಾರೆ. Cell stacks ಅಂದ್ರೆ ಏನಂದ್ರೆ ನಿಮಗೆ ಕ್ಲೀನ್ ಆಗಿ ಅರ್ಥ ಮಾಡಿಸಿದ್ದಾರೆ. You can see there is you can understand very clearly. Each cell and cell, if 10 cells are connected, the voltage would be like this. So 0.7 into 10. Okay, 0.7 into 10. So like that you have to calculate. So it will try to give the actual value of the cell voltage, isn't it? So if you have the cell voltage of 0.7 volt, okay, into 10, it will be giving around how much 7 volts it will provide. Yes sir, it will provide only the 0.7 volts. ನೀವು ಆ ಥರ 10 cells ನ ನೀವು ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೀರಾ ಅಂದ್ರೆ ಸೀರೀಸ್ ಅಲ್ಲಿ, so it will try to give only the 7 voltage. ಅದೇ 100 cells ಆದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ, you go for 100 cells, see 70 voltage. Yes or not? So this is how you have to make the configuration of the cells. Okay, to get the enough of the power on the electric drivetrains. So this is how they make the stacks. Stacks are nothing but the combinations of the series and parallel combinations. One example I told for the 6 kilowatt. 6 kilowatt one example ಹೇಳಿದೆ ನಾನು. 6 kilowatt ಗೆ ನಿಮಗೆ if you want to get the voltage around of 27 voltage, right, and also the current to be around 200 amperes, then you have to connect in parallel. So see, this is how the series and parallel combinations will occur. ನಿಮಗೆ ಯಾವ ಥರ ವೋಲ್ಟೇಜ್ ಜಾಸ್ತಿ ಬೇಕೋ ಕರೆಂಟ್ ಜಾಸ್ತಿ ಬೇಕೋ ಅನ್ನೋದ ಮೇಲೆ ನೀವು ಅದನ್ನು ನೀವೇನು ಮಾಡಬೇಕು, ವೋಲ್ಟೇಜ್ ಜಾಸ್ತಿ ಬೇಕು ಅಂದರೆ ಸೀರೀಸಲ್ಲಿ ಮಾಡಿ, ಕರೆಂಟ್ ಜಾಸ್ತಿ ಬೇಕಂದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಕನೆಕ್ಟ್ ಇನ್ ಪ್ಯಾರಲ್. ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದಿ ಕಾಂಬಿನೇಷನ್ ಕಾನ್ಫಿಗರೇಷನ್ಸ್ ಯಾವ ಥರ ಮಾಡ್ತೀವಿ ಅನ್ನೋದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ಸ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಈಚ್ ಸೆಲ್ ಪ್ರೊಡ್ಯೂಸರ್ಸ್, ಪ್ಲೀಸ್ ರಿಮೆಂಬರ್, ಈಚ್ ಸೆಲ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ದ ರೇಟಿಂಗ್ ಆಫ್ 0.7 volts ಅಂಡರ್ ದಿ ಲೋಡ್ ಕಂಡೀಷನ್ಸ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ಆಕ್ಚುಯಲ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದಿಸ್. ಅದಕ್ಕೆ ಫ್ಯೂಯಲ್ ಸೆಲ್ ನಾವು ಬೇರೆ ಸೆಲ್ಸ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ವೋಲ್ಟೇಜ್ ಕಡಿಮೆ ಇದೆ, ಬಟ್ ದೇರ್ ಇಸ್ ಲಾಟ್ ಆಫ್ ಬೆನಿಫಿಟ್ ಫ್ರಮ್ ದಿಸ್. ಓಕೆ, to reach the practical voltage for the vehicles, right, this is not very sufficient. So you have to make the voltage to be more and more. ಜಾಸ್ತಿ voltage ನೀವೇನು ಮಾಡಬೇಕು, ಸ್ಟ್ಯಾಕ್ನ ಅರೇಂಜ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. It may be 10 cell stack, it may be 50 cell stacks, it may be 100 cell stack. So based on that you can get the enormous of power, okay, and current will be very less. So that's how you have to make the voltage check, isn't it? So ನೀವು voltage check ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, you can get the good amount of voltage of the readings, okay. So next, if you see the benefits, right, so benefit from the these kinds of the cells, that is we can use as like a ultra capacitors ಹೆಂಗೆ ಯೂಸ್ ಮಾಡಿದ್ರಿ ನೀವು for the cold start from the -45 to 65 degrees centigrade, okay. ಇಲ್ಲೂ ಕೂಡ ನಾವು ಅದೇ ರೇಂಜಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತಿದ್ದೀವಿ, we are going to start the fuel cells, right. The fuel cells ಇಂದ ಏನು ಮಾಡ್ತೀವಿ ನಾವು, ಕೋಲ್ಡ್ ಸ್ಟಾರ್ಟ್ ಕೂಡ ಮಾಡ್ಬೋದು. Engine, for example, if you have to use the fuel cell, right, especially in the -degree centigrade, the electrical vehicle is under the -degree centigrade, you can go for the cold start, especially in the where there is a temperature is very less, okay. ಎಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಕಡಿಮೆ ಇರುತ್ತೆ ಅಲ್ಲಿ ನೀವು ಶಿಮ್ಲಾ, ಜಮ್ಮು ಕಾಶ್ಮೀರ, ಅಲ್ಲೂ ಕೂಡ ನೀವು ವೆಹಿಕಲ್ ಇಫ್ ಇಟ್ ಟೇಕಲ್ ಓವರ್ ದೇರ್ ನೋ, ದೆನ್ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ದ ಫ್ಯೂಯಲ್ ಸೆಲ್ಸ್, ಓಕೆ. ಫ್ಯೂಯಲ್ ಸೆಲ್ಸ್ನ ಯೂಸ್ ಮಾಡಿಬಿಟ್ಟು ನೀವು ಕೋಲ್ಡ್ ಸ್ಟಾರ್ಟ್ನ ಕೂಡ ಮಾಡ್ಬೋದು. ಲೋ ಟೆಂಪರೇಚರ್ ಆಪರೇಷನ್ ಎನೇಬಲ್ ದ ಸ್ಟಾರ್ಟ್ಅಪ್ ಈಸ್ ಇನ್ ಸೆಕೆಂಡ್ಸ್. ಟೆಂಪರೇಚರ್ -ಡಿಗ್ರಿಯಲ್ಲಿ ಇದ್ರೂ ಕೂಡ ನೀವು ಫ್ಯೂಯಲ್ ಸೆಲ್ ಯೂಸ್ ಮಾಡಿದ್ದೀರ ಅಂದರೆ ವೆಹಿಕಲ್ ಬೇಗ ಇಗ್ನೈಟ್ ಆಗುತ್ತೆ and it will start immediately, okay. So that is what it is used in the fuels are used in the automotive and the portable applications, okay. Portable applications are where it is we want to make the quick start, okay. So and also it is used in high power densities, right. Compact and lightweight design, the power densities among the highest of any fuel cell type. If we compare with the other fuel cells, right, voltage also very less, and also there is a light in weight. If you see the cell structure and also the cell weight, it will be very lightweight in designs, okay. When you talk about the efficiency, it will be comes to be around 50% of a maximum voltage, right. So that is what you cannot get the more efficiency, right, as compared with the other cells, okay. Next, if you see the constraints, what are the constraints? That is impurities, that is the poisons that is going to perform, right. So one thing is that when you talk about the catalyst, so catalyst ಅನ್ನೋದು ನಾವು ಯಾವಾಗ ಮಾತಾಡಿದ್ವಿ, ಯಾವ catalyst ಯೂಸ್ ಮಾಡ್ತೀವಿ for making the reaction to be more faster? Platinum, isn't it? So if you see the what do you say, for example, I'll give the example why it is more poisons, okay. I hope you are understanding the classes. Are you following now? Mamta, Sneha?
Yes, sir.
So we'll understand why this is very more poisonous, right, your fuel cells, right. If you see, for example, if you take the amaranth batteries, right, so which is around it may be a lithium or if you say the lead acid batteries, right. So ಏನಾಗುತ್ತೆ, ಕಂಪ್ನಿಲಿ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರಿಂಗ್ ಅಲ್ಲಿ ಕಂಪ್ನಿಲಿ ನೀವು ಕೆಲಸಕ್ಕೆ ಹೋದ್ರಿ ಅಂದ್ರೆ, so usually you have to work for the battery technologies, right. So battery technology, lead ಆಗಿರ್ಬೋದು. For example, if you take the lead, okay, so if you are using the lead to create in the batteries, so lead is also very poisonous, okay. So adina gases ಏನಾಗುತ್ತೆ during the inhale ಮಾಡಿದಾಗ, if you make in the industries, when you work in the industries, so lead is also very toxic in nature. 40 ಏಜ್ ಆಗಿದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ, ಅದನ್ನ ಇನ್ಹೇಲ್ ಮಾಡ್ತಾ ನಿಮ್ಮ ಲಂಗ್ಸ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, try to not to get you will feel more suffocations, ಉಸಿರಾಡಕ್ಕಾಗಲ್ಲ, yes sir, because that side is very toxic. So I've just given the example to understand why it is more poisonous, right. So that is what the lead acid batteries ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, ನಿಮಗೆ lead when you start inhaling that materials, no, that is what in the form of gaseous materials, okay. So ಏನಾಗುತ್ತೆ ನಿಮಗೆ, it will try to inhale, ನಿಮಗೆ inhale ಆದಾಗ ಅದು ಏನಾಗುತ್ತೆ, ಬಾಡಿ ಒಳಗಡೆ ಹೋಗುತ್ತೆ. So that will try to not to give the proper lungs ಅಲ್ಲಿ operations, lungs ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ನಿಮಗೆ ಸರಿಯಾಗಿ ಆಪರೇಟ್ ಆಗೋದಿಲ್ಲ ಅದು, right. You cannot make the inhale or exhale, ಉಸಿರಾಡಕ್ಕೆ ತುಂಬಾ ತೊಂದರೆ ಆಗುತ್ತೆ ಯಾವಾಗ ಒಂದು 40-45 ಏಜ್ ಆದಾಗ, okay. So these are the problems we are facing. That's why some materials are poisonous, and also you cannot ಅಂತ ಬ್ಯಾಟ್ರಿನ ನೀವು ಲಿಥಿಯಂ ಆಗಿರ್ಬೋದು, ಲೆಡ್ ಆಸಿಡ್ ಬ್ಯಾಟ್ರಿ ಆಗಿರ್ಬೋದು, ಎಲ್ಲಿ ಬೇಕಂಗೆ ಎಸೆಯಕ್ಕಾಗಲ್ಲ. If somebody takes if they eat that material, lead, they will die, or it is very poisonous also, it is very toxic in nature. ಅದನ್ನ ಎಲ್ಲಿ ಬೇಕಂಗೆ ಎಸೆಯಕ್ಕಾಗಲ್ಲ, ಓಕೆ. ನೀವೇನು ಮಾಡಬೇಕು, ಸಮುದ್ರ ಒಳಗಡೆ ಹೋಗ್ಬೋದು, ಇನ್ ಡೆಪ್ತ್, ಬೇರೆ ದೇರ್ ಇಸ್ ಡೆಪ್ತ್, ಯು ಶುಡ್ ಗೋ ಕೀಪ್ ಇನ್ಸೈಡ್ ದಿ ಅರ್ತ್, ಓಕೆ. ಅದಕ್ಕೆ ನಾವು ಅದನ್ನು ಡಿಸ್ಪೋಸ್ ಮಾಡುವಾಗ ಶುಡ್ ಬಿ ವೆರಿ ಕೇರ್ಫುಲ್, ರೈಟ್. ಸೊ ದೀಸ್ ಆರ್ ದ ಥಿಂಗ್ಸ್ ವಿಲ್ ವಿ ಫೈಂಡ್ ದ ಮೋರ್ toxic in nature, right. So if you see the carbon monoxide, right, carbon monoxide is binds strongly to the platinum catalyst, okay. So during the catalyst ನಾವು ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂದರೆ to make the reaction to be more faster, right? So blocking active sites reduce the output significantly, even parts per millions, that is ppm, what we talk about the parts per million, right? So level causes severe damage, right? The carbon monoxide ಇಂದ ಕೂಡ ಏನಾಗುತ್ತೆ, it is more poisonous. So when you inhale the carbon monoxide or carbon dioxide, ನಿಮ್ಮ ವೆಹಿಕಲ್ ಇಂದ ಏನು ಬರುತ್ತೆ ಅದನ್ನು ಇನ್ಹೇಲ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಲಂಗ್ಸ್ ಒಳಗಡೆ ಉಸಿರಾಟಕ್ಕೆ ತೊಂದರೆ ಆಗುತ್ತೆ. ಸರ್ ನಮಗೆ ಆಕ್ಸಿಜನ್ ಮಾತ್ರ ಬೇಕು ಹೊರತು ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ತಗೊಳ್ಳೋಕೆ ವಿ ಆರ್ ನಾಟ್ ದ ಪ್ಲಾಂಟ್ಸ್ ಟು ರಿಲೀಸ್ ಬ್ಯಾಕ್ ಟು ದ ಆಕ್ಸಿಜನ್ ಟು ದ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ಸ್, ರೈಟ್? ವಿ ರಿಕ್ವೈರ್ಡ್ ಓನ್ಲಿ ದ ಆಕ್ಸಿಜನ್. ಸೊ ಅದಕ್ಕೆ ನಾವು ಇದನ್ನೆಲ್ಲ ಇನ್ಹೇಲ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ದಿಸ್ ವಿಲ್ ಟ್ರೈ ಟು ವೆನ್ ದಿಸ್ platinum reacts with this carbon monoxide, it will try to produce the the reaction will be more faster, and also it will try to produce a toxic in nature, right? So those things we should not be happen, right? So ಅದಕ್ಕೆ ನಾವು ಇದನ್ನ ಕ್ಲಿಯರ್ ಆಗಿ ತೋರಿಸಿದೀವಿ. ಕಾರ್ಬನ್ ಮತ್ತೆ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ when it react with the platinum just like a catalyst, it will try to improve the reaction to be more faster. Okay, so if you see the platinum group metals, right, catalysts are extremely expensive it is expensive, right? It is very costlier. Platinum is very costlier. ಅದಕ್ಕೆ ನಾವು ಫ್ಯೂಯಲ್ ಸೆಲ್ ನ ಯಾಕೆ ನಾವು ವೆಹಿಕಲ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡಲ್ಲ ಅಂದ್ರೆ the cost is very high. ಅದಕ್ಕೆ ನಾವು ಲಿಥಿಯಂ ಬ್ಯಾಟರೀಸ್ನ ಯೂಸ್ ಮಾಡೋದು. ಫ್ಯೂಯಲ್ ಸೆಲ್ ಯಾಕೆ ಯೂಸ್ ಮಾಡಲ್ಲ ಅಂದ್ರೆ ಅಲ್ಲಿ ಫ್ಯೂಯಲ್ ಸೆಲ್ ಆಗಿರ್ಬೋದು, ಅಲ್ಟ್ರಾ ಕೆಪಾಸಿಟರ್ಸ್ ಆಗಿರ್ಬೋದು, ದೀಸ್ ಆರ್ ವೆರಿ ಕಾಸ್ಟ್ಲಿಯರ್ ಆಸ್ ಕಂಪೇರ್ ವಿತ್ ದ ಅದರ್ ವಾಟ್ ಇಸ್ ಬ್ಯಾಟರೀಸ್. These are very costlier, right? So they are more expensive also, right? And the supply constraints which drives up the entire system cost. Platinum ನೀವು ಸಪ್ಲೈ ಮಾಡೋದು ತುಂಬಾ ಕಷ್ಟನೇ. Okay, it is very difficult. You cannot supply whenever it is required, right? So that's why because of the cost only, the fuel cell has got very good name in the EV vehicles. Okay, ಅದಕ್ಕೆ fuel cells ಎಲ್ಲರೂ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. And also we have the lot of vehicles in the Delhi also, Gurgaon ಬಂದಿದೆ, right? Some Nexon companies, right? I think the Nexon companies, they have introduced the fuel cells, right? So that is what the fuel cell has, will try to have the catalyst, and it will try to improve the reaction to be more and more faster, right? That's why the platinum catalysts are also expensive and supply constraints. ನಾವೆಲ್ಲ ಟೈಮಲ್ಲಿ ಸಪ್ಲೈ ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಮೇಕಿಂಗ್ ದ ಕಾಸ್ಟ್ ರಿಡಕ್ಷನ್ ಇನ್ ಕ್ರಿಟಿಕಲ್ ಫಾರ್ ದಿ R&D priority. ರೈಟ್, ನಿಮಗೆ ಸಪ್ಲೈ ಮಾಡಿದ್ದೀವಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ದ catalyst it works, right, the project is successful, right, and also it will try to make the very critical things in the research and development priority. You have to check about the priority conditions also, right? And also there is a PMC has a lot of demand for very pure hydrogen. Okay, hydrogen ಕೂಡ ಸಪ್ಲೈ ಮಾಡಬೇಕು, ಮತ್ತೆ ಇಲ್ಲಿ catalyst ಕೂಡ ಸಪ್ಲೈ ಮಾಡಬೇಕು ನಾವು. See, there are a lot of difficulties we are facing, right, which is not a negotiable, right? ನೆಗೋಷಿಯಬಲ್ ಆದರೆ ಓಕೆ, ಇಟ್ ಇಸ್ ನಾನ್ ನೆಗೋಷಿಯಬಲ್. ಇದನ್ನು ಬೇಕು, catalyst ಬೇಕು, ಇದನ್ನು ಬೇಕು, ನಮ್ಗೆ ಎರಡು ಬೇಕಾಗುತ್ತೆ. ಯಾಕಂದ್ರೆ we have to produce electricity. You cannot negotiate this one, hydrogen. You cannot negotiate the catalyst. So both are required. So both will try to combine, right? And it will try to produce the electricity. So right, so if you see in the earlier stage, right, there are many research has been undergone, right, in the different in the laboratories, right? If you see in Chicago, right, in Chicago also they have used the Ballard tested proton exchange member fuel cells in transit buses, right, in the Chicago transit, that is in the year 1995. If you see in the 2000, NASA also they used the for your Vernoments selected PMC for the night time for the power in the solar powered Helios aircraft ಅಲ್ಲೆಲ್ಲ ಕೂಡ ಇದನ್ನ fuel cells ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. And also late 90s also it has been used in the various your vehicles. Experimental ಕೂಡ ಮಾಡಿದ್ದಾರೆ. Technology brought to the road also. Not only in 1990s, ಇವಾಗಲೂ ಕೂಡ if you saw in the Delhi, if you go in the Gurgaon, most of the vehicles are they take the from the fuels, they'll run from the fuel cells only. Okay, so that's why if you talk about the commercial today, commercial scale is also because of the power vehicles and also backup systems for the grid ಅಷ್ಟೇ backup system ಬೇಕು ಅಂದ್ರೆ ಕೂಡ fuel cells ಯೂಸ್ ಮಾಡ್ತೀವಿ. vehicles power ಜಾಸ್ತಿ ಡ್ರೈವ್ ಮಾಡೋಕ್ಕೂ ಕೂಡ ನಾವು fuel cell ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ, right? So wherever it is installed in the most of the stationary across the world. Okay, so why? Because ಯಾಕೆ ನಾವು ಅದನ್ನ fuel cell ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ತೀವಿ? Because it is very clean and keeps it more greenery. Okay, and also if you talk about the cost, right, purity is good. If the talk about the cost is also very high. So that is what you have to think about the what all the things can be happen if you use this fuel cells, right? So fuel cells is also very good for the your electric vehicles, for the grid also, right? For the grid ಗೂ ಕೂಡ ನಾವು ಇದನ್ನ ಯೂಸ್ ಮಾಡಬಹುದು, vehicles ಗೂ ಕೂಡ ಯೂಸ್ ಮಾಡಬಹುದು. Almost most of the countries in Canada ಆಗಿರಬಹುದು, also in the other countries also, right? In India also, if you see in the Delhi and Gurgaon also, most of the vehicles are run on the fuel cells only. Okay, so if you see the design and the cost. 1 minute. Okay, are you following now, Mamta and Sneha?
Yes, sir.
Okay, so this is about the very right from the scratch we have understood the how the fuel cells will try to work and what are its various constraints we have been discussed, isn't it? See, the designs for the lower cost membranes and the catalyst, right, becomes the mainstream for the clean and power options. We have to think about more on the membrane also, right? The type of the membranes we have used over here. Uh, it is what the membranes we are using. Nephron, right? Nephron is a membrane electrolyte to solid polymers we are going to use for the membrane to get the superpower. Okay, now let us see our basics study, right? We'll understand the basic concept of the fuel cell, right? Fuel cell operates like a battery, okay, but is not unlike batteries. ಬ್ಯಾಟ್ರಿ ಥರ ಅಲ್ಲ, ಬ್ಯಾಟ್ರಿ ಥರ ಕೆಲಸ ಮಾಡುತ್ತೆ, ಬಟ್ ಅದನ್ನ ಬ್ಯಾಟ್ರಿ ಅಂತ ನಾವು ಹೇಳೋಕ್ಕಾಗಲ್ಲ, ರೈಟ್? ಬ್ಯಾಟ್ರಿ ಹೆಂಗೆ ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ, ಇದು ಸ್ಟೋರ್ ಮಾಡಲ್ಲ. ದಟ್ ಈಸ್ ವಾಟ್ ದಿ ಮೇಜರ್ ಡಿಫ್ರೆನ್ಸಸ್ ಯು ಹ್ಯಾವ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಓಕೆ, ಪ್ಲೀಸ್ ಗೋ ಥ್ರೂ ದ ಸ್ಲೈಡ್ಸ್. ಓಕೆ, ನಾನು ಏನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಿದ್ದೀನಿ, ಟ್ರೈ ಟು ಅನಲೈಸ್ ದ ಸ್ಲೈಡ್ಸ್. ಓಕೆ, fuel cell operates like a batteries, right? It is not similar to the batteries, right? It is just like a batteries, just like a batteries, but it will not store. ಹೆಂಗೆ ಬ್ಯಾಟ್ರಿ ನಿಮಗೆ ಚಾರ್ಜಿಂಗ್ ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಆಗುತ್ತೆ, ಸ್ಟೋರಿಂಗ್ ಫಾರ್ ಮೆನಿ ಅವರ್ಸ್ ಅಂಡ್ ಚಾರ್ಜಿಂಗ್ ಫಾರ್ ಮೆನಿ ಅವರ್ಸ್, ಆ ಥರ ಇಲ್ಲ. ಫ್ಯೂಯಲ್ ಸೆಲ್ ಯಾಕೆ ಇನ್ಸ್ಟೆಂಟ್, ಫ್ಯೂಯಲ್ ಕೊಡಿ ಜನರೇಷನ್ ಮಾಡು, ಫ್ಯೂಯಲ್ ಸ್ಟಾಪ್ ಮಾಡಿ ನೋ ಜನರೇಷನ್ಸ್. ಸೊ ದಟ್ ಈಸ್ ಹೌ ದಿ ಫ್ಯೂಯಲ್ ಸೆಲ್ ವಿಲ್ ವರ್ಕ್. ಓಕೆ, ಸೊ ಫ್ಯೂಯಲ್ ಸೆಲ್ ಈಸ್ ಅನ್ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ಸೆಲ್ಸ್ ದಟ್ ಕನ್ವರ್ಟ್ಸ್ ದಿ ಕೆಮಿಕಲ್ ಎನರ್ಜಿ ಆಫ್ ಫ್ಯೂಯಲ್ಸ್. ಯಾವ್ಯಾವ ಕೆಮಿಕಲ್ ಎನರ್ಜೀಸ್ ಇದಾವೆ ನಮ್ಮ ಹತ್ರ? ಗ್ಯಾಸ್. ವಾಟ್ ಈಸ್ ದ ಗ್ಯಾಸ್ ಯು ಆರ್ ಪ್ರೊವೈಡಿಂಗ್? What liquid you are providing? Hydrogen and gas. That is what kind of hydrogen and things you are providing. What are the things, the agents you are providing for across the anode, and across the oxidizing agent is nothing but the oxygen across the cathode. ನೋಡಿ ಯಾವ್ಯಾವ ಇದಾವೆ ನಮ್ಮ ಹತ್ರ ಫ್ಯೂಯಲ್ಸ್. ಇಲ್ಲಿ ನಾವೇನು ತಗೊಂಡಿದ್ದೀವಿ? ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ತಗೊಂಡಿದ್ದೀವಿ. ಇಲ್ಲೇನು ತಗೊಂಡಿದ್ದೀವಿ? ಏಜೆಂಟ್ ಆಕ್ಸಿಜನ್ ತಗೊಂಡಿದ್ದೀವಿ. ಇಲ್ಲಿ ಗ್ಯಾಸ್ ಎಲ್ಲಿ ತಗೋಬೇಕು? ಹೈಡ್ರೋಜನ್ ಆನೋಡ್ ಹತ್ರ ತಗೋಬೇಕು, ಆನೋಡ್ ಹತ್ರ ಪಾಸ್ ಮಾಡಬೇಕು. ಆಕ್ಸಿಜನ್ ಎಲ್ಲಿ ಪಾಸ್ ಮಾಡಬೇಕು? ಕ್ಯಾಥೋಡ್ ಹತ್ರ ಪಾಸ್. ದೀಸ್ ಆರ್ 2 ಎಲೆಕ್ಟ್ರೋಡ್ಸ್. ಎರಡು ಎಲೆಕ್ಟ್ರೋಡ್ ಹತ್ರ ನಾವೇನು ಮಾಡಿದೀವಿ? ಒಂದು ಕಡೆ ಹೈಡ್ರೋಜನ್ ಪಾಸ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಇನ್ನೊಂದು ಕಡೆ ಆಕ್ಸಿಜನ್ ಪಾಸ್ ಮಾಡ್ತೀವಿ. ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಮೇಕ್ ದ ಕೆಮಿಕಲ್ ಎನರ್ಜಿ ವಿಲ್ ಬಿ ಕನ್ವರ್ಟೆಡ್, ನಥಿಂಗ್ ಬಟ್ ದಿ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್. ದಟ್ ಈಸ್ ವಾಟ್ ವಿ ಸ್ಟಡಿ ಇನ್ ದ ಅರ್ಲಿಯರ್ ಕೇಸಸ್, ಅಂಡ್ ಇಟ್ ಇಲ್ಲಿ ನೋಡಿ, ದೀಸ್ ಆರ್ ದಿ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್. ರೈಟ್, ನೋಡಿ ಆನೋಡ್ ಹತ್ರ ಏನಾಗ್ತಿದೆ ರಿಯಾಕ್ಷನ್? ಹೈಡ್ರೋಜನ್ ಬರ್ತಾ ಇದೆ, ಕರೆಕ್ಟ್. ಕ್ಯಾಥೋಡ್ ಹತ್ರ ಏನು ಬರ್ತಾ ಇದೆ? ಆಕ್ಸಿಜನ್ ಬರ್ತಾ ಇದೆ. ಸೊ ದಿಸ್ ಈಸ್ ಆಕ್ಚುಲಿ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಇಟ್ ಈಸ್ ಹ್ಯಾಪನಿಂಗ್. ಓಕೆ, so now see, that is what liquids have use ಮಾಡಬಹುದು ನೀವು. You can use the different types of the liquids fuels, right? If you want to have the gaseous, that is hydrogen use ಮಾಡಬಹುದು. ಇಲ್ಲಾಂದ್ರೆ ಲಿಕ್ವಿಡ್ ಹೈಡ್ರೋಜನ್ ಒಂದು ಯೂಸ್ ಮಾಡಬೇಕಂತೇನಿಲ್ಲ. You can use any kind of the fuels. Okay, methanol use ಮಾಡಬಹುದು, that is CH3 ethanol use ಮಾಡಬಹುದು, right? You can use hydrazines, formaldehyde ಕೂಡ ಯೂಸ್ ಮಾಡಬಹುದು. Gaseous fuels you can go for the hydrogen. That is what I am talking about, the hydrogen. Okay, liquid use ಮಾಡಬಹುದು, only hydrogen use ಮಾಡಬೇಕಂತೇನಿಲ್ಲ. gaseous fuels you can use for the hydrogen also, and you can use the carbon monoxide also. So these are the gaseous fuels. Okay, now let us go with the differences. Is that clear? Fuel cell, Mamta, Sneha?
Yes, sir.
Fuel cell is not like a batteries. Okay, it is
But
similar
sir,
to
yes, sir.
what ma?
Yes, sir. ಅರ್ಥ ಆಯ್ತು ಸರ್.
ಫ್ಯೂಯಲ್ ಸೆಲ್ ನ ಬ್ಯಾಟ್ರಿ ಅಂತ ಅನ್ಕೊಳ್ಳೋಕೆ ಹೋಗ್ಬೇಡಿ. ಬ್ಯಾಟ್ರಿ ತರಾನೇ ಅದು, ಬಟ್ ಬ್ಯಾಟ್ರಿ ತರಾನೇ ಕೆಲಸ ಮಾಡುತ್ತೆ, ಸ್ಟೋರ್ ಮಾಡಲ್ಲ ಅಷ್ಟೇ.
ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಸ್ಟೋರ್ ಮಾಡಲ್ಲ,
ಅದು ಇನ್ಸ್ಟೆಂಟ್ ಅಷ್ಟೇ. ಅದು ಯಾವಾಗ ಬೇಕೋ ಅವಾಗ ಮಾತ್ರ ನಿಮಗೆ ಜನರೇಷನ್ ಮಾಡಿ ಕೊಡುತ್ತೆ. ಫ್ಯೂಯಲ್ ಯಾವಾಗವರೆಗೂ ಕಳಿಸ್ತಾ ಇರ್ತಾರೆ ಅವಾಗ ಮಾತ್ರ ಜನರೇಷನ್ ಮಾಡುತ್ತೆ, ಇಲ್ಲಾಂದ್ರೆ ಸ್ಟಾಪ್ ಮಾಡಿಬಿಡುತ್ತೆ. ಅಗೇನ್ ದ ಎಕ್ಸಾಂಪಲ್, ಯು ರಿಮೆಂಬರ್ ದಟ್ ಬೇಸಿಕ್ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ಯುವರ್ ವೆಹಿಕಲ್, ರೈಟ್? ಪೆಟ್ರೋಲ್ ಹಾಕಿದ್ರೆ ಮಾತ್ರ ವೆಹಿಕಲ್ ಓಡುತ್ತೆ, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಪೆಟ್ರೋಲ್ ಖಾಲಿ ಆದರೆ ವೆಹಿಕಲ್ ಓಡಲ್ಲ. ಅದೇ ಥರ ಫ್ಯೂಯಲ್, ಅದಕ್ಕೆ ಫ್ಯೂಯಲ್ ಬೇಕು. ಅಲ್ಲಿ ಹಿಂಗೆ ನೀವು ಪೆಟ್ರೋಲ್ ಫ್ಯೂಯಲ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀರಾ, ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಮತ್ತು ನಾವು ಆಕ್ಸಿಜನ್ ಫ್ಯೂಯಲ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಯಾವಾಗವರೆಗೂ ನೀವು ಹೈಡ್ರೋಜನ್ ಆಕ್ಸಿಜನ್ ಪಾಸ್ ಮಾಡ್ತೀರಾ ಅಲ್ಲಿವರೆಗೆ ಮಾತ್ರ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ. ಯಾವಾಗ ಸ್ಟಾಪ್ ಮಾಡ್ತೀರಾ ಅದು ಕೂಡ ಸ್ಟಾಪ್ ಆಗಿಬಿಡುತ್ತೆ. ಅಂದರೆ ಇಲ್ಲಿ ಸ್ಟೋರೇಜ್ ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟೇ ಬರಲಿಲ್ಲಲ್ಲ, ಬಟ್ ಬ್ಯಾಟ್ರಿ ಥರನೇ ಆಪ್ರೇಟ್ ಆಗುತ್ತೆ. ಓಕೆ, ಇಟ್ ಈಸ್ ನಾಟ್ ಸಿಮಿಲರ್ ಟು ದ ಬ್ಯಾಟ್ರೀಸ್, ಇಟ್ ಈಸ್ ಅನ್ಲೈಕ್ ಟು ಎ ಬ್ಯಾಟ್ರೀಸ್, ಬಟ್ ಆಪ್ರೇಟ್ಸ್ ಲೈಕ್ ಎ ಬ್ಯಾಟ್ರೀಸ್. ಪ್ಲೀಸ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ಫಸ್ಟ್ ಲೈನಲ್ಲಿ ನಾನು ಏನು ಹೇಳಿದ್ದೀನಿ, ಇಟ್ ಈಸ್ ಅನ್ಲೈಕ್ ಎ ಬ್ಯಾಟ್ರೀಸ್, ಕರೆಕ್ಟ್? It is very clear, you can understand the line, it is very clear. It is unlike a batteries. Not a battery thara alla, okay, but it is just work like a batteries. ನೀವು ಬ್ಯಾಟ್ರಿ ಥರ ಅಂದರೆ ಏನು? ಸ್ಟೋರೇಜ್ ಮಾಡಲ್ಲ, ಕೆಲಸ ಬ್ಯಾಟ್ರಿ ಥರನೇ ಕೆಲಸ ಮಾಡುತ್ತೆ, ಬಟ್ ಸ್ಟೋರೇಜ್ ಮಾಡಲ್ಲ. ದಟ್ಸ್ ವಾಟ್ ಈಸ್ ಅನ್ಲೈಕ್. ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಲೈಕ್ ಟು ದ ಬ್ಯಾಟ್ರೀಸ್, ಇಟ್ಸ್ ವರ್ಕಿಂಗ್ ಈಸ್ ಜಸ್ಟ್ ಲೈಕ್ ಟು ದ ಬ್ಯಾಟ್ರೀಸ್. ಬಟ್ ಸ್ಟೋರೇಜ್ ಅಂತ ಬಂದಾಗ ನಾವು ಬ್ಯಾಟ್ರೀಸ್ ಇದು ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. right? Battery ತರ ಕೆಲಸ ಮಾಡುತ್ತೆ, it is working like a batteries, but it doesn't store the energy. ಓಕೆ, ಹೆಂಗೆ ಲಿಥಿಯಂ ಬ್ಯಾಟ್ರಿ ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ, ಸ್ಟೋರ್ ಮಾಡಿ ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡ್ತೀರಾ, 5 hours ಸ್ಟೋರ್ ಮಾಡೋಕ್ಕೆ ಬೇಕು, ಇನ್ನು 3 hours ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡೋಕ್ಕೆ ಬೇಕು, ಆ ಥರ ಇಲ್ಲ. ಇದು ಫ್ರೀಕ್ವೆಂಟ್ ಆಗಿ ಯಾವಾಗ ನೀವು ಸಪ್ಲೈ ಮಾಡ್ತೀರಾ ಫ್ಯೂಯಲ್ಸ್ನ, ಹೈಡ್ರೋಜನ್, ಆಕ್ಸಿಜನ್ ಆರ್ ಲಿಕ್ವಿಡ್ ಫ್ಯೂಯಲ್ಸ್ ಆರ್ ಗ್ಯಾಸಿಯಸ್ ಫ್ಯೂಯಲ್ಸ್ ಸಪ್ಲೈ ಮಾಡ್ತೀರಾ, ಅವಾಗ ಮಾತ್ರ ಇದು ಎಲೆಕ್ಟ್ರಿಸಿಟಿನ ಜನರೇಷನ್ ಮಾಡೋಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಸೊ ದಟ್ಸ್ ವೈ ದೇರ್ ಇಸ್ ಎ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ವಿಲ್ ಹ್ಯಾಪನ್, isn't it? So that is because of the catalyst. Okay, because of the catalyst in the your fuel cells, the reaction is become the more and more faster. Right, what are the agents we have to use? Across the cathode you have to use the oxygen. Air andre ಏನು oxygen use ಮಾಡಬೇಕು. Okay, liquid andre ಯಾವ್ದು ಯೂಸ್ ಮಾಡ್ಬೋದು ನೀವು? You can use the methanol, ethanol and hydrogens or formaldehyde use ಮಾಡ್ಬೋದು. Okay, and also if you want to use the gaseous, then you go for the hydrogen or carbon monoxide. So these are the agents. So ಈ ತರ ನೀವು ಏನು ಮಾಡಬೇಕು, fuel agent ನ ಯೂಸ್ ಮಾಡಬೇಕು for to generation the electricity. Okay, so through the pair of redox reactions. Okay, so what is the meaning of redox? There is a reduction and oxidations. ನೋಡಿ, ಎರಡು ವರ್ಣ ಕಂಬೈನ್ ಮಾಡಿದ್ದಾರೆ. It is very beautiful to understand. Redox reaction ಆಗುತ್ತಂತೆ, right? We call this chemical energy into electrical energy conversion ಆಗುವಾಗ what actually with the help of the catalyst, that is a platinum catalyst, that is a the platinum catalyst material chain use ಮಾಡಿದ್ದೀರಾ, because of that there is a reduction. R stand for the reduction, right? RED stand for reduction. OX stand for the oxidations. Correct? ನೋಡಿ, ರಿಡಕ್ಷನ್ ಅಂದ್ರೆ ಏನು, ಆಕ್ಸಿಡೇಷನ್ಸ್ ಅಂದ್ರೆ ಏನೋ, ಇಟ್ ಈಸ್ ವೆರಿ ಬ್ಯೂಟಿಫುಲ್ ವರ್ಡ್ಸ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಅವರ್ ಕಾನ್ಸೆಪ್ಟ್ ವಿಚ್ ಮೇಕ್ಸ್ ವೆರಿ ಕ್ಲಿಯರ್ಲಿ. ಅದಕ್ಕೆ ರೆಡಾಕ್ಸ್ ರಿಯಾಕ್ಷನ್ಸ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಇಲ್ಲಿ ರಿಡಕ್ಷನ್ಸ್ ಏನಾಗ್ತಿದೆ ನಿಮಗೆ, ವಾಟ್ ಇಸ್ ರಿಡಕ್ಷನ್ ಇಟ್ ಈಸ್ ಹ್ಯಾಪನಿಂಗ್? ಇಫ್ ಯು ಸಿ ದಿಸ್ ಅಕ್ರಾಸ್ ದಿ ಆ್ಯನೋಡ್ ಹತ್ರ ನೋಡಿ ಏನಾಗ್ತಿದೆ, ವಾಟ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್ ಅಕ್ರಾಸ್ ದಿ ಆ್ಯನೋಡ್? ಹೈಡ್ರೋಜನ್ ಇದೆ ತಾನೆ, ಹೈಡ್ರೋಜನ್ H2, right? There is a production of the ions, that is across the protons. This is called your protons. Okay, and also the electrons is getting released. Yes or not? So this is of the reduction. There is a reduction in this hydrogen. Hydrogen ಅಲ್ಲಿ ಏನಾಗ್ತಿದೆ, ಹೈಡ್ರೋಜನ್ ಅಯಾನ್ಸ್ ನ ತೆಗಿತಾ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ತೆಗಿತಾ ಇದೆ ಹೈಡ್ರೋಜನ್ ಅಲ್ಲಿ ಇರೋದು, ಪ್ಲಸ್ ಅಯಾನ್ಸ್ ಅದೇನಾಗ್ತಿದೆ ಪ್ರೋಟಾನ್ಸ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ತಾ ಇದೆ. ಹೈಡ್ರೋಜನ್ ಇದ್ದಿದ್ದು ಪ್ರೋಟಾನ್ಸ್ ಅಯಾನ್ಸ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಇದೆ, ಪ್ಲಸ್ ರಿಲೀಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ದಟ್ ಈಸ್ ದೇರ್ ಇಸ್ ಎ ಹೈಡ್ರೋಜನ್ ಒಳಗಡೆ ಇತ್ತು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಯು ಹ್ಯಾವ್ 100 rupees, ರೈಟ್? ಇಫ್ ಯು ಆಸ್ 50 rupees, ನೋ, ಎಷ್ಟು ರಿಡಕ್ಷನ್ ಆಯ್ತು ಹಂಗಿರೋ ನಿಮ್ಮ ಹತ್ರ 50 rupees ಉಳಿತು. ಕರೆಕ್ಟ್ ಅಲ್ಲ? 50 rupees ನನಗೆ ಲೆಂಡ್ ಮಾಡಿದ್ರೆ ಮೀನ್ಸ್ ಯು ಆರ್ ಗಿವಿಂಗ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. 50 rupees nothing but electrons give, you are giving electrons for me, isn't it? And also there is a phenomenon which is happening where it is going to be having the hydrogen protons, right? That is a 2H plus. That's why it is called a reduction. That is called the reduction ಆಗ್ತಾ ಇದೆ. ಇಲ್ಲ ಎಲ್ಲಿ ಆನೋಡ್ ಹತ್ರ ರಿಡಕ್ಷನ್ ಆಗ್ತಾ ಇದೆ. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಅಲ್ಲಿರೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಿದೆ ಅಲ್ವಾ, ನೆನ್ನೆ ಕೂಡ ನಾನು ಹೇಳಿದ್ದೀನಿ, ಇಫ್ ಯು ಟೇಕ್ ವುಡ್ ಆಲ್ಸೋ ಅಲ್ಲೂ ಕೂಡ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. ಓಕೆ, ಇಫ್ ಯು ಟೇಕ್ ದ ಮೆಟಲ್ ಆಲ್ಸೋ ಅಲ್ಲೂ ಕೂಡ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. ನಿಮ್ಮ ಬಾಡಿಯಲ್ಲೂ ಕೂಡ ಅಯಾನ್ಸ್ ಇದಾವೆ. ಓಕೆ ಸರ್, ವಿ ಹ್ಯಾವ್ ದ ಐರನ್ ಕಂಟೆಂಟ್ ಇನ್ ಯುವರ್ ಬಾಡೀಸ್. ಕರೆಕ್ಟ್? ಅದಕ್ಕೆ ನಿಮ್ಗೆ ಶಾಕ್ ಹೊಡಿಯುತ್ತೆ, ರೈಟ್? ನಮ್ಮಲ್ಲಿ ಆ ಥರ ಇಫ್ ಯು ಹ್ಯಾವ್ ದಟ್ ಆಟಮ್ಸ್ ಓನ್ಲಿ, ದೆನ್ ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಗೆಟ್ ದಿ ಸಿವಿಯರ್ ಶಾಕ್. ಅದಕ್ಕೆ ಹೈಡ್ರೋಜನ್ ಅಲ್ಲೂ ಕೂಡ ಏನಿರುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತಾವೆ. ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಯು ಹ್ಯಾವ್ ಟು ಸ್ಟಡಿ ದ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಇಲ್ಲ ಇದನ್ನೆಲ್ಲ ನೀವು ಓದಾಗ ಅರ್ಥ ಆಗುತ್ತೆ. ಯು ವುಡ್ ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್ ಇನ್ ದ ಲೋವರ್ ಕ್ಲಾಸಸ್ ಆಲ್ಸೋ, ರೈಟ್? ಹೈಡ್ರೋಜನ್ ಇರೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗ್ತಿದೆ, ಅದು ಇಟ್ ಇಸ್ ಟ್ರೈಂಗ್ ಟು ರಿಲೀಸ್. ದಟ್ಸ್ ವಾಟ್ ಇಸ್ ಎ ರಿಡಕ್ಷನ್, ರೈಟ್? ಆ್ಯಂಡ್ ರಿಲೀಸ್ ಆಫ್ ಪ್ರೋಟಾನ್ಸ್ ಆಲ್ಸೋ. ನೋಡಿ, ಪ್ರೋಟಾನ್ಸ್ ಕೂಡ ರಿಲೀಸ್ ಆಗ್ತಾ ಇದೆ ಹೈಡ್ರೋಜನ್ ಇರೋದು, ಆ್ಯಂಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೂಡ ರಿಲೀಸ್ ಆಗ್ತದೆ. ಸರ್, ಯು ಹ್ಯಾವ್ ಟು ಅಗ್ರಿ ಫಾರ್ ದಿಸ್. ಹೈಡ್ರೋಜನ್ ಇರೋ ಏನಾಗ್ತದೆ, ಸ್ಪ್ಲಿಟ್ ಆಗ್ತಾ ಇದೆ. ಮುಂಚೆ ಏನಿತ್ತು, 100 ರೂಪಾಯಿ ಇತ್ತು ನಿಮ್ಮ ಹತ್ರ, 50 ರೂಪಾಯಿ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿದ್ರಿ. 50 rupees ನಿಮ್ಮ ಫ್ರೆಂಡಿಗೆ ಕೊಟ್ಟರೆ, ಇನ್ನು 50 rupees ನೀವು ಇಟ್ಕೊಂಡಿದ್ದೀರಾ. ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ದಿ ರಿಡಕ್ಷನ್. That is called reduction techniques. Okay, 100 rupees ittu ನಿಮ್ಮ ಹತ್ರ, ಎಷ್ಟು is nothing but 100 rupees. So in that you are going to reduce 50 rupees and 50 rupees. Correct? So that is called the reductions. That's what is called the RED. Okay, please understand RED. ಹೈಡ್ರೋಜನ್ ಇರೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ತೆಗಿತಾ ಇದೆ, ಅಯಾನ್ಸ್ ನ ಕೂಡ ರಿಲೀಸ್ ಮಾಡ್ತಾ ಇದೆ. Okay, so that's why that is a word called RED, reduction. Correct? ಅದಕ್ಕೆ ರಿಡಕ್ಷನ್ ಅಂತ ಕರೀತಾರೆ. OX ಇದೆಯಲ್ಲ, OX ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಆಕ್ಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿ ಆಕ್ಸಿಡೇಷನ್ಸ್. ನೋಡಿ, ಆಕ್ಸಿಡೇಷನ್ಸ್ ಎಲ್ಲಾಗ್ತಾ ಇದೆ, if you see across the your cathode ಹತ್ರ ನೋಡಿ, if you see across the cathode ನೋಡಿ, cathode ಹತ್ರ ಏನಾಗ್ತದೆ, ಆಕ್ಸಿಜನ್ ಯಾರ ಜೊತೆ ಕಂಬೈನ್ ಆಗ್ತಾ ಇದೆ, ಅದು ಆಲ್ರೆಡಿ ಅಯಾನ್ಸ್ ಏನಿದೆ, ದಟ್ ಇಸ್ ಪ್ರೋಟಾನ್ಸ್, H+ ಪ್ರೋಟಾನ್ಸ್ ಏನಿದೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿಲೀಸ್ ಆಗಿರ್ತಾರೆ. ಇವು ಮೂರು ಏನಾಗುತ್ತೆ, ಆಕ್ಸಿಡೇಷನ್ಸ್ ಆಗ್ತಾ ಇದೆ, ಕಂಬೈನಿಂಗ್ ವಿತ್ ಆಕ್ಸಿಜನ್ ಟು ಫಾರ್ಮ್ ದಿ ವಾಟರ್ ಆ್ಯಂಡ್ ಹೀಟ್. ಸೊ ದಟ್ಸ್ ವಾಟ್ ಇಸ್ ಆಕ್ಸಿಡೇಷನ್ಸ್ ಪ್ರಾಸೆಸ್. ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ, ಇಲ್ಲಿ ಆಕ್ಸಿಡೇಷನ್ಸ್ ಆಗ್ತಾ ಇದೆ. ಆಕ್ಸಿಡೇಷನ್ ಏನಾಗ್ತದೆ, ಆಕ್ಸಿಜನ್ ಇಸ್ ಗೆಟಿಂಗ್ ಕಂಬೈನಿಂಗ್ ವಿತ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ and the protons. It will try to release the waters. Okay, water will be sent in the across the cathode, right, in the bottom layers. So that's why it is oxidations. ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ ರಿಡಕ್ಷನ್ ಆಗ್ತಾ ಇದೆ ನೋಡಿ, ಆನೋಡ್ ಹತ್ರ ರಿಡಕ್ಷನ್ ಆಗ್ತಿದೆ, ಅಕ್ರಾಸ್ ಕ್ಯಾಥೋಡ್ ಹತ್ರ ಆಕ್ಸಿಡೇಷನ್ ಆಗುತ್ತೆ. ಸೊ ದಟ್ಸ್ ವೈ ಇಟ್ ಈಸ್ ನೇಮ್ಡ್ ಆಸ್ ಎ ರೆಡಾಕ್ಸ್. ರೆಡಾಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತಾರೆ, ಅದಕ್ಕೆ ರೆಡಾಕ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್ ನೌ? ಐ ಹೋಪ್ ಇಟ್ ಇಸ್ ಕ್ಲಿಯರ್ ಟು ಯು.
Yes, sir.
Okay, you can take the agents like this, methanol or tagabozo, or else you can take the ethanol also, you can take the formaldehyde also, you can take the hydrazine also, right? So these are the various agents. Okay, so I will not study the especially of this what is the atomic mass, molecular mass, okay, and what kind of the its energy densities, right? I will just understand the various basics of the how the fuel cells will work, right? ನಮಗೆ ಬೇಕಾಗಿರೋ fuel cells ಯಾವ್ದಾರ ಕೆಲಸ ಮಾಡುತ್ತೆ ಅನ್ನೋದು ಮಾತ್ರ will study, right? That is what we have in the syllabus, right? ಸೊ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ತಗೊಂಡಾಗ ಕೂಡ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ, ಈಥನಾಲ್ ಇಂದ ಕೂಡ ನಾವು ಏನು ಮಾಡೋದು, ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಕೂಡ ಜನರೇಷನ್ ಮಾಡ್ಬೋದು. ಸರ್ ನಾಟ್. ಸೊ ದಟ್ ಇಸ್ ವಾಟ್ C2H2 ಇಂದ ಆಲ್ಸೋ ಯು ಕ್ಯಾನ್ ಪ್ರೊಡ್ಯೂಸ್ ದ ಯುವರ್ ಹೈಡ್ರೋಜನ್, ರೈಟ್? ವಿ ಕ್ಯಾನ್ ಪ್ರೊಡ್ಯೂಸ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಫ್ರಮ್ ದಿ ethanol, right? The C2H2O, right? From also you can produce the your electricity, right? So ಅದೇ ತರ ನಾವು these are the various agents. Let us see the different types of the battery and the fuel cells, right? ಬ್ಯಾಟ್ರಿ ಫ್ಯೂಯಲ್ ಸೆಲ್ಗೆ ಏನು ಡಿಫ್ರೆನ್ಸ್ ಇದೆ, you can understand very clearly. ನೋಡಿ, ಬ್ಯಾಟ್ರಿ ಫ್ಯೂಯಲ್ ಸೆಲ್ಗೆ ಇಟ್ ಇಸ್ ದೇ ಹ್ಯಾವ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ವೆರಿ ಕ್ಲಿಯರ್. ಬ್ಯಾಟ್ರಿದಲ್ಲಿ ಇಲ್ಲಿ ನಿಮಗೆ ಇನ್ನೂ ಚೆನ್ನಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ ಬ್ಯಾಟ್ರಿಗೆ ಮತ್ತು ಫ್ಯೂಯಲ್ ಸೆಲ್ಗೆ ಏನು ಡಿಫ್ರೆನ್ಸ್ ಹೇಳಿದ್ರು ಸರ್ ಅನ್ನೋ. ಸೊ ಇಟ್ ಸೇವ್ಸ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ. ಓಕೆ, ಏನು ಮಾಡ್ತಾ ಇದ್ದು ಬ್ಯಾಟ್ರಿಯಲ್ಲಿ ಎನರ್ಜಿ ಸ್ಟೋರ್ ಮಾಡ್ತಾ ಇದೆ, ಸೇವ್ ಮಾಡ್ತಾ ಇದೆ. ಸೇವ್ ಮಾಡೋದು ಅಂದ್ರೇನು, ನೀವು ಉಳಿತಾಯ ಮಾಡಬೇಕು, ಸರ್ ನಾಟ್ ಸ್ಟೋರ್ ಮಾಡಬೇಕು, ರೈಟ್? 100 ರೂಪಾಯಿ ಇದೆ ಅಂದರೆ ಇನ್ನೂ 100 ರೂಪಾಯಿ ಯಾರಾದ್ರೂ ಇಸ್ಕೊಂಡ್ಬಿಟ್ಟು ನೀವು 200 ರೂಪಾಯಿ ಮಾಡಬೇಕು, ಆಮೇಲೆ 300, ನಥಿಂಗ್ ಬಟ್ ದಿ ಕ್ಯುಮ್ಯುಲೇಟಿವ್ ಆಗ್ತಾ ಹೋಗ್ಬೇಕು. 100 ರೂಪಾಯಿ ಥರದ್ದು ಏನಾಗಬೇಕು, 10 ಟೈಮ್ಸ್ ಕಿಲೋಮೀಟರ್ ಆದರೆ ಆಗುತ್ತೆ 1000 ರೂಪಾಯಿ ಆಗುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ವಾಟ್. ಬಟ್ ಫ್ಯೂಯಲ್ ಸೆಲ್ ಯಾವ ಥರ ಗೊತ್ತಾ, ಫ್ಯೂಯಲ್ ಸೆಲ್ 100 ರೂಪಾಯಿ ಮತ್ತೆ ಇವತ್ತು ಖರ್ಚಾಯ್ತು, ಮತ್ತೆ ನಾಳೆ 100 ರೂಪಾಯಿ ಬರುತ್ತೆ, ಮತ್ತೆ ಖರ್ಚಾಯ್ತು, ನಾಳೆ ಮತ್ತೆ 100 ರೂಪಾಯಿ ಬರುತ್ತೆ, ಮತ್ತೆ ಖರ್ಚಾಯ್ತು, ಆ ಥರ ಫ್ಯೂಯಲ್ ಸೆಲ್ಸ್. ಓಕೆ, ಅದು ಇನ್ಸ್ಟೆಂಟ್ ಅಷ್ಟೇ ಅಲ್ಲ, ಆ ಟೈಮಲ್ಲಿ ಮಾತ್ರ ಇರುತ್ತೆ, ಬಾಕಿ ಟೈಮಲ್ಲಿ ನಿಮ್ಮ ಹತ್ರ ದುಡ್ಡು ಇರೋದಿಲ್ಲ. ಬ್ಯಾಟ್ರಿ ಆ ಥರ ಅಲ್ಲ, ಇಟ್ ಇಸ್ ಜಸ್ಟ್ ಲೈಕ್ ಎ ಕ್ಯುಮ್ಯುಲೇಟಿವ್. ಎವ್ರಿ ಟೈಮ್ ಏನಾಗ್ತಾ ಇರುತ್ತೆ, ಎನರ್ಜಿ ಆ್ಯಡ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ಇಟ್ ಸೇವ್ಸ್ ಆ್ಯಂಡ್ ಡಿಸ್ಚಾರ್ಜ್ ಕೂಡ ಆಗುತ್ತೆ. ನೀವು ಎಷ್ಟು ಸೇವ್ ಮಾಡ್ತೀರಾ ಅಷ್ಟೇ ಖರ್ಚು ಮಾಡ್ತೀರಾ. ಬಟ್ ಇಲ್ಲಿ ಹೆಂಗೆ ಗೊತ್ತಾ, ಅಟ್ ಇನ್ಸ್ಟೆಂಟ್ ಇಮಿಡಿಯೇಟಾಗಿ ಬರುತ್ತೆ ದುಡ್ಡು, ಇಮಿಡಿಯೇಟಾಗಿ ಖರ್ಚಾಗ್ಬಿಡುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ದಿ ಫ್ಯೂಯಲ್ ಸೆಲ್ಸ್. ಓಕೆ, ಐ ಹೋಪ್ ಇಟ್ ಇಸ್ ವೆರಿ ಕ್ಲಿಯರ್ ಟು ನೌ. ಸೊ ಬ್ಯಾಟ್ರಿ ವಿಲ್ ಟ್ರೈ ಟು ಸ್ಟೋರ್ ದ ಎನರ್ಜಿ. ಓಕೆ, ಫ್ಯೂಯಲ್ ಸೆಲ್ ಏನು ಮಾಡುತ್ತೆ, ಫ್ಯೂಯಲ್ ಸೆಲ್ ಕೆಲಸ ನೀವು ಇಟ್ ವಿಲ್ ಜನರೇಟ್ ದ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ, ಐ ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ಬಟ್ ಇಟ್ ಈಸ್ ವೆರಿ ಇನ್ಸ್ಟೆಂಟ್, ಆ ಟೈಮಲ್ಲಿ ಮಾತ್ರ ಕೊಡೋದು. ಬಟ್ ಕ್ಲೋಸ್, ದಿಸ್ ಈಸ್ ಅ ಕ್ಲೋಸ್ ಸಿಸ್ಟಮ್. ಬ್ಯಾಟ್ರಿ ಇಟ್ ಇಸ್ ಅ ಕ್ಲೋಸ್ ಸಿಸ್ಟಮ್. ಬಿಕಾಸ್ ಬ್ಯಾಟ್ರಿಲಿ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಅದು ದೇರ್ ಇಸ್ ಅ ಸೈಕ್ಲಿಕ್ ಫಾರ್ಮೇಷನ್ಸ್. ಓಕೆ, ಬ್ಯಾಟ್ರಿ ಒಳಗಡೆ ಎಲ್ಲ ಆಗ್ತಾ ಇರುತ್ತೆ ಅಂಡ್ ಇಟ್ ವಿಲ್ ಬಿ ಸ್ಟೋರ್ಡ್. ಅಂಡ್ ಎಕ್ಸ್ಟರ್ನಲಿ ಯು ಕ್ಯಾನಾಟ್ ಹ್ಯಾವ್ ಎನಿ ಕೈಂಡ್ ಆಫ್ ದಿ ರಿಲೀಸ್ ಆಫ್ ವಾಟ್ ಇಸ್ ಎ ವಾಟರ್, ರಿಲೀಸ್ ಆಫ್ ವಾಟರ್ ಆರ್ ಹೀಟ್, ಆ ಥರ ಯಾವುದು ಪ್ರೊಡ್ಯೂಸ್ ಆಗೋದಿಲ್ಲ. ದಟ್ಸ್ ಇಟ್ ಇಸ್ ಎ ಕ್ಲೋಸ್ ಸಿಸ್ಟಮ್ಸ್, ರೈಟ್? ಇಫ್ ಯು ಸಿ ದ ಬ್ಯಾಟ್ರಿ, ಇಟ್ ಇಸ್ ವಿಲ್ ಬಿ ಪ್ಯಾಕ್ಡ್. ಓಕೆ, ಅಂಡ್ ಇಟ್ ವಿಲ್ ಕನೆಕ್ಟ್ ಟು ದ ಎಕ್ಸ್ಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್ಸ್, ರೈಟ್? ಬಟ್ ದಿಸ್ ಇಸ್ ಅ ಓಪನ್ ಸಿಸ್ಟಮ್. ಓಪನ್ ಸಿಸ್ಟಮಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ ನಿಮಗೆ ದೇರ್ ಇಸ್ ಎ ಪ್ರೊಡಕ್ಷನ್ ಆಫ್ ವಾಟ್, ಯು ಕ್ಯಾನ್ ಸಿ ದೇರ್ ಇಸ್ ಎ ಪ್ರೊಡಕ್ಷನ್ ಆಫ್ ದಿ ವಾಟರ್ ಆಲ್ಸೋ. ಎಸ್ ನೋಡಿ, ವಾಟರ್ ಕೂಡ ಏನಾಗ್ತದೆ, ರಿಲೀಸ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ದಟ್ಸ್ ವೈ ಇಟ್ ಈಸ್ ಅ ಓಪನ್ ಸಿಸ್ಟಮ್. ಓಪನ್ ಸಿಸ್ಟಮಲ್ಲಿ ನೀವು ವಾಟರ್ ಏನು ಮಾಡಬೇಕು, ಸ್ಟೋರ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಅದನ್ನು ಆಚೆ ಕಡೆ ಹಾಕಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ಸೊ ದಟ್ ಇಸ್ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಎ ಓಪನ್ ಸಿಸ್ಟಮ್, ರೈಟ್? ಆ್ಯನೋಡ್ ಅಂಡ್ ಕ್ಯಾಥೋಡ್ ಆರ್ ಮೆಟಲ್ಸ್. ಓಕೆ, ಹಿಯರ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ಆ್ಯನೋಡ್ ಅಂಡ್ ಕ್ಯಾಥೋಡ್ ಆಸ್ ಅ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಓನ್ಲಿ. ಎಲ್ಲ ಬ್ಯಾಟ್ರಿ ತಗೊಳ್ಳಿ, ಸೆಲ್ಸ್ ತಗೊಳ್ಳಿ, ಎಲ್ಲ ಕಡೆ ಆದರೂ ಎಲೆಕ್ಟ್ರೋಡ್ ಇದೇ ಇರೋದು. ಬಟ್ ನಾವು ಬ್ಯಾಟ್ರೀಸಲ್ಲಿ ಏನು ಮಾಡಿದ್ವಿ, ನಾವು ಮೆಟಲ್ಸ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ವಿ ಆರ್ ಜಸ್ಟ್ ಕನ್ಸಿಡರಿಂಗ್ ಇಟ್ ಇಸ್ ಅ ಮೆಟಲ್ಸ್. ಓಕೆ, and if you see in the what you say in the fuel cells, anode and cathodes are gaseous, means they are also kind of electrodes. They are gaseous in contact with the platinum catalyst. ಏನಾಗುತ್ತೆ ಅದು, ಆನೋಡ್ ಕ್ಯಾಥೋಡ್ ಏನಿದೆ ನಿಮಗೆ, ಆನೋಡ್ ಕ್ಯಾಥೋಡ್ ಬೋತ್ ವಿಲ್ ಟ್ರೈ ಟು ಮೇಕ್ ದ ಕಾಂಟ್ಯಾಕ್ಟ್ ವಿತ್ ದ your gaseous materials, and also it will be in contact with the platinum catalyst. So that is how the fuel cell have the internal structure. Internal structure ನಿಮಗೆ I'll show the internal structure of the fuel cells also. Okay, you'll understand in a very clear way. If we come to the next upcoming slides. Okay, ನೋಡಿ, ಇಲ್ಲಿ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಆರ್ ಇಂಟರ್ಮಿಟಲಿ ಕನ್ಸ್ಯೂಮ್, ಸೊ ನೀಡ್ ಪೀರಿಯಾಡಿಕ್ ರೀಚಾರ್ಜಿಂಗ್. ಪ್ರತಿ ಸಲ ನಾವೇನು ಮಾಡ್ತೀವಿ, ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಆರ್ ಇಂಟರ್ನಲಿ ಕನ್ಸ್ಯೂಮ್, ಎವ್ರಿ ಟೈಮ್ ಕನ್ಸ್ಯೂಷನ್ ಆಗ್ತಾ ಇರುತ್ತೆ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಅಂಡ್ ನೀಡ್ಸ್ ಅ ಪೀರಿಯಾಡಿಕ್ ರೀಚಾರ್ಜಿಂಗ್. ಪ್ರತಿ ಸಲ ಚಾರ್ಜ್ ಆಯಿತು ಅಂದರೆ ಡಿಸ್ಚಾರ್ಜ್ ಆಗಬೇಕು, ಚಾರ್ಜ್ ಮಾಡಬೇಕು, ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡಬೇಕು, ಚಾರ್ಜ್ ಮಾಡಬೇಕು, ಡಿಸ್ಚಾರ್ಜ್. ಸೊ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಅಂದ್ರೆ ಏನು, ಅಲ್ಲಿರೋ ನಿಮ್ಗೆ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಏನು ಯೂಸ್ ಮಾಡ್ತಿರೋದು, ಸಾಲ್ವೆಂಟ್ ಇನ್ ದ ಬ್ಯಾಟ್ರೀಸ್, ರೈಟ್? ದಟ್ ಈಸ್ ಡಿಸ್ಟಿಲ್ ವಾಟರ್ ತಗೊಳ್ಳಿ. ಓಕೆ, ಡಿಸ್ಟಿಲ್ ವಾಟರ್ ತಗೊಳ್ಳಿ ಬ್ಯಾಟ್ರಿಲಿ, ಏನಿಂದ ಲಿಥಿಯಂ ಬ್ಯಾಟ್ರೀಸ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ಲೆಡ್ ಆಸಿಡ್ ಬ್ಯಾಟ್ರಿ ಆಗಿರ್ಬೋದು, ಅದರಲ್ಲಿ ನೀವು ಡಿಸ್ಟಿಲ್ ವಾಟರ್ ತಗೊಂಡಾಗ ಏನಾಗುತ್ತೆ, ವಾಟ್ ವಿಲ್ ಇಟ್ ಈಸ್ ಹ್ಯಾಪನಿಂಗ್, ದೇರ್ ಇಸ್ ಎ ದೇ ಶುಡ್ ಹ್ಯಾವ್ ದಿ ಪಿರಿಯಾಡಿಕ್ ರೀಚಾರ್ಜಿಂಗ್ ಆಗ್ತಾ ಇರಬೇಕು ಆ್ಯಂಡ್ ಆಲ್ಸೋ ಚೆಕಿಂಗ್ ಮಾಡ್ತಾ ಇರಬೇಕು. ವಾಟರ್ ಕಂಟೆಂಟ್ ಕಡಿಮೆ ಆಯಿತು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಬ್ಯಾಟ್ರಿ ಚಾರ್ಜ್ ಮಾಡಲ್ಲ ಆರ್ ಬ್ಯಾಟ್ರಿ ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡೋದು. ಅದಕ್ಕೆ ನೀವು ಇಫ್ ಯು ಸಿ ಇನ್ ದ ಲಿಥಿಯಂ ಅಮೆರಾನ್ ಬ್ಯಾಟ್ರೀಸ್, ಲಿಥಿಯಂ ಬ್ಯಾಟ್ರೀಸ್ ನೀವು ಯು ಪಿ ಸಿ ಎಲ್ಲ ನೋಡ್ತಿರಲ್ವಾ, ಅಲ್ಲಿ ಮೇಲ್ಗಡೆ ಒಂದು ಲೆಡ್ ಟೈಪ್ ಇರುತ್ತೆ, ಜಸ್ಟ್ ಲೈಕ್ ನೀಡಲ್ ವಿಲ್ ಬಿ ಇನ್ ರೈಟ್, ಇಟ್ ವಿಲ್ ಶೋಸ್ ದ ರೆಡ್ ಮಾರ್ಕ್, ರೆಡ್ ಆ್ಯಂಡ್ ಬ್ಲೂ ಮಾರ್ಕ್ ತೋರಿಸುತ್ತೆ. ಅಲ್ಲಿ ವಾಟರ್ ಲೆವೆಲ್ ಎಷ್ಟಿದೆ ಅಂತ ತೋರಿಸುತ್ತೆ. ಆ ಬೇಸ್ಡ್ ಆನ್ ಯು ಕ್ಯಾನ್ ಸಿ ವೈ ಬ್ಯಾಟ್ರಿ ಇಸ್ ನಾಟ್ ಚಾರ್ಜಿಂಗ್, ವೈ ಬ್ಯಾಟ್ರಿ ಇಸ್ ನಾಟ್ ಡಿಸ್ಚಾರ್ಜಿಂಗ್. ಆ ಲೆವೆಲ್ ಕಡಿಮೆ ಇತ್ತು ಅಂದರೆ ಬ್ಯಾಟ್ರಿ ಒಳಗಡೆ ಮೇಲ್ಗಡೆ ಜಸ್ಟ್ ಲೈಕ್ ಕ್ಯಾಪ್ ಥರ ಇರುತ್ತೆ, ಮೇಲ್ಗಡೆ ಒಂದು ಪೈಪ್ ಥರ ಹಾಕಿರುತ್ತೆ, ಸ್ಮಾಲ್ ಲೈಕ್ ನೀಡಲ್ ಟೈಪ್. ಓಕೆ, ಸೊ ಇಂಜೆಕ್ಷನ್ ಸಿರಿಂಜ್ ಇರುತ್ತಲ್ಲ ಆ ಟೈಪ್ ಇರುತ್ತೆ. ಇಟ್ ಈಸ್ ಲೈಕ್ ಎ ನೀಡಲ್ ವಿಲ್ ಬಿ ಲೈಕ್ ಜಸ್ಟ್ ಯುವರ್ ಸಿರಿಂಜ್. ಓಕೆ, ಅದಕ್ಕೆ ಕೆಳಗಡೆ ಒಂದು ಕ್ಯಾಪ್ ಇರುತ್ತೆ, ಕ್ಯಾಪ್ ಒಳಗಡೆ ಏನು ಮಾಡಿರ್ತಾರೆ, ಡಿಸ್ಟಿಲ್ ವಾಟರ್ನ ಲೆವೆಲ್ನ ಚೆಕ್ ಮಾಡಕ್ಕೆ ಇಟ್ಟಿರ್ತಾರೆ ಅದನ್ನು. ಓಕೆ, ಅದು ಕಡಿಮೆ ಆಯಿತು ಅಂದರೆ ಏನಾಗುತ್ತೆ, ಬ್ಯಾಟ್ರಿ ಚಾರ್ಜ್ ಆಗಲ್ಲ, ಮೀನ್ಸ್ ಬ್ಯಾಟ್ರಿ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಡೈ. ನಿಮ್ಮ ಲಿಥಿಯಂ ಬ್ಯಾಟ್ರೀಸ್ ಏನು ಚಾರ್ಜಿಂಗ್ ಪರ್ಪಸ್ ಇಟ್ಟಿರ್ತಾರೆ, ರೀಚಾರ್ಜಬಲ್ ಬ್ಯಾಟ್ರೀಸ್ ಯೂಸ್ ಮಾಡ್ತೀರಿ ನೀವು ಯು ಪಿ ಎಸ್ಗೆ, ಅದೇನಾಗುತ್ತೆ ಲೆವೆಲ್ ಕಡಿಮೆ ಆಯಿತು ಅಂದರೆ ಬ್ಯಾಟ್ರಿ ಇದು ಲೆವೆಲ್ ಕಡಿಮೆ ಆಯಿತು ಚಾರ್ಜಿಂಗ್ ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಮಾಡಲ್ಲ. ಇಟ್ ಮೀನ್ಸ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ರಿಪ್ಲೇಸ್ ದ ಯುವರ್ ಡಿಸ್ಟಿಲ್ ವಾಟರ್ನ ರಿಪ್ಲೇಸ್ ಮಾಡಬೇಕಂತ ಹೇಳುತ್ತದು. ನೀವು ಮಾಡಲಿಲ್ಲ ಅಂದರೆ ಏನಾಗುತ್ತೆ, ಆಬ್ವಿಯಸ್ಲಿ ಬ್ಯಾಟ್ರಿ ಈಸ್ ಅಬೌಟ್ ಟು ಡೈ. ಎಸ್ ಆರ್ ನಾಟ್? ಇಟ್ ಇಸ್ ಜಸ್ಟ್ ಲೈಕ್ ಇಫ್ ಯು ಡೋಂಟ್ ಪ್ರೊವೈಡ್ ದ ಆಯಿಲ್ ಟು ದ ಇಂಜಿನ್, ನೀವು ಐ ಸಿ ಇಂಜಿನಿಗೆ ನೀವು ಆಯಿಲ್ ಕೊಟ್ಟಿಲ್ಲ ಅಂದರೆ ಏನಾಗುತ್ತೆ, ಆಯಿಲ್ ಹೋಗ್ತಾ ಹೋಗ್ತಾ ಇಟ್ ವಿಲ್ ಬಿಕಮ್ ಬ್ಲ್ಯಾಕ್, ಇಸ್ಂಟ್ ಇಟ್? The engine will go for the what is it at the final stage, right? So ಏನಾಗುತ್ತೆ, ಅದೊಂದು ಸ್ಕ್ರಾಪಲ್ಲಿ ಹಾಕಬೇಕಾಗುತ್ತೆ ಅವಾಗ. ಎಸ್ ಆರ್ ನಾಟ್? ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಇಟ್ ಈಸ್ ಹ್ಯಾಪನಿಂಗ್ ಹಿಯರ್, ರೈಟ್? ಇಂಜಿನ್ ಆಯಿಲ್ ಹಿಂಗೆ ಹಾಕ್ತೀವಿ ನಾವು ವೆಹಿಕಲ್ಗೆ, ಅದೇ ಥರ ಡಿಸ್ಟಿಲ್ ವಾಟರ್ ಕೂಡ ಬ್ಯಾಟ್ರಿಗೆ ಹಾಕ್ತಾ ಇರಬೇಕು. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಚಾರ್ಜಿಂಗ್ ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಕೂಡ ಪ್ರಾಪರ್ ಆಗುತ್ತೆ. ಪೀರಿಯಾಡಿಕ್ ಚಾರ್ಜಿಂಗ್ ವಿಲ್ ಆಲ್ಸೋ ಕ್ಯಾನ್ ಹ್ಯಾಪನ್, ರೈಟ್? ಸೊ ದಟ್ಸ್ ವೈ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಆರ್ ಇಂಟರ್ನಲಿ ಕನ್ಸ್ಯೂಮ್. ರಿಯಾಕ್ಷನ್ಸ್ ಅಂದರೆ ಯಾವುದು, ಯುವರ್ ಡಿಸ್ಟಿಲ್ ವಾಟರ್ ವಾಟ್ ಆರ್ ಯೂಸಿಂಗ್ ಇನ್ ದ ಬ್ಯಾಟ್ರೀಸ್. ಓಕೆ, that will be consumed periodical and you need to check the charging and discharging level. So that is what, ಅದರ ನೀವು ಹಾಕಿದಾಗ ಏನಾಗುತ್ತೆ, ನಿಮಗೆ ಹಾಕಲಿಲ್ಲ ಅಂದರೆ ಏನಾಗುತ್ತೆ, ಲೈಫ್ ವಿಲ್ ಡಿಕ್ರೀಸಸ್, ಲೈಫ್ ಸೈಕಲ್ ಕೂಡ ಕಡಿಮೆ ಆಗ್ತಾ ಆಗುತ್ತೆ. ಕರೆಕ್ಟ್? ಇಫ್ ಯು ಡೋಂಟ್ ಪುಟ್ ದ ಡಿಸ್ಟಿಲ್ ವಾಟರ್ ಇನ್ ಯರ್ ಬ್ಯಾಟ್ರೀಸ್, ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್, ಲೈಫ್ ಸೈಕಲ್ ವಿಲ್ ಆಲ್ಸೋ ಡಿಕ್ರೀಸಸ್, ಇಸ್ಂಟ್ ಇಟ್? ನೋಡಿ, ನೀವು ವೆಹಿಕಲ್ಗೆ ಇಂಜಿನ್ಗೆ ನೀವು ಇಂಜಿನ್ ಆಯಿಲ್ ಹಾಕ್ಸಿಲ್ಲ ಅಂದರೆ ಆಫ್ಟರ್ 2 years or 1 year ಏನಾಗುತ್ತೆ, ವೆಹಿಕಲ್ ವಿಲ್ ಗೋ ಫಾರ್ ದಿ ಸೀಸ್. ಇಂಜಿನ್ ಏನಾಗುತ್ತೆ, ಸೀಸ್ ಆಗಿಬಿಡುತ್ತೆ. ಇಲ್ಲ ಇಂಜಿನ್ ಸೀಸ್ ಆಯ್ತು ಅಂದರೆ ಏನಾಗುತ್ತೆ, ವೆಹಿಕಲ್ ಈಸ್ ಅಂಡರ್ ದ ಅಟ್ ದಿ ಎಂಡ್ ಸ್ಟೇಜ್, ನೀವು ಹೊಸ ವೆಹಿಕಲ್ ತೊಗೋಬೇಕಾಗುತ್ತೆ. ಎಸ್ ಆರ್ ನಾಟ್? ಅದು ಇಂಜಿನ್ನ ರಿಪ್ಲೇಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಇಂಜಿನ್ ಕಾಸ್ಟ್ ಇಸ್ ವೆರಿ ಹೈ. ಎಸ್ ಆರ್ ನಾಟ್? ಸೊ ದಟ್ಸ್ ವೈ ಯು ಹ್ಯಾವ್ ಟು ಮೇಂಟೈನ್ ದ ಲೈಫ್ ಸೈಕಲ್. ಮೇಂಟೈನ್ ಮಾಡಬೇಕಂದ್ರೆ ಬ್ಯಾಟ್ರಿ ಒಳಗಡೆ ನೀವು ಯು ಹ್ಯಾವ್ ಟು ಚೆಕ್ ದ ಡಿಸ್ಟಿಲ್ ವಾಟರ್. ಕರೆಕ್ಟ್? ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್ ಸ್ನೇಹ ಆ್ಯಂಡ್ ಮಮತಾ?
Yes, sir.
ಅಂಡರ್ಸ್ಟುಡ್? ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಡಿಸ್ಟಿಲ್ ವಾಟರ್ ನೀವು ರಿಪ್ಲೇಸ್ ಮಾಡ್ತಾ ಇರಬೇಕು. ಅದಕ್ಕೆ ಅಲ್ಲಿ ಲೆವೆಲ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ ಬ್ಯಾಟ್ರಿ ಮೇಲ್ಗಡೆ. ಇಫ್ ಯು ನಾಟ್ ಸೀನ್ ದ ಬ್ಯಾಟ್ರೀಸ್ ಯು ಸಿ ಇಟ್, ನೋ ಪ್ರಾಬ್ಲಮ್. ಮೇಲೆ ಲೆವೆಲ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ಆ ಲೆವೆಲ್ಸ್ ಮೇಲೆ ಎಷ್ಟಿದೆ ಡಿಸ್ಟಿಲ್ ವಾಟರ್ ಅಂತ ತೋರಿಸುತ್ತೆ. ಕಡಿಮೆ ಆಯಿತು ಅಂದರೆ ಮತ್ತೆ ರಿಪ್ಲೇಸ್ ಮಾಡಬೇಕು. ನೀವು ರಿಪ್ಲೇಸ್ ಮಾಡಲಿಲ್ಲ ಲೈಫ್ ಸೈಕಲ್ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ನೀವು ಇಂಜಿನ್ ಆಯಿಲ್ ಹಾಕ್ಸಿಲ್ಲ ಅಂದರೆ ನಿಮ್ಮ ವೆಹಿಕಲ್ಗೆ ಏನಾಗುತ್ತೆ, ಇಂಜಿನ್ ಸೀಸ್ ಆಗುತ್ತೆ, ಅದು ಬೋರಿಂಗ್ ಬರುತ್ತೆ, ಆಮೇಲೆ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಕಂಪ್ಲೀಟ್ಲಿ ಇಟ್ ವಿಲ್ ಗೋ ಫಾರ್ ದಿ ಸ್ಕ್ರ್ಯಾಪ್ ಓನ್ಲಿ. ಕರೆಕ್ಟ್? ಅದೇ ಥರ ಬ್ಯಾಟ್ರಿ ಲೈಫ್ ಕೊಡಬೇಕಂದ್ರೆ ನಾವು ಯಾಕೆ ಬ್ಯಾಟ್ರಿ ಬ್ಯಾಕಪ್ ಕೊಡ್ತಿಲ್ಲ? ಮುಂಚೆ 3 years ಬರ್ತಾ ಇತ್ತು, ಅದು ನಿಮ್ಮ ಯು ಪಿ ಎಸ್ ಮನೆಯಲ್ಲಿ 3 years ಕೊಡ್ತಾ ಇತ್ತು. ಓಕೆ, ಇವಾಗ ಯಾಕೆ ಬರೀ 1 hourಲ್ಲೇ ಶಟ್ ಡೌನ್ ಆಗ್ತಿದೆ? Because of you are not maintaining the charging and discharging properly frequently, and also the life cycle is getting reduced. ಯಾಕೆ ರಿಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ ಅಂದರೆ ನೀವು ಡಿಸ್ಟಿಲ್ ವಾಟರ್ನ ಕರೆಕ್ಟಾಗಿ ಅದನ್ನು ಪಿರಿಯಾಡಿಕ್ಕಾಗಿ ಚೆಕ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ರೆಡ್ಯೂಸಿಂಗ್ ದ ಲೈಫ್ ಸೈಕಲ್. ಇದೆ ನಾವು ಒಂದು 5000 ಕೊಟ್ಟಿದ್ವಿ ಬ್ಯಾಟ್ರಿ ಲೈಫ್. ಓಕೆ, ಇವಾಗ ಏನಾಗ್ತಿದೆ, ಇಟ್ ಇಸ್ ಗೆಟಿಂಗ್ ರೆಡ್ಯೂಸ್ ಟು 3000 ಬಿಕಾಸ್ ಯು ಆರ್ ನಾಟ್ ಮೇಂಟೈನಿಂಗ್ ದ ಬ್ಯಾಟ್ರಿ ಪ್ರಾಪರ್ಲಿ. ಎಸ್ ಆರ್ ಮೀನ್ಸ್ ಅದು ವೋಲ್ಟೇಜ್ ಕೊಡೋದಿಲ್ಲ. ವೋಲ್ಟೇಜ್ ನಿಮಗೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಅದು ಒಂದು 12 volts ಇದೆ ಅಂದರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 12 volts ಇದೆ ಅಂದರೆ 9 volts ಕೊಡ್ತು ಅಂದರೆ ಅದು ಯು ಕ್ಯಾನ್ಟ್ ಹ್ಯಾವ್ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕರೆಂಟ್ ನೋ ಟು ದ ಲೋಡ್. ಎಸ್ ಆರ್ ನಾಟ್? ಪೊಟೆನ್ಷಿಯಲ್ ಇಲ್ಲ ಅಂದರೆ ಕರೆಂಟ್ ಎಲ್ಲಿಂದ ಮೂವ್ ಆಗುತ್ತೆ? ಎಸ್ ಆರ್ ನಾಟ್? ಇಫ್ ಯು ಸಿ ದ ಬೇಸಿಕ್ ಎಕ್ಸಾಂಪಲ್ ದ ವಾಟರ್ ಟ್ಯಾಂಕ್ ಇನ್ ದ ಸಿಂಟೆಕ್ಸ್. ಓಕೆ, ಸಿಂಟೆಕ್ಸಲ್ಲಿ ಮೇಲ್ಗಡೆ ಪ್ರೆಷರ್ ಇರುತ್ತೆ, ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಇದ್ದರೆ ಮಾತ್ರ ತಾನೇ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಸ್ಟಾರ್ಟ್ ಮೂವಿಂಗ್. ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಇಲ್ಲೂ ಕೂಡ ನಮಗೆ ಪ್ರೆಷರ್ ನಥಿಂಗ್ ಮಾಡಿದೆ ಅನಾಲಗಸ್ ಟು ವೋಲ್ಟೇಜ್. ವೋಲ್ಟೇಜ್ ಕಡಿಮೆ ಇದೆ ಅಂದರೆ ಕರೆಂಟ್ನ ಹೆಂಗೆ ದಬ್ಬೋದಿಲ್ಲ. ಇಟ್ ವಿಲ್ ನಾಟ್. ದಟ್ಸ್ ವೈ ವೋಲ್ಟೇಜ್ ಇರೋದಿಲ್ಲ. ಯಾಕಂದರೆ ಡಿಸ್ಟಿಲ್ ವಾಟರ್ ಕಡಿಮೆ ಆದಾಗ ಲೈಫ್ ಸೈಕಲ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ವೋಲ್ಟೇಜ್ 12 volts ಇಂದ 9 volts ಅಥವಾ 7 volts ಬಂದುಬಿಡುತ್ತೆ. ಅವಾಗ ಕರೆಂಟು ಡೆಲಿವರ್ ಮಾಡೋದಿಲ್ಲ. ಅದು ಮಾಡಿದ್ರು ಕೂಡ ದೇರ್ ಇಸ್ ಶಾರ್ಟ್ ಸ್ಪ್ಯಾನ್ ಆಫ್ ಟೈಮ್ ಮಾತ್ರ ಮಾಡುತ್ತೆ. 3 hours ಇದ್ದು 2 hours ಬರುತ್ತೆ. ದಟ್ಸ್ ಹೌ ದಿ ಬ್ಯಾಟ್ರಿ ವಿಲ್ ಟ್ರೈ ಟು ವರ್ಕ್. ಓಕೆ, ದಟ್ ಈಸ್ ಎಕ್ಸಾಂಪಲ್. ದಿ ಲಿಥಿಯಂ ಬ್ಯಾಟ್ರೀಸ್ ಸೆಲ್ ವೋಲ್ಟೇಜ್ ಅರೌಂಡ್ 3 volts. ಪ್ಲೀಸ್ ರಿಮೆಂಬರ್ ದಿಸ್ ಪಾಯಿಂಟ್ ನಂಬರ್ 6. ಈ ಮೋಸ್ಟ್ ಆಫ್ ದ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸಲ್ಲಿ ಕೇಳ್ತಾರೆ ನಿಮಗೆ. ಇಫ್ ಯು ಗೋ ಫಾರ್ ದಿ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಇಟ್ ವಿಲ್ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್. ಸೊ ಸೆಲ್ ವೋಲ್ಟೇಜ್ ಈಸ್ ಅರೌಂಡ್ 3.7 volts ಫಾರ್ ದಿ ಲಿಥಿಯಂ ಬ್ಯಾಟ್ರೀಸ್. ಬಟ್ ಹೈಡ್ರೋಜನ್ಗೆ ಏನಾಗುತ್ತೆ, ಇಟ್ ಈಸ್ ಅರೌಂಡ್ 0.8 volts ಫಾರ್ ದಿ ಫ್ಯೂಯಲ್ ಸೆಲ್ಸ್. ಓಕೆ, ಫಾರ್ ದಿ ಫ್ಯೂಯಲ್ ಸೆಲ್ಸ್ ಇಟ್ ಈಸ್ ಅರೌಂಡ್ 0.8 volts. Okay, it will generate the electricity frequently and there is a open system, right? Reactants are externally supplied, so no charging is required. ನೋಡಿ, ಇಲ್ಲಿ ಚಾರ್ಜಿಂಗ್ ಮಾಡ್ತೀರಿ ನೀವು, ಪ್ರತಿ ಸಲ ಚಾರ್ಜ್ ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡ್ತಾರೆ. ಇಲ್ಲಿ ಚಾರ್ಜಿಂಗ್ ಮಾಡೋ ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ. ನೀನೇ ಟು ಚಾರ್ಜ್ ಅಗೇನ್ ಅಂಡ್ ಅಗೇನ್. ವೈ ಯು ಹ್ಯಾವ್ ಟು ಚಾರ್ಜ್? ಇಟ್ ಇಸ್ ನಾಟ್ ಲೈಕ್ ಯುವರ್ ಬ್ಯಾಟ್ರೀಸ್. in the first definition we understood very clearly. We are very specific with the fuel cell and the batteries. Differentiation ನಮಗೆ ಕ್ಲೀನಾಗಿ ಇವಾಗ ತುಂಬ ಚೆನ್ನಾಗಿ ಅರ್ಥ ಆಗಿದೆ, ರೈಟ್. ಇದು ರೀಚಾರ್ಜಿಂಗ್ ಮಾಡೋ ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ, ಯಾಕಂದರೆ ನೀವು ಫ್ಯೂಯಲ್ ಯಾವಾಗ ಫ್ರೀಕ್ವೆಂಟಾಗಿ ಕೊಡ್ತೀರಾ ಅವಾಗ ಮಾತ್ರ ಚಾರ್ಜ್ ಮಾಡುತ್ತೆ, ಕೊಡಲಿಲ್ಲ ಸ್ಟಾಪ್ ಮಾಡುತ್ತೆ ಅಷ್ಟೇ. ದಟ್ ಇಸ್ ವಾಟ್ ಇಟ್ ಈಸ್ ಡೂಯಿಂಗ್, ಎಸ್ ಆರ್ ನಾಟ್? ದರ್ ಇಸ್ ನೋ ರೀಚಾರ್ಜಿಂಗ್ ಈಸ್ ರಿಕ್ವೈರ್ಡ್. ದ ಶೆಲ್ ಲೈಫ್ ಇನ್ಕ್ರೀಸಸ್, ಯಾಕಂದರೆ ನೀವು ಅದನ್ನು ಫ್ರೀಕ್ವೆಂಟಾಗಿ ನೀವು ಮಾನಿಟರ್ ಮಾಡೋದು ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಯಾವಾಗ ಬೇಕು ಅವಾಗ ನೀವು ಯೂಸ್ ಮಾಡ್ಬೋದು. ಓಕೆ, ಇಟ್ ಇಸ್ ನಾಟ್ ಲೈಕ್ ಪ್ಲೀಸ್ ಗೋ ಆ್ಯಂಡ್ ಚೆಕ್ ದ ಡಿಸ್ಟಿಲ್ ವಾಟರ್ ಎವ್ರಿ ಟೈಮ್ ಇನ್ ದ ಲಿಥಿಯಂ ಬ್ಯಾಟ್ರೀಸ್, ಲೆಡ್ ಆಸಿಡ್ ಬ್ಯಾಟ್ರೀಸ್ ಡಿಸ್ಟಿಲ್ ವಾಟರ್ ಚೆಕ್ ಮಾಡೋ ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ. ಅಲ್ಲಿ ಚೆಕ್ ಮಾಡಲೇಬೇಕು. ಯಾಕೆ ನೀವು ಡಿಸ್ಟಿಲ್ ವಾಟರ್ ಕಡಿಮೆ ಆದರೆ ಏನಾಗುತ್ತೆ, ನಿಮಗೆ ಬ್ಯಾಟ್ರಿ ಲೈಫ್ ಕೊಡೋದಿಲ್ಲ, ಆ್ಯಂಡ್ ಆಲ್ಸೋ ಸೈಕಲ್ ವಿಲ್ ಆಲ್ಸೋ ಗೆಟ್ ರೆಡ್ಯೂಸ್ಡ್, ಎಸ್ ಆರ್ ನಾಟ್? ಆ್ಯಂಡ್ ವೋಲ್ಟೇಜ್ ಕೂಡ ಕೊಡೋದಿಲ್ಲ. 3 hours ಬರೋ ಬ್ಯಾಟ್ರಿ ಏನಾಗಿದೆ 1 hour ಮಾತ್ರ ಬಂದು ನಿಂತ್ಕೊಂಡ್ಬಿಡುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಮೇಂಟೆನೆನ್ಸ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ರೀಚಾರ್ಜ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಲೈಫ್ ಸೈಕಲ್ ಕೂಡ, ಬಿಕಾಸ್ ದಟ್ ಓನ್ಲಿ ದ ಲೈಫ್ ಸೈಕಲ್ ಹ್ಯಾಸ್ ಬಿನ್ ಇನ್ಕ್ರೀಸ್ಡ್, because frequent it is. Whenever you provide fuel, then it will produce electricity, right? So that's why the shell life will increases, right? The hydrogen fuel cells will having the voltage be around 0. You can take the screenshot of this. Usually you have to remember, okay? Most of the competitive exams alli nimage keltare lithium batteries each cell voltage ಎಷ್ಟು ಇರುತ್ತೆ. This is for the each cell voltage. So each cell voltage is to be around 3.7 volts, okay? And the hydrogen for the your cells, it is to be around 0.8 volts. Correct? Is it clear? Sneha and Mamta?
Yes, sir. Yes, sir.
Okay, we'll see the other difference also, right? If you see the other differences also, right? If you see in the battery, there is a chemical energy usually come from the metals and the ions or oxides, isn't it? So battery ಏನಾಗುತ್ತೆ, electrode ಇರೋದ್ರಿಂದ it will try to react with the other oxidants, other oxides also, right? It will try to produce the ions. Ions exchange ಆಗುತ್ತೆ, but electrons also. Similarly, in the fuel cell also, what is happening here? Continuous source of fuels and the oxygen, usually from air, to sustain the chemical reaction. Here, if you want to run the reaction continuously, means you have to provide your oxygen and hydrogen continuously, right? Then only the electricity can be produced. Okay, so here in the batteries, if you see, no, there is a supplied electricity energy over a short period of time in a discharge cycle. Okay, point number 7, what it will tell, it will try to supply the electrical energy over a short period of time. Okay, of a time in a discharge cycle. ಎಷ್ಟು discharge cycle ಇರುತ್ತೆ ಅದಕ್ಕೆ ಚಾಲೆಂಜ್ discharge based on that it will try to discharge the energy for a short period. But if it is not like that, ಒಂದ್ಸಲ discharge ಆಯಿತು ಅಂದರೆ ಮತ್ತೆ ನೀವು ಚಾರ್ಜ್ ಮಾಡಲೇಬೇಕಾಗುತ್ತೆ. But here we don't have that kind of problems. Okay, it can supply for electrical energy over a much longer period of time, as much as the possibilities of sending the fuel, no, ಫ್ಯೂಯಲ್ ಎಷ್ಟು ಆಗ್ತಾ ಇರ್ತಾರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಫ್ಯೂಯಲ್ ಸೆಲ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಪ್ರೊಡ್ಯೂಸಿಂಗ್ ದ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ. ಫ್ಯೂಯಲ್ ಯಾವಾಗ ಸ್ಟಾಪ್ ಮಾಡ್ತೀರೋ ಅದು ಕೂಡ ಸ್ಟಾಪ್ ಆಗ್ಬಿಡುತ್ತೆ. ಬಟ್ ಇದ್ರಲ್ಲಿ ಆ ಥರ ಅಲ್ಲ. ಒನ್ ಥಿಂಗ್ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್, ಪ್ಲೀಸ್ ರಿಮೆಂಬರ್ ದಿಸ್. ಓಕೆ, ಇಟ್ ಕ್ಯಾನ್ ಸಪ್ಲೈ ದ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಓವರ್ ಎ ಶಾರ್ಟ್ ಪೀರಿಯಡ್ ಆಫ್ ಟೈಮ್ ಇನ್ ಅ ಡಿಸ್ಚಾರ್ಜ್ ಸೈಕಲ್. ಓಕೆ, ಸೊ ನೀವು ಡಿಸ್ಚಾರ್ಜ್ ಸೈಕಲಲ್ಲಿ ಏನು ಮಾಡ್ಬೋದು, ಯು ಕ್ಯಾನ್ ಟ್ರೈ ಟು ಡಿಸ್ಚಾರ್ಜ್ ಓನ್ಲಿ ದ ವೆರಿ ಶಾರ್ಟ್ ಪೀರಿಯಡ್ ಆಫ್ ಟೈಮ್, ಬಟ್ ಹಿಯರ್ ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು generate the energy as longer times as you supply the more fuels, right? Frequently you supply fuel, supply ಮಾಡ್ತಿದ್ದಂಗೆ ಏನಾಗುತ್ತೆ, you can have the energy also, electrical energy, right? So battery cannot be charged and discharged simultaneously. Okay, but here fuel cell can refueled while the operational, since the tank is separated. ನೋಡಿ here, this is one of the advantage. ನೋಡಿ ನೀವು ಒಂದು ಸುಮಾರು ಸಲ ನೀವು most of the time you might have seen in the most of the videos, right? ಸೊ ಬ್ಯಾಟ್ರಿನ ನೀವು ಕನೆಕ್ಟ್ ಮಾಡಿಬಿಟ್ಟು ಫೋನಲ್ಲಿ ಮಾತಾಡ್ಬೋದು, ಕರೆಕ್ಟ್? ಅಂದರೆ ಅಲ್ಲಿ ಚಾರ್ಜ್ ಆಗ್ತಿದೆಯೋ ಮತ್ತು ಡಿಸ್ಚಾರ್ಜ್ ಆಗ್ತಿದೆಯೋ ಎರಡೂ ಆಗ್ತಾ ಇರುತ್ತೆ. ಬ್ಯಾಟ್ರಿನ ಚಾರ್ಜ್ ಮಾಡ್ತಾ ಇದ್ರೆ ಫೋನಲ್ಲಿ ಮಾತಾಡ್ತಾ ಇರ್ತೀರ. ಮೀನ್ಸ್ ಸರ್ಕ್ಯೂಟ್ ಇಸ್ ಕನ್ಸ್ಯೂಮಿಂಗ್ ದ ಚಾರ್ಜಿಂಗ್ ಆಲ್ಸೋ ಟ್ರೈಂಗ್ ಟು ಡಿಸ್ಚಾರ್ಜ್ ಸೈಮಲ್ಟೇನಿಯಸ್ಲಿ, ಇಟ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್. ಎಸ್, ಅದಕ್ಕೆ ಬ್ಯಾಟ್ರಿ ಬ್ಲಾಸ್ಟ್ ಆಗೋದು. ಯು ಮೈಟ್ ಹ್ಯಾವ್ ಸೀನ್ ಇನ್ ಮೋಸ್ಟ್ ಆಫ್ ದ ವಿಡಿಯೋಸ್, ರೈಟ್? ಪಾಯಿಂಟ್ ನಂಬರ್ 8 ಏನು ಹೇಳುತ್ತೆ, ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಟೇಕ್ ದ ಬ್ಯಾಟ್ರೀಸ್, ಓಕೆ, ನೀವು ಮೊಬೈಲಲ್ಲಿ ಬ್ಯಾಟ್ರಿ ಇದೆಯಲ್ವಾ, ಸಮ್ 5000 mAh 3000 mAh ಬ್ಯಾಟ್ರೀಸ್ ಇದೆ. ಓಕೆ, ಅದು ನೀವೇನು ಮಾಡ್ತೀರಾ, ಚಾರ್ಜಿಂಗ್ ಕನೆಕ್ಟ್ ಮಾಡ್ತೀರಾ, ಪ್ಲಗ್ ಮಾಡ್ತೀರಾ. ಓಕೆ, ಯು ಆರ್ ಕನೆಕ್ಟೆಡ್ ಟು ದ ಅಡ್ಯಾಪ್ಟರ್ ಆಫ್ ಯುವರ್ plug. Okay, when you plug that your batteries, no, and it will charge. Meanwhile you are also using to making a calls or using WhatsApp, right? ಏನಾಗುತ್ತೆ ಅವಾಗ ಬ್ಯಾಟ್ರಿ ಡಿಸ್ಚಾರ್ಜ್ ಆಗುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ವೆರಿ ಡಿಫಿಕಲ್ಟೀಸ್. ದಟ್ಸ್ ವೈ ದ ಬ್ಯಾಟ್ರಿ ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜ್ ಆಗಿರ್ಬೋದು, ಸ್ಟೇಟ್ ಆಫ್ ಹೆಲ್ತ್ನ ಮಾನಿಟರ್ ಮಾಡೋಕೆ ಏನಾಗುತ್ತೆ, ವಿ ಫೈಂಡ್ ಲಾಟ್ ಆಫ್ ಡಿಫಿಕಲ್ಟೀಸ್. ದಟ್ ಈಸ್ ವಾಟ್ ಯು ಹ್ಯಾವ್ ಟು ಸಿ ದ ರಿಸರ್ಚ್ ಗ್ಯಾಪ್ ಇನ್ ದಿಸ್. ಯಾಕೆ ಆ ಥರ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನು ನಾವು ಸ್ಟಡಿ ಮಾಡಬೇಕಾಗುತ್ತೆ, ರೈಟ್? ದಟ್ ಈಸ್ ವಾಟ್ ದ ಬ್ಯಾಟ್ರಿ ಕ್ಯಾನಾಟ್ ಬಿ ಚಾರ್ಜ್ ಆ್ಯಂಡ್ ಡಿಸ್ಚಾರ್ಜ್ ಸೈಮಲ್ಟೇನಿಯಸ್ಲಿ. ಇಟ್ ಇಸ್ ನಾಟ್ ಪಾಸಿಬಲ್. ನೀವು ಪ್ಲಗ್ ಮಾಡಿಬಿಟ್ಟು ನಾನು ಫೋನಲ್ಲಿ ಮಾತಾಡ್ತೀನಿ, ಚಾರ್ಜ್ ಆಗ್ತಾ ಇದೆ, ನೀವು ಫೋನಲ್ಲಿ ಮಾತಾಡ್ತೀರಾ ಆ್ಯಂಡ್ ವಾಟ್ಸಪ್ ಯೂಸ್ ಮಾಡ್ತಿರಲ್ಲ, ಮೊಬೈಲಿಗೆ ವೀಡಿಯೋ ನೋಡ್ತೀರಾ, ಚಾರ್ಜ್ ಮಾಡ್ತಾ ಇದೆ, ಏನಾಗ್ತಿದೆ ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡ್ತಾ ಇದೆ. ಸೊ ದಟ್ ಈಸ್ ಬಿಕಮ್ ವೆರಿ ಡಿಫಿಕಲ್ಟೀಸ್ ಇನ್ ದ ಬ್ಯಾಟ್ರೀಸ್. ಸೊ ಬ್ಯಾಟ್ರಿ ಕ್ಯಾನಾಟ್ ಬಿ ಚಾರ್ಜ್ ಆ್ಯಂಡ್ ಡಿಸ್ಚಾರ್ಜ್. ಒಂದು ಬ್ಯಾಟ್ರಿ ಚಾರ್ಜ್ ಮಾಡಬೇಕು ಫುಲ್ಲಿ ಆರ್ ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸಿ if you see the battery is now completely around in my laptop it is 100%, right? When it's 100% we are yes and ಇವಾಗ ನೋಡಿ ನಾವೇನು ಮಾಡಿದ್ದೀವಿ, we are going completely for discharge. 100% ಇಂದ ಅದನ್ನ ನಾವೇನು ಮಾಡಬೇಕು, ಇವಾಗ ಡಿಸ್ಚಾರ್ಜ್ ಮಾಡಬೇಕು. ಇಲ್ಲಾಂದ್ರೆ ಏನಾಗುತ್ತೆ, ನಾನು if I plug this battery for, see if I plug this battery for charging, right, for next 2 hours, so what will happen, it is charging also, it will try to overcharge also, it will try to discharge. So both is happening. So both you cannot make simultaneously. That is a very difficult observe. ಓಕೆ, ಎರಡು ಅಟ್ ಎ ಟೈಮ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ ಬ್ಯಾಟ್ರಿ. ಅದಕ್ಕೆ ಬ್ಯಾಟ್ರಿ ಯಾಕೆ ಲೈಫ್ ಕೊಡಲ್ಲ ಅಂದರೆ ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜ್ ಅಂಡ್ ಸ್ಟೇಟ್ ಆಫ್ ಡಿಸ್ಚಾರ್ಜ್ and state of life and and also the state of health conditions, everything we have to monitor. That is what we studied in the previous sessions. ಎಲ್ಲ ನಮಗೆ ಚೆನ್ನಾಗಿ ಅರ್ಥ ಆಗಿದೆ. ಸ್ಟೇಟ್ ಆಫ್ ಲೈಫ್ ಎಷ್ಟಿರುತ್ತೆ, ಸ್ಟೇಟ್ ಆಫ್ ಚಾರ್ಜಿಂಗ್ ಯಾವ ಥರ ಮಾಡಬೇಕು, ಸ್ಟೇಟ್ ಆಫ್ ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಮಾಡಬೇಕು, ಡೆಪ್ತ್ ಆಫ್ ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಮಾಡಬೇಕು, ಅದನ್ನೆಲ್ಲ ನಾವು ಕ್ಲೀನಾಗಿ ಮಾನಿಟರ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ಸೊ ದಟ್ ಇಸ್ ವಾಟ್. ಬಟ್ ವೇರ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಫ್ಯೂಯಲ್ ಸೆಲ್ ಕ್ಯಾನ್ ಬಿ ರೀಫ್ಯೂಲ್ಡ್ ವೈಲ್ ದ ಆಪರೇಷನ್ಸ್, ವೆನ್ ದೇರ್ ಇಸ್ ಇನ್ ಆಪರೇಷನ್ ಕಂಡೀಷನ್. ನೋಡಿ, ಸೆಲ್ ಆಪರೇಟ್ ಆಗ್ತಾ ಇದೆ, ಸೆಲ್ ಈಸ್ ಅಂಡರ್ ದ ಆಪರೇಷನ್ಸ್. ಓಕೆ, ಸಿನ್ಸ್ ದ ಟ್ಯಾಂಕ್ ಈಸ್ ಸಪ್ರೇಟ್, ಟ್ಯಾಂಕ್ ಸಪ್ರೇಟ್ ಇರುತ್ತೆ ಆ್ಯಂಡ್ ಆಲ್ಸೋ ದಿ ಯಾವ ಥರ ಇರುತ್ತೆ, ಫ್ಯೂಯಲ್ ಸೆಲ್ ಸಪ್ರೇಟ್ ಆಗಿ, ಹೈಡ್ರೋಜನ್ ಸಪ್ರೇಟ್ ಆಗಿ ಬರ್ತಾ ಇರುತ್ತೆ, ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಆ್ಯಂಡ್ ಆಕ್ಸಿಜನ್ ಗ್ಯಾಸ್ ಆರ್ ಬಿನ್ ಸಪ್ರೇಟ್ ಟ್ಯಾಂಕ್. ಓಕೆ, ಬೋತ್ ಆರ್ ಇನ್ ಸಪ್ರೇಟ್ ಟ್ಯಾಂಕ್, ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಪ್ರೊಡ್ಯೂಸ್ ಅ ಫ್ಯೂಯಲ್ಸ್. Whenever you require, it will try to produce a fuels. Okay, refueling it is happening. That's why it is called as a fuel cells. There is a refueling it is happening. That's why it is a rechargeable. Batteries is called as rechargeable, and the fuel cell is called as a refueling systems. Okay, that's why it is a open. This is a we call this as a in this circuit, as I told, this is a closed system, whereas the fuel cell is a open system. ನೋಡಿ, ಓಪನ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ನೀವು ಓಪನ್ ಆಗಿ ಟ್ಯಾಂಕ್ ಸಪ್ರೇಟ್ ಆಗಿರುತ್ತೆ, ಅರೆ ಟ್ಯಾಂಕ್ ಸಪ್ರೇಟ್ ಆಗಿರುತ್ತೆ, ಆಕ್ಸಿಜನ್ ಮತ್ತು ಹೈಡ್ರೋಜನ್ ಸಪ್ರೇಟಾಗಿ ಸಪ್ಲೈ ಮಾಡ್ತೀರಾ, ಆ್ಯಂಡ್ ಆಲ್ಸೋ ವಾಟರ್ ಕೂಡ H2O ಕೂಡ ಏನಾಗ್ತದೆ, ರಿಲೀಸ್ ಆಗ್ತದೆ. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗ್ತದೆ, ಕ್ಲೋಸ್ ಸಿಸ್ಟಮಲ್ಲಿ ಎಲ್ಲದೂ ನಡಿಬೇಕು. ಬ್ಯಾಟ್ರಿದಲ್ಲಿ ನೋಡಿ, ಎವ್ರಿಥಿಂಗ್ ಇಟ್ ಈಸ್ ಅಂಡರ್ ಕ್ಲೋಸ್ ಸಿಸ್ಟಮ್. ಡಿಸ್ಟಿಲ್ ವಾಟರ್ನು ಒಳಗಡೆ ಇರುತ್ತೆ, ಎಲೆಕ್ಟ್ರೋಡು ಒಳಗಡೆ ಇರುತ್ತೆ, ಮತ್ತು ನೀವು ಚಾರ್ಜಿಂಗ್ ಕೂಡ ಸಿಸ್ಟಮ್ ಏನು ಅದು ಕೂಡ ಕ್ಲೋಸ್ಡ್ ಆಗಿರುತ್ತೆ. ಎವ್ರಿಥಿಂಗ್ ಇಟ್ ಇಸ್ ಕ್ಲೋಸ್ಡ್, right? And discharging also happen when you disconnect from the charging of the batteries, isn't it? Everything reaction is happening inside only. But il athara alla, supply is also coming from the outside, yes or not? The agents which are coming from the outside, external tank inda kuda enagtade, agents kuda barta ide, and also the water is also releasing from the other ends, right? So that's why it is called a fuel can be refueled while the operation, under the operations. ಆಪರೇಷನ್ ನೀವು ವರ್ಕ್ ಮಾಡ್ತಿರೋ ಕೂಡ ಫ್ಯೂಯಲ್ ಸೆಲ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀರ ಅಂದರೆ, ಇಫ್ ಯು ಯೂಸ್ ಅ ಫ್ಯೂಯಲ್ ಸೆಲ್ ಡ್ಯೂರಿಂಗ್ ದ ಇನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ಸ್. ಓಕೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ಸಲ್ಲಿ ನೀವು ಫ್ಯೂಯಲ್ ಸೆಲ್ ಯೂಸ್ ಮಾಡಿದ್ದೀರಾ ಅಂದರೆ, ಆ ಫ್ಯೂಯಲ್ ಸೆಲ್ನ ಏನು ಮಾಡ್ಬೋದು, ಯು ಕ್ಯಾನ್ ಟ್ರೈ ಟು ಡ್ಯೂರಿಂಗ್ ದ ಆಪರೇಷನ್ ಆಲ್ಸೋ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ದ ಫ್ಯೂಯಲ್ ಸೆಲ್ಸ್. ಬಟ್ ಬ್ಯಾಟ್ರಿದಲ್ಲಿ ಆ ಥರ ಇಲ್ಲ. ಬ್ಯಾಟ್ರಿನ ನೀವು ಒಂದ್ಸಲ ಇನ್ಸ್ಟಾಲ್ ಮಾಡಿದ್ದೀರಾ ಅಂದರೆ, ಬ್ಯಾಟ್ರಿ ಡಿಸ್ಚಾರ್ಜ್ ಆಗೋವರೆಗೂ ನೀವು ಚಾರ್ಜಿಂಗ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ವಿ ಹ್ಯಾವ್ ದ ಡಿಫ್ರೆಂಟ್ ಟೆಕ್ನಿಕ್ಸ್ ಆಲ್ಸೋ, ವಿಲ್ ಡೋಂಟ್ ಬಾದರ್ ಅಬೌಟ್ ದ ಡಿಫ್ರೆಂಟ್ ಟೆಕ್ನಿಕ್ಸ್ ಓವರ್ ಹಿಯರ್. ಓಕೆ, ಬಟ್ ಫ್ಯೂಯಲ್ ಸೆಲ್ಸಲ್ಲಿ ಏನಾಗುತ್ತೆ, ನಿಮಗೆ ಟ್ಯಾಂಕ್ ಇದು ಸಪ್ರೇಟ್ ಆಗಿ ನಿಮಗೆ ಸಪ್ಲೈ ಆಗ್ತಾ ಇರುತ್ತೆ. ಓಕೆ, ಡ್ಯೂರಿಂಗ್ ಅಂಡರ್ ಆಪರೇಷನ್ಸ್ ಆಲ್ಸೋ. ನೋಡಿ, ಫ್ಯೂಯಲ್ ಸೆಲ್ ಆಪರೇಷನ್ ಆಗ್ತಾ ಫ್ಯೂಯಲ್ ಸೆಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಹಾಕಿದ್ದೀರಾ, ನೀವು ವೆಹಿಕಲ್ನ ರನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ಓಕೆ, ಎವ್ರಿ ಟೈಮ್ ಇನ್ಸ್ಟೆಂಟ್ ಆಗಿ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಜನರೇಷನ್ ಮಾಡಿ ಕೊಡ್ತಾ ಇದೆ ಫ್ರಮ್ ಸಪ್ರೇಟ್ ಟ್ಯಾಂಕ್. ಇಸ್ ದಟ್ಸ್ ವೈ ಇಟ್ ಇಸ್ ಅ ಓಪನ್, ದಟ್ಸ್ ವೈ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಓಪನ್ ಸಿಸ್ಟಮ್. ಬ್ಯಾಟರಿ ಇಸ್ ಕಾಲ್ಡ್ as a closed system. Okay, that is the meaning of that. So battery electric car consumes a less electricity than the fuel car. ನೋಡಿ, ಬ್ಯಾಟ್ರಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಕಾರ್ ಯಾವುದೇ ನಾವು ಲಿಥಿಯಂ ಬ್ಯಾಟರೀಸ್ ಯೂಸ್ ಮಾಡಿ ಟ್ರೈ ಟು ಕನ್ಸ್ಯೂಮ್ ದ ಲೆಸ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ. But whereas hydrogen fuel car, if you use a hydrogen fuel car, I can show the hydrogen fuel car also in the upcoming slides. Okay, so we have the hydrogen fuel cars also over here. So these are the hydrogen fuel cars. Okay, not hydrogen fuel cars which are used in the Canada. Canada already ಇದನ್ನ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡಿದ್ದಾರೆ. Okay, the 30 feet of height of the hydrogen fuel cell powered the transit the bus made by the Ballard power systems in Canada. ಕ್ಯಾನಡಾ ಆಲ್ರೆಡಿ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡಿದ್ದಾರೆ ಫ್ಯೂಯಲ್ ಸೆಲ್ಸ್. ಇವಾಗ ಇಂಡಿಯಾದಲ್ಲಿ ಆಗಿದೆ, ಮತ್ತು ಇಂಡಿಯಾದಲ್ಲಿ ಆಗಿಲ್ಲ ಅಂದ್ಕೊಳ್ಳೋಕೆ ಹೋಗ್ಬಿಡಿ. ಇನ್ ಇಂಡಿಯಾ ಆಲ್ಸೋ ವಿ ಹ್ಯಾವ್ ದ ಇಂಪ್ಲಿಮೆಂಟ್ ಇಸ್ ಬಿನ್ ಹ್ಯಾಪನ್ ಇನ್ ದ ಡೆಲ್ಲಿ ಅಂಡ್ ದ ಗುರ್ಗಾಂವ್ ಆಲ್ಸೋ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ದಿ ಹೈಡ್ರೋಜನ್ ಫ್ಯೂಯಲ್ ಸೆಲ್ ವಿಲ್ ವರ್ಕ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ಎಕ್ಸಾಂಪಲ್ ಐ ಆಮ್ ಜಸ್ಟ್ ಶೋಯಿಂಗ್ ಟು ಮೇಕ್ ಯು ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವೆರಿ ಕ್ಲಿಯರ್ಲಿ. ಸೊ ಆಲ್ ರೈಟ್, ಸೊ ಬ್ಯಾಟ್ರೀಸ್ ಆರ್ ವೆರಿ ಚೀಪರ್. ಓಕೆ, ಬ್ಯಾಟ್ರಿ ಯಾಕೆ ಚೀಪರ್ ಅಂದರೆ, ನಿಮಗೆ ಒನ್ಸ್ ಯು ಇನ್ಸ್ಟಾಲ್ ದ ಬ್ಯಾಟ್ರೀಸ್ ಯು ಹ್ಯಾವ್ ಲೆಡ್ ಆಸಿಡ್ ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಅಂಡರ್ ದ ಪ್ಯಾಕ್. But it is costlier. ನೋಡಿ, ಯಾಕೆ ಕಾಸ್ಟ್ಲಿಯರ್? Can anybody tell me why it is costlier? Hydrogen. Yes, Mamta, Sneha. Mamta and Sneha. Okay.
Because of the catalyst we will use, sir.
Yes, it got catalyst ಕೂಡ ಪರ್ಚೇಸ್ ಮಾಡಬೇಕು ನೀವು. ಹೈಡ್ರೋಜನ್ ಕೂಡ ಟ್ರಾನ್ಸ್ಪೋರ್ಟೇಷನ್ ಮಾಡಬೇಕು. ಹೈಡ್ರೋಜನ್ ಇಸ್ ಎ ಮೋರ್ ಇನ್ಫ್ಲಾಮೇಬಲ್, ಬೇಗ ಬೆಂಕಿ ಹಚ್ಕೊಂಡ್ಬಿಡುತ್ತೆ. ಹೈಡ್ರೋಜನ್ ನೀವು ಟ್ರಾನ್ಸ್ಪೋರ್ಟೇಷನ್ ಮಾಡುವಾಗ ಕನ್ವರ್ಷನ್ಸ್ ಮಾಡಿ ಟ್ರಾನ್ಸ್ಪೋರ್ಟೇಷನ್ ಮಾಡಬೇಕು, ಎಸ್ ನಾಟ್? ಸೊ ದಟ್ಸ್ ವೈ ಹೈಡ್ರೋಜನ್ ಇಸ್ ಆಲ್ಸೋ ವೆರಿ ಕಾಸ್ಟ್ಲಿಯರ್. ಅಂಡ್ ಆಕ್ಸಿಜನ್ ಆಲ್ಸೋ ನೀವು ಅದನ್ನ ಬೇರೆ ಕಂಟೈನರ್ ಇಂದ ಪಾಸ್ ಮಾಡಬೇಕು, ಕೆಟಲಿಸ್ಟ್ ಪರ್ಚೇಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಸೊ ದಟ್ಸ್ ವೈ ಇಟ್ ಇಸ್ ವೆರಿ ಕಾಸ್ಟ್ಲಿ. ಅಂಡ್ ಯು ರಿಕ್ವೈರ್ ದಿ ಸಪರೇಟ್ ಸಿಸ್ಟಮ್ ಫಾರ್ ದಟ್. ಎಕ್ಸ್ಟರ್ನಲ್ ಸಿಸ್ಟಮ್ಸ್ ಎಲ್ಲ ಬೇಕಾಗುತ್ತೆ ಅದು ಸಪ್ಲೈ ಮಾಡುವಾಗ, ಎಸ್ ನಾಟ್? ಕೆಟಲಿಸ್ಟ್ ಇಸ್ ಆಲ್ಸೋ ವೆರಿ ಕಾಸ್ಟ್ಲಿಯರ್, isn't it? So fuel, that's why the fuel cell cost is very very high. Fuel cell ಆಗಿರ್ಬೋದು. Also you have the what is it, the super capacitor cost is very high compared with the batteries. Battery is very cheaper. ಅದಕ್ಕೆ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಅಲ್ಲಿ ಏನು ಮಾಡಿದ್ದೀವಿ, ನಾವು ಇಂಡಿಯನ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಅಲ್ಲಿ ಬ್ಯಾಟ್ರಿನ ಹಾಕಿದ್ದೀವಿ. ಯಾಕಂದ್ರೆ ಜನ, if you want to go for the fuel cell, no, the cost of the vehicle will also increases. Yes, and if you want the high end of the facilities, that high speed and more speed, if you want to require, if you want the quick start, if you want the cold start, right, then you can go for the fuel cells. ನಮಗೆ ಟೆಂಪ್ರೇಚರ್ ನಮ್ಮಲ್ಲಿರೋ ನಮ್ಮ ಸ್ಟೇಟಲ್ಲಿರೋ ಟೆಂಪ್ರೇಚರ್ಗೆ ಬ್ಯಾಟ್ರಿನೇ ಸಾಕು, ಫ್ಯೂಯಲ್ ಸೆಲ್ ತಗೊಳ್ಳೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಅದಕ್ಕೆ ಡೆಲ್ಲಿಯಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ, ಬಿಕಾಸ್ ದೇ ಹ್ಯಾವ್ ದ ಟೆಂಪ್ರೇಚರ್ ಇಸ್ ವೆರಿ ವೆರಿ, ಸಮಟೈಮ್ಸ್ ಇಟ್ ಮೇ ಗೋ ಟು ದ -10 ಡಿಗ್ರಿ ಆಲ್ಸೋ ಇನ್ ಡೆಲ್ಲಿ, ಆರ್ -2 ಡಿಗ್ರಿಗೆ ಹೋಗ್ಬಿಡುತ್ತೆ. ಬಟ್ ಇಲ್ಲಿ ಯಾವತ್ತೂ ಮೈನಸ್ಸಿಗೆ ಹೋಗೋದಿಲ್ಲ, ಎಸ್ ಆರ್ ನಾಟ್? ಇಟ್ ಇಸ್ ವೆರಿ ವೆರಿ ರೇಟ್. ದ ಟೆಂಪ್ರೇಚರ್ ಮೇ ಕಮ್ಸ್ ಅರೌಂಡ್ 8 ಡಿಗ್ರಿ 10 ಡಿಗ್ರಿ ಬರ್ಬೋದು ನಮ್ಮ ಸ್ಟೇಟಲ್ಲಿ, ಬಟ್ ನಾಟ್ ಬಿಯಾಂಡ್ ದಟ್. ಇಫ್ ಯು ಸೀನ್ ಅವರ್ ದಾವಣಗೆರೆ ಆಲ್ಸೋ, ರೈಟ್, ಇಟ್ ವಿಲ್ ಬಿ ವೆರಿ ವೆರಿ ಲೆಸ್. ಬಟ್ ಡೆಲ್ಲಿದಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ ತುಂಬ ಕ್ಲೌಡ್ ಇರುತ್ತೆ, ಶಿಮ್ಲಾ ಆ ಕಡೆ ಎಲ್ಲ. ಸೊ ಗುರ್ಗಾಂವ್ದಲ್ಲಿ ಏನಾಗುತ್ತೆ, ತುಂಬ ಕ್ಲೌಡ್ ಇರುತ್ತೆ. ಸಮಟೈಮ್ಸ್ ಏನಾಗುತ್ತೆ, -2 ಡಿಗ್ರಿ -3 ಡಿಗ್ರಿ ಬಂದ್ಬಿಡುತ್ತೆ ಟೆಂಪ್ರೇಚರ್. ಅದಕ್ಕೆ ಇಲ್ಲಿ ಕ್ವಿಕ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕಂದ್ರೆ ನೀವು ಏನು ಮಾಡಬೇಕು, ಫ್ಯೂಯಲ್ ಸೆಲ್ನ ತಗೋಬೇಕು. ಸಿ, ಅದಕ್ಕೆ ನಾನು ಶೋನ್ ದ ಎಕ್ಸಾಂಪಲ್, ರೈಟ್? here I shown the example of to understand the quick start. That's why it is called a quick start. It's a rapid cold start, isn't it? ನೋಡಿ, ಕೋಲ್ಡ್ ಇದ್ರೂ ಕೂಡ ಏನಾಗುತ್ತೆ, ಲೋ ಟೆಂಪ್ರೇಚರ್ ಕೂಡ ನಿಮ್ಮದು ಫ್ಯೂಯಲ್ ಸೆಲ್ ವರ್ಕ್ ಆಗುತ್ತೆ. ಅಟ್ ದ ಲೋ ಟೆಂಪ್ರೇಚರ್ ಆಲ್ಸೋ ಆಪರೇಷನ್ ಎನೇಬಲ್ಸ್ ಸ್ಟಾರ್ಟ್ ಅಪ್ ಇನ್ ಸೆಕೆಂಡ್ಸ್. ವೆಹಿಕಲ್ ವಿತ್ ಇನ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ವೆಹಿಕಲ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ನಾವು ಫ್ಯೂಯಲ್ ಸೆಲ್ಸ್ನ ಏನು ಮಾಡ್ತೀವಿ, ಬೇಸ್ಡ್ ಆನ್ ದ ರೀಜನ್ಸ್, ಆ ರೀಜನ್ ಅಲ್ಲಿ ನಾವು ಫ್ಯೂಯಲ್ ಸೆಲ್ನ ಇನ್ಸ್ಟಾಲ್ ಮಾಡಿ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಮಾಡಿದ್ದೀವಿ ಅಂದ್ರೆ, ಇಫ್ ಇಟ್ ರಿಲೀಸ್ ಇನ್ ದ ಮಾರ್ಕೆಟ್, ನೋ, ಸೊ ದೋಸ್ ರೀಜನ್ಸ್ ಆಫ್ ದಿ ಪೀಪಲ್ ವಿಲ್ ಬೈ. ನಮಗೆ ಫ್ಯೂಯಲ್ ಸೆಲ್ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ವಿ ರಿಕ್ವೈರ್ ಬ್ಯಾಟ್ರೀಸ್ ಇನಫ್ ಫಾರ್ ಅಸ್. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ನೋ, ಸೊ ಬ್ಯಾಟ್ರೀಸ್ ಇನಫ್. ವಿ ಡೋಂಟ್ ರಿಕ್ವೈರ್ ದ ಕ್ವಿಕ್ ಸ್ಟಾರ್ಟ್. ಇಲ್ಲಿ ಕೋಲ್ಡ್ ಅಷ್ಟೊಂದು ಕೋಲ್ಡ್ -ಡಿಗ್ರಿ ಹೋಗೋದಿಲ್ಲ. ಮ್ಯಾಕ್ಸಿಮಮ್ ವಿ ಕ್ಯಾನ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಟು 10 ಡಿಗ್ರಿ ಆರ್ 12 ಡಿಗ್ರಿ, ದಟ್ಸ್ ಇಟ್, ಆರ್ 15 ಡಿಗ್ರಿ. ನಾವು ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಯೂಶಲಿ ಹೋಗೋದಿಲ್ಲ. -ಡಿಗ್ರಿ ಇವತ್ತು ಹೋಗೋದಿಲ್ಲ. ಯು ಡೋಂಟ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಎನಿ ಸ್ನೋಫಾಲ್ ಓವರ್ ಇನ್ ದ ಅವರ್ ಪ್ಲೇಸ್, ಓಕೆ, ಇನ್ ದ ಅವರ್ ರೀಜನ್ಸ್, ಓಕೆ, ಎಸ್ಪೆಷಲಿ ಇನ್ ಐ ಆಮ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ಇನ್ ದಾವಣಗೆರೆ ಸಿಟಿ. ಬಿಕಾಸ್ ಇಫ್ ಯು ಸೀನ್ ದ ಗುರ್ಗಾಂವ್ ಅಂಡ್ ನ್ಯೂ ಡೆಲ್ಲಿ, ನೋ, ದ ಕೋಲ್ಡ್ ಇಸ್ ವೆರಿ ವೆರಿ, ಟೆಂಪ್ರೇಚರ್ ಇಸ್ ವೆರಿ ವೆರಿ ಲೋ ಅವರ್ ದೇ. ಸೊ ಅದಕ್ಕೆ ಕ್ವಿಕ್ ಸ್ಟಾರ್ಟ್ ಆಗಬೇಕಂದ್ರೆ, ರ್ಯಾಪಿಡ್ ಕೋಲ್ಡ್ ಸ್ಟಾರ್ಟ್ ಆಗಬೇಕಂದ್ರೆ ಫ್ಯೂಯಲ್ ಸೆಲ್ಲಿಗೆ ಹೋಗಲೇಬೇಕು. ನೋಡಿ, ಫ್ಯೂಯಲ್ ಸೆಲ್ ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಇಂಜೆಕ್ಟ್ ಮಾಡುತ್ತೆ ದ ಏಜೆಂಟ್ಸ್, ಹೈಡ್ರೋಜನ್, ಆಕ್ಸಿಜನ್, ರೈಟ್? It will try to start your vehicle immediately. Yes or no? It will try to start your vehicle immediately. So that's why the fuel cell is very costly, even for the vehicle also. So most of the vehicles are they have been implemented, right? And it is not environmentally friendly, right? Environmentally friendly no, because disposal is very very difficult. Nodi, if you dispose the batteries, no, lithium batteries and lead acid batteries, no, you cannot throw on the roadsides. It should be disposal, should be properly. ದೂರದಲ್ಲಿ ಹೋಗ್ಬಿಟ್ಟು ಅದನ್ನ ಏನು ಮಾಡಬೇಕು, ಇನ್ಸೈಡ್ ದಿ ಅರ್ತ್ ಒಳಗಡೆ ನೀವು ಅದನ್ನು ಡಿಸ್ಪೋಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಎಲ್ಲಿ ಬೇಕಾದ್ರೆ ಡಿಸ್ಪೋಸ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಇಟ್ ಇಸ್ ವೆರಿ ಟಾಕ್ಸಿಕ್ ಆ್ಯಂಡ್ ಇಟ್ ಇಸ್ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಬೇಗ ಆಗ್ಬಿಡುತ್ತೆ. ಬೇರೆ ಏಜೆಂಟ್ಸ್ ಜೊತೆಗೆ ಅದು ರಿಯಾಕ್ಟ್ ಆಯಿತು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಪ್ರೊಡ್ಯೂಸ್ ದ ರಿಯಾಕ್ಷನ್ಸ್, ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ. ಇಫ್ ಸಂಬಡಿ ಟಚ್, ಇಫ್ ಸಂಬಡಿ ಸ್ಮೆಲ್ ಇಟ್, ಆರ್ ಇಫ್ ಸಂಬಡಿ ಇನೇಲ್ ಇಟ್, ಸೊ ಇಫ್ ಸಂಬಡಿ ಟೇಸ್ಟ್ ದಟ್ ಒನ್, ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್, ದ ಲಿಥಿಯಮ್ ಆರ್ ಲೆಡ್ ಆಸಿಡ್, ರೈಟ್? ಬರೀ ಗ್ಯಾಸ್ ಇನ್ಹೇಲ್ ಮಾಡಿದ್ರೆ ಸಾಕು, ಜನ ಸತ್ತೋಗ್ಬಿಡ್ತಾರೆ. It is very toxic in nature, right? The lead acid batteries. So ಅದಕ್ಕೆ it is not very friendly in nature. Okay. See, fuel cell ನೋಡಿ, hydrogen at instant, every time it is more friendly. ನಿಮ್ಮ ಹೆಂಗ್ ಫ್ರೆಂಡ್ ಎಷ್ಟು ಕ್ಲೋಸ್ ಆಗಿರ್ತಾರೆ ನೋಡಿ, ಎನ್ವಿರಾನ್ಮೆಂಟಲ್ ಫ್ರೆಂಡ್ಲಿ. ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ದಿ ಎನ್ವಿರಾನ್ಮೆಂಟಲ್ ಫ್ರೆಂಡ್ಲಿ. ಇಟ್ ಇಸ್ ಲೈಕ್ ಎ ಇನ್ಸ್ಟೆಂಟ್. ಓಕೆ, ವೆನೆವರ್ ಯು ರಿಕ್ವೈರ್ ದ ಫ್ಯೂಯಲ್ಸ್, ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಪ್ರೊಡ್ಯೂಸ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ, ರೈಟ್? ಇಟ್ ಇಸ್ ಜಸ್ಟ್ ಲೈಕ್ ಯರ್ ಫ್ರೆಂಡ್ಸ್ ಓನ್ಲಿ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ನೋ, ಸಿ ಆರ್ ದ ರೀಚಾರ್ಜಿಂಗ್ ವಿಲ್ ಟೇಕ್ಸ್ ಎ ಲಾಂಗರ್ ಟೈಮ್. ಓಕೆ, 3 hours ತಗೋಬಹುದು, 4 hours ತಗೋಬಹುದು, ಎಸ್ ಆರ್ ನಾಟ್, ಆರ್ 5 hours will take, and discharging also will take 3 hours. But refilling takes a very less time. ಫ್ರಾಕ್ಷನ್ ಆಫ್ ಮಿನಿಟ್ಸ್ ಇಟ್ ಕ್ಯಾನ್ ಹ್ಯಾಪನ್, ರೈಟ್? ಯಾವಾಗ ನೀವು ಫ್ಯೂಯಲ್ನ ಸಪ್ಲೈ ಮಾಡ್ತೀರಾ, ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಚಾರ್ಜಿಂಗ್ ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಆಗ ಚಾನ್ಸಸ್ ಇಸ್ ಮೋರ್. ಓಕೆ, So that is what, if you see in the next slide, you can understand very clearly. So this is actually the diagram of the your batteries, right? You have the electrode, positive electrode is a negative electrode is, isn't it? So current current is trying to move in this direction, correct? Whenever the these positive ions will try to move towards this, electrons in opposite direction. So that's why we call it a conventional current. So if you see in this diagram, no, you have the cathode electrode as well as we have the electrolytes in between these two. Okay, it's similar like a batteries only, but storage agodilla. It is you can get that instant. Okay, see in one side across the anode you're passing a hydrogen, right? Across the cathode you're passing the oxygen. But one kade hydrogen pass madidre one kade oxygen pass madbekagutte. Okay, so enagutte electrons will try to come in this direction. So anode inda cathode ge hogutte. So right, H2 enagutte, H2 is going to be released as a 2H plus 2E. To 2E enagutte anode it is more attractive nature, isn't it? So anode is more this is the electrons will try to move from here to here. Okay, and current will move from here to here. That is we call it as a conventional current. Okay, now let us see the fuel cell histories. If we talk about the fuel histories, so these are the people who have been discovered the different types of the fuel cells, right? Alkaline agirbodu, and also you see the fuel cells of the stacks madadaga are different. They have got the different results also, right? So when you see about the Sir William group, right, in the year 1839, which is before our independence, right? So this people has made a reverse hydrolysis. So reverse hydrolysis andre yav ತರ ಆಗುತ್ತೆ ಅಂದ್ರೆ ನಿಮಗೆ now what we are using is nothing but the hydrolysis process. ನಾವು ಯೂಸ್ ಮಾಡ್ತಾ ಇರೋದು ಈಗ ಫ್ಯೂಯಲ್ ಸೆಲ್ ಅಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, hydrolysis process ನ ಯೂಸ್ ಮಾಡಿದ್ವಿ. But he made the invention on the reverse hydrolysis. So where the breakdown of hydrogen is trying to occur, isn't it? So actually in this research, the researcher who have made has lot of made impact in the world, right? So Sir William has a very has an interesting research. He has made a lot of interesting research, right? Where he built the first gas voltaic batteries. He was the first person to develop the voltaic batteries of to be around 1 volt. So 1 volt battery na first ಇವನೇ invent ಮಾಡಿದ್ದು. He is the first person to invent in the fuel cell ಬಗ್ಗೆ study ಮಾಡಿ research ಮಾಡಿ he has invented to produce a 1 volt of cell in the batteries, right? So that is what in the year 1839, right? So he took the sulfuric acid, nothing but the H2SO4. H2SO4 ತಗೊಂಡ್ಬಿಟ್ಟು ಆತ ಏನು ಮಾಡ್ದ, he supplied the hydrogen to the one electrode and oxygen to the other electrodes. He has taken the each electrolyte as a sulfuric acid, that is the H2SO4, with the help of the platinum also. You have to take the platinum, that is the reaction to become more faster. So from that experiment he has invented and he got the cell voltage of around 1 volts. So that is what he have made the invention, right? So usually reverse hydrolysis ಅಂದ್ರೆ ಯಾವ ತರ ಆಗುತ್ತೆ ನಿಮಗೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇವಾಗ ಹೈಡ್ರೋಜನ್ ವಾಟರ್ ಇದೆ, okay, when water is combined with the electricity it will try to produce a hydrogen and oxygen, right? So that is called the reverse hydrolysis. So reverse hydrolysis ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ನಿಮಗೆ ಈ ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ನೀವು H2O ತಗೊಳ್ಳಿ, ವಾಟರ್ ನ ತಗೊಳ್ಳಿ, ಮತ್ತೆ ಎಲೆಕ್ಟ್ರಿಸಿಟಿನ ಪಾಸ್ ಮಾಡಿ, ಅವಾಗ ಏನಾಗುತ್ತೆ, ಹೈಡ್ರೋಜನ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ ಮತ್ತೆ ಆಕ್ಸಿಜನ್ ರಿಲೀಸ್ ಆಗುತ್ತೆ. ನೋಡಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಟೇಕ್ ಟೂ ಎಲೆಕ್ಟ್ರೋಡ್ ನ ನೀವು ಏನ್ ಮಾಡಿ ಅಂದ್ರೆ ನೀವು ಅದಕ್ಕೆ ಎಲೆಕ್ಟ್ರಿಸಿಟಿನ ಪಾಸ್ ಮಾಡಿ, ಎರಡು ಎಲೆಕ್ಟ್ರೋಡ್ ತಗೊಳ್ಳಿ, ಎಲೆಕ್ಟ್ರಿಸಿಟಿನ ಪಾಸ್ ಮಾಡಿ ಇದನ್ನು ವಾಟರ್ ಹಾಕಿ, ಅವಾಗ ಏನಾಗುತ್ತೆ, ಬಬಲ್ ಫಾರ್ಮೇಷನ್ಸ್ ಆಗುತ್ತೆ. ಸೊ ಬಬಲ್ ಫಾರ್ಮೇಷನ್ಸ್ ಅಂದ್ರೆ ಏನ್ ಆಕ್ಚುಲಿ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಕ್ಸಿಜನ್, release of oxygen, yes or no, release of hydrogen. That is what it is. They have made reverse hydrolysis. That is called the reverse hydrolysis. I hope you understood now, right? If you can please note on the equations. I'll tell you the equation, right? If you take the water, okay, H2O ತಗೊಳ್ಳಿ plus electricity. H2O plus electricity will try to give the H2 plus oxygen. Then you balance the equations. That is called the reverse hydrolysis. Correct? You follow up ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ please note down the equations, okay? Sneha and Mamta, you can please note down the equations. You can see the reverse hydrolysis ಯಾವ ತರ ಆಗುತ್ತೆ ಅನ್ನೋದು ಗೊತ್ತಾಗುತ್ತೆ. ಎರಡು ಎಲೆಕ್ಟ್ರೋಡ್ ನ ತಗೊಳ್ಳಿ, ಅದನ್ನ ಏನ್ ಮಾಡಿ, ಅದಕ್ಕೆ ಎಲೆಕ್ಟ್ರೋಡ್ ನ ಚಾರ್ಜ್ ಮಾಡಿ, ವಾಟರ್ ಡಿಪ್ ಮಾಡಿ, ವಾಟರ್ ಡಿಪ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಅವಾಗ H2 ಡಿಪ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, it will try to produce a bubbles on the water, right? So that is called the hydrogen oxygen release. Okay, that is what he has made the experiment by the Sir William Grew in the year 1839. Is it clear, Sneha and Mamta?
Yes, sir.
Okay, again if you see that reverse hydrolysis, again if you take the hydrogen and oxygen, you combine it again, it will try to produce the water and electricity again. So So that is called a reverse hydrolysis. ಅದೇ equation ಮತ್ತೆ ಉಲ್ಟಾ ಬರೀರಿ ಏನಾಗುತ್ತೆ, reverse hydrolysis process will get resembles for that, the concept of reverse hydrolysis. So that is what he has made the invention, ಆ ಥರ invention ಮಾಡಿದ್ರು. Okay, if you write the equation plus H2O plus electricity will give the H2 plus O2. Okay, then balance the equations. Okay, and if you see the reverse of it ಏನಾಗುತ್ತೆ, H2 release ಆಗಿದೆನಲ್ಲ right hand side, right, and oxygen, you try to combine this, it will try to produce the H2O plus electricity. So that is called a reverse hydrolysis process that he has been invented. So that's why the fuel cell was first invented by the William Grew in the year 1839. So ಅದೇ ತರ we have the Francis Bourne also has made the a lot of inventions in the fuel cells. He made the fuel stacks. 1 volt ಈತ ಕಂಡುಹಿಡಿದು ಕೊಟ್ಟ. ಆಮೇಲೆ ಏನಾಯ್ತು, ಅದು 1 volt ನಾವು ಫ್ಯೂಯಲ್ ಸ್ಟ್ಯಾಕ್ ಅಂತ ಹೇಳಿದ್ದೀನಲ್ವ, ಯಾವ ಥರ ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್ಸ್ ಮಾಡಬೇಕು. 6 ಕಿಲೋವ್ಯಾಟಿಗೆ ನಿಮಗೆ ಇಫ್ ಯು ವಾಂಟ್ ಟು ಹ್ಯಾವ್ ದ 240 ಆಂಪಿಯರ್ ಆಫ್ ದಿ ಕರೆಂಟ್ ಆ್ಯಂಡ್ 27 voltage, then you have to connect in the your parallel combination. Cells should be connected, the cell stack should be connected in the parallel combinations. If you want to get the more voltage, then you connect in the series combinations to get the higher value of the voltages. Okay. So that is what they have made the invention to get the lot of research ಮಾಡಿದ್ಮೇಲೆ 1 voltage ಇಂದ ಅವ್ರು ಏನು ಮಾಡಿದ್ರು, ಜಾಸ್ತಿ voltage ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರು. That is what they are telling, the cell stack has been connected in the fuel cells, right, to get the more and more voltages, right. And this person, the Francis Bacon, also used the potassium hydroxide. Potassium hydroxide ಇವ್ರು ಹೆಂಗೆ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ನ ಯೂಸ್ ಮಾಡಿದ್ರು, ಅದರಿಂದ ಹೈಡ್ರೋಜನ್ ಹಿಂಗೆ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿ ವಾಟರ್ ದೇ ಹ್ಯಾವ್ ಟು ಗೆಟ್ ದ ಜನರೇಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಯಾವ ಥರ ಮಾಡಿದ್ರು ವಿಲಿಯಂ ಗ್ರೂ. ಅದೇ ಥರ ದಿಸ್ ಫೆಲ್ ಆಲ್ಸೋ ಯೂಸ್ ದ ಫಾರ್ ಸೇಮ್ ಫ್ಯೂಯಲ್ಸ್ ಅಲ್ಲಿ ಯೂಸ್ ದ potassium hydroxide, right. As I told, you can use any kind of the agents, isn't it? Gaseous fuels use ಮಾಡ್ಬೋದು, also you can use the hydrogen use ಮಾಡ್ಬೋದು, you can use the liquid fuels also, not only one, you can use any kinds of the fuels, right, for your for generation of the energy, that is electrical energy, right. So that is what he used, the potassium hydroxide electrolytes use ಮಾಡಿದ್ರು. Okay, so from that he got the candidate from the process, he got the energy, electrical energy ಕೂಡ generation ಮಾಡೋ help ಆಯ್ತು. And also try to improve from the each cells, he has made the stacking, right. Stacking 5 kilowatt stacking ಮಾಡಿಬಿಟ್ಟು ಎಷ್ಟು ಬರುತ್ತೆ, 5 kilowatt approximately if you connected in the series, sorry, in the parallel combinations, right, he expected to get the more current, around 200 ampere voltage he got, and also the current and the voltage to be around 27 voltage. Okay, 5 kilowatt ಯಾವ ಥರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ಅದೇ ಥರ ನೀವು 6 kilowatt ಕೂಡ 200 amperes and also the voltage to be around 27 volts ಗೆ ಡೆವಲಪ್ ಮಾಡಿದ್ರು. So these are the people, they have created the history in the world, right, because of the inventions. ನೋಡಿ ಅವರು ರಿಸರ್ಚ್ ಮಾಡಿ ಏನು ಮಾಡಿದ್ರೆ they got some results, that is the outcome. So that is also we are expecting in your people also, after learning this subject, what is the outcome from that? You have to make certain kind of novelties in your work. Already ಏನಾದರೂ ಸಹ ನಾವೆಲ್ಟಿನ ನೀವು ಮಾಡಬೇಕು, ಇನ್ವೆನ್ಷನ್ ಮಾಡಬೇಕು, ರಿಸರ್ಚ್ ಮಾಡಬೇಕು, ರೈಟ್. ಸೊ M.Tech ಅಲ್ಲಿ ನೀವು ಯಾವಾಗ ರಿಸರ್ಚ್ ಮಾಡೋದು ಕಲಿತೀರ, ಇಟ್ ವಿಲ್ ಬಿಕಮ್ ವೆರಿ ಈಸಿಯರ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿ ಕಾನ್ಸೆಪ್ಟ್, and also you can go for the n number of papers to be published in the good journals and conference, right. So in the late 1950s, right, alkaline fuel cells first was used in the space programs. Space aircraft ಅಲ್ಲಿ ಕೂಡ they have been used, this one alkaline fuel cells ಕೂಡ ಯೂಸ್ ಮಾಡಿದ್ರು. In 1960s also they are used this kind of the present, from 1960 to present. If you see the 1960 to present, it is used in the manned of space programs ಅಲ್ಲೆಲ್ಲ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಏರ್ಕ್ರಾಫ್ಟ್ ಅಲ್ಲೆಲ್ಲ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಸ್ಯಾಟಲೈಟ್ ಅಲ್ಲಿ we are using the various applications we are going to use, right. So not only for the particular events, ಬೇರೆ ಕೂಡ ನಾವು ಅದನ್ನ ಯುಟಿಲೈಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, right, after the discovery of this fuel cells, right. So that is these are the types of the electrolytes. Please go through the electrolytes concept, right. ಯಾವ electrolytes ಬರ್ತಾವೆ ನಮಗೆ, AFC we have in this syllabus, you have to study the AFC, alkaline fuel cells ನ ಕೂಡ ನೀವೇನ್ ಮಾಡಬೇಕು, ಸ್ಟಡಿ ಮಾಡಬೇಕು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ಯಾರು ಸ್ಟಡಿ ಮಾಡಬೇಕು, PEMFC ನ ಕೂಡ ಸ್ಟಡಿ ಮಾಡಬೇಕು. ದಟ್ ಈಸ್ polymer electrolytes membrane fuel cells, or you can say the proton exchange membrane fuel cells. Okay, so polymer electrolyte na use ಮಾಡಿ, ಏನು polymer electrolyte use ಮಾಡಿದೀವಿ ನಾವು, what is the polymer electrolyte? Please you have to note down certain points in your book, don't just see the slides. Okay, ಕೆಲವು ಪಾಯಿಂಟ್ಸ್ ನೀವು ತುಂಬಾ ನೆನ್ಪಿಟ್ಕೋಬೇಕು. Every time I have to go back and show you the what is the type of the polymers, solid polymers have been used, electrolytes, right. That is a Nephia, commercial name is a Nephia, that is a parafluorosulfonic acid na use ಮಾಡಿದ್ದಾರೆ, that is called electrolyte has been used. Example, it is a Nephia. Okay, so that is called the polymers they have been used, isn't it. So that is called the polymer electrolytic, or you can say proton exchange. ಅದಕ್ಕೆ ಪ್ರೋಟಾನ್ ಕೂಡ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗುತ್ತೆ, ಅದನ್ನ ನೀವು ಪ್ರೋಟಾನ್ ಎಕ್ಸ್ಚೇಂಜ್ ಮೆಂಬರ್ ಫ್ಯೂಲ್ ಸೆಲ್ಸ್ ಅಂತಾನೂ ಕರೀಬಹುದು. Okay, you can call it as a polymer electrolytes. right? So the name of the polymer electrode also you know it, right? And also we have not studied the MCFC. We don't have in the syllabus. We study the solid oxide fuel cells. Okay. So these are the three electrolytes that are used in the fuel cells. Okay. The first one, third one, and the fifth one. 135 you have to remember. ಯಾವ ತರ electrolytes ಇದೆ ನಮಗೆ alkaline fuel cells ಇದಾವೆ. In our syllabus we have the polymer electrolyte, or you can say proton exchange membrane fuel cells. We have the solid oxide fuel cells. See, working principle all are same. ನೋಡಿ ಫ್ಯೂಯಲ್ ಸೆಲ್ ಅಂದಮೇಲೆ ಕೆಲಸ ಎಲ್ಲದು ಒಂದೇನೇ ಇರುತ್ತೆ. ನೀವು ಆಕ್ಸಿಜನ್ ಏಜೆಂಟ್ನ ಏನು ಮಾಡಬೇಕು, ಎಡಗಡೆಯಿಂದ ಪಾಸ್ ಮಾಡಬೇಕು, ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕು, ಅಂಡ್ ಸಿ ಹೌ ದ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಹ್ಯಾಸ್ ಬಿನ್ ಜನರೇಟ್, ಹೌ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಟ್ ಇಸ್ ಎಮಿಟಿಂಗ್ ಫ್ರಮ್ ದಿ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಅಂಡ್ ಫ್ಲೋಯಿಂಗ್ ಟುವರ್ಡ್ಸ್ ದಿ cathode side, and current is flowing in the cathode anode side to produce a conventional current. So this process will remain same. Okay, if you take any fuel cell, process will remain same, please remember. But electrolytes ಏನಾಗಿದೆ, electrolytes ಮಾತ್ರ ಚೇಂಜ್ ಆಗುತ್ತೆ ನಿಮಗೆ, because electrolyte will also will change. ಒಂದರಲ್ಲಿ alkaline ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಒಂದರಲ್ಲಿ ನಾವು ಏನು ಮಾಡಿದ್ವಿ ಪಾಲಿಮರ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ನ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಒಂದರಲ್ಲಿ ಸಾಲಿಡ್ ಆಕ್ಸೈಡ್ ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ದಿಸ್ ಇಸ್ only the types of electrolytes. See, at the end words you can see there is a FC, FC and FC, correct? Everywhere you can see there is FC, FC. All are fuel cells only, but electrolytes are changed. ನೋಡಿ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ alkaline ಯೂಸ್ ಮಾಡಿದ್ದೀವಿ, ಇಲ್ಲಿ ನಾವೇನು ಯೂಸ್ ಮಾಡಿದ್ದೀವಿ ಪಾಲಿಮರ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ನ ಯೂಸ್ ಮಾಡಿದ್ದೀವಿ, ಇಲ್ಲಿ ಸಾಲಿಡ್ ಆಕ್ಸೈಡ್ ನ ಯೂಸ್ ಮಾಡಿದ್ದೀವಿ. So only the electrolyte has been changed. Those are the types of electrolytes. I hope it is very clear to you. Alright, next, based on the oxidant and fuel, ಯಾವ ತರ fuels ನ ಯೂಸ್ ಮಾಡ್ತೀರಾ ನೀವು for this particular types of the fuel cells, right? What are the oxidant and fuels are you using? So one is the hydrogen. You have to use the pure hydrogen. Okay, ನಾವು ಹಿಂಗೆ ಪ್ಯೂರ್ ಪೆಟ್ರೋಲ್ ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ for the domestic and international flights. What we are not using in the our two-wheelers or four-wheelers vehicles. Okay, so ಅಲ್ಲಿ ನಾವು ಪ್ಯೂರ್ ಪೆಟ್ರೋಲ್ ನ ಯೂಸ್ ಮಾಡಲ್ಲ, but we are using the pure petrol in the for what is it, for the flights and helicopters also. But here also we have to see the pure hydrogen. Pure hydrogen ಇಲ್ಲಿಂದ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಬೇಕು ನಾವು, ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಆಗಿ H2SO4 ಇಂದ ಆದರೂ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿ, ಆರ್ H2O ಇಂದ ಆದರೂ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿ, try to extract the hydrogen. Pure hydrogen ಬೇಕು, pure oxygen ಬೇಕು for the fuel cells. So these are the fuel and oxidant it is required. Okay, next, hydrogen rich in gas or air fuel cells should be there, right? That is the next the fuel types of fuels. We have the ammonia, that is NH for air fuel cell. Should you can have the synthesis gas also, right? Air fuel cell, and the hydrocarbons, that is HC, right? That is in form of the gaseous material. These are the air fuel cells. Okay, is it clear the types of fuel cells and the electrolytes?
Yes, sir.
Okay, all right. Now let us see the PEMC, right? PEMFC, isn't it? So that is what we have to study in the today's session. Okay, today's session ನಿಮ್ಗೆ ಇರೋದು actually fuel cell technologies ನ ಓದಿದೀವಿ ನಾವು. Okay, ಇವಾಗ ಏನು ಓದಬೇಕು? We have to study the PEMC ನ study ಮಾಡಬೇಕು. Then you will go for the SOFC, then we'll go for the EFC. Then we'll combine the storage of your supercapacitor with the various batteries for the satisfying the conventional and non-conventional grid to the load demands. Okay, so that is what we have to discuss. All right, so let us see the PEMC, right? PEMC, how it is the PEMC will work, right? And polymer electrolytes we also called as a polymer electrolyte membrane fuel cell. Okay, both are same only. Here there is a exchange of protons. ಯಾವ್ದು ಪ್ರೋಟಾನ್ಸ್ H ಪ್ಲಸ್ ಪ್ರೋಟಾನ್ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ. ಇಲ್ಲಿ ಒಂದು ಮೆಂಬ್ರೇನ್ ಇರುತ್ತೆ ಇನ್ ಬಿಟ್ವೀನ್ ಎರಡು ಕ್ಯಾಥೋಡ್ ಮುಂದೆ ಏನು ಮಾಡಿರ್ತಾರೆ, ಒಂದು ಮೆಂಬ್ರೇನ್ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತಾರೆ. ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಮೂವ್ ಫ್ರಮ್ ದಟ್ ಮೆಂಬ್ರೇನ್ಸ್. ಇಟ್ ವಿಲ್ ಅಲೋ ಓನ್ಲಿ ದ ಹೈಡ್ರೋಜನ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ನ ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಅದನ್ನು ಮೂವ್ ಮಾಡಕ್ಕೆ ಬಿಡೋದಿಲ್ಲ. ಆ ಥರ ನಾವು ಮೆಂಬ್ರೇನ್ನ ಏನು ಮಾಡಿದ್ದೀವಿ, ಯೂಸ್ ಮಾಡಿದ್ದೀವಿ. ವಾಟ್ ಕೈಂಡ್ ಆಫ್ ಮೆಂಬ್ರೇನ್ಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್, ಐ ಹ್ಯಾವ್ ಶೋನ್ ಇಟ್ ಹಿಯರ್ ಆಲ್ಸೋ, ರೈಟ್? ಪ್ಲೀಸ್ ನೋಟ್ ಆನ್ ಸಮ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ಸ್. ಕೆಲವೊಂದು ಮೆಂಬ್ರೇನ್ಸ್ನ ಯಾವ್ಯಾವ ತೋರಿಸ್ತಾ ಇರ್ತೀನಿ ಅದನ್ನು ನೀವು ಕ್ಲೀನಾಗಿ ಸ್ವಲ್ಪ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ. ಯಾಕಂದರೆ ಕಾನ್ಸೆಪ್ಟು ಕ್ಲಿಯರ್ ಆಗಬೇಕಂದ್ರೆ you have to see the different types of the concept which I am delivering to you. Okay, ನೋಡಿ here electrolyte is a solid polymers. Okay, ಏನು ಮಾಡುತ್ತೆ ನೋಡಿ ಇಲ್ಲಿ, it conducts the protons. ನೋಡಿ, we can take the screenshot of this for understanding the next slides. Okay, next slide ಅಲ್ಲಿ ತುಂಬ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ ನಿಮಗೆ. ನೀವೇನು ಮಾಡಬೇಕು, this the nephyon is a solid polymers. Okay, commercial name is parafluorosulfonic acid. Okay, so this will try to allow only the protons. H plus ನ ಮಾತ್ರ ಏನು ಮಾಡುತ್ತೆ, ಅಲೋ ಮಾಡುತ್ತೆ. H plus ನ ಮಾತ್ರ ಅಲೋ ಮಾಡುತ್ತೆ, electron ನ ಬ್ಲಾಕ್ ಮಾಡುತ್ತೆ. That is the job of this membrane. Okay, that is the job of this membrane. Is it clear now? Sneha and Mamta?
Yes, sir.
Okay, so now we'll use we are going to use the proton exchange as well as the polymer electrolyte. That is a Nefion, right? Here there we have the anode, we have the cathode, isn't it? So across the anode there is a negative post of the fuel cell, okay, and conducts the electrons that are freed from the hydrogen molecules so that they can be used in the external circuit. So what exactly it will tell anode electrode hatra enaಗುತ್ತೆ, there are two electrodes ಇರುತ್ತೆ. ಯಾವುದೇ fuel cell ತಗೊಳ್ಳಿ, any batteries you take, there is a two electrodes, that is anode and cathodes. Okay, but fuel cell is a little bit somehow different from the actual batteries. ಸ್ವಲ್ಪ ಡಿಫ್ರೆಂಟ್ ಆಗಿದೆ. ದ ಫ್ಯೂಯಲ್ ಸೆಲ್ ಇಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಡಿಫ್ರೆಂಟ್. ಇಟ್ಸ್ ವರ್ಕಿಂಗ್ ಪ್ರಿನ್ಸಿಪಲ್ ಅಂಡ್ ಆಲ್ಸೋ ದಿ ರಿಯಾಕ್ಷನ್ಸ್. ಓಕೆ, ಅದಕ್ಕೆ ನಾವು ರೆಡಾಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಅದಕ್ಕೆ ಬೇರೆ ರೆಡಾಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ವಿ ಕಾಲ್ ಇಟ್ ದ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್. ಬಟ್ ಇನ್ ದ ಕೇಸ್ ಆಫ್ ದಿಸ್ ಫ್ಯೂಯಲ್ ಸೆಲ್ ವಿ ಕಾಲ್ ಇಟ್ ದ ರೆಡಾಕ್ಸ್ ರಿಯಾಕ್ಷನ್ಸ್. ಓಕೆ, ನೋಡಿ ಆನೋಡ್ ಹತ್ರ ಏನಾಗ್ತದೆ, ದೇರ್ ಇಸ್ ಎ ನೆಗೆಟಿವ್ ಪೋಸ್ಟ್ ಆಫ್ ದಿ ಫ್ಯೂಯಲ್ ಸೆಲ್ಸ್. ಓಕೆ, ಇಫ್ ಸಿ ಅಕ್ರಾಸ್ ದಿ ಆನೋಡ್ ದೇರ್ ಇಸ್ ಎ ನೆಗೆಟಿವ್ ಪೋಸ್ಟ್. ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಪೋಸ್ಟ್ ಅಂದ್ರೆ ಏನು, ವಾಟ್ಸಪ್ಪಲ್ಲಿ ನೀವೇನೇ ಪೋಸ್ಟ್ ಮಾಡ್ತೀರಾ ಅನ್ಕೊಳ್ಳಿ, ಒಂದು PDF ಪೋಸ್ಟ್ ಮಾಡ್ತೀರಾ, ನೋಟ್ಸ್ ಪೋಸ್ಟ್ ಮಾಡ್ತೀರಾ, ಅದು ಎಲ್ರಿಗೂ ಶೇರ್ ಆಗುತ್ತಲ್ವಾ. ಅಂದರೆ ಎಲ್ಲಿ ಹೋಗ್ಬೇಕು ಅಲ್ಲಿ ರೀಚ್ ಆಗುತ್ತೆ, ನಿಮ್ಮ ಗ್ರೂಪಲ್ಲಿ ರೀಚ್ ಆಗುತ್ತೆ. ನನ್ನ ಗ್ರೂಪಲ್ಲಿ ಬರೋದಿಲ್ಲ, ನನಗೆ ಪೋಸ್ಟ್ ಮಾಡಿ ನನಗೆ ಬರುತ್ತೆ, ಬೇರೆ ಗ್ರೂಪಲ್ಲಿ ಬೇರೆ ಗ್ರೂಪಿಗೆ ಪೋಸ್ಟ್ ಆಗುತ್ತೆ. ಎಸ್ ಆರ್ ನೋಡ್ ಅದೇ ಥರ ಅಕ್ರಾಸ್ ದಿ ಆನೋಡ್ ಹತ್ರ ಏನಾಗ್ತದೆ, ಆನೋಡ್ ಇಸ್ ಎ ಮೋರ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ಎಸ್ ಆರ್ ನೋಡ್. ಸೊ ನೆಗೆಟಿವ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗುತ್ತೆ ಅಕ್ರಾಸ್ ದಿ ಆನೋಡ್ ಹತ್ರ ಮೂವ್ ಸ್ಟಾರ್ಟ್ ಮಾಡುತ್ತೆ ಫ್ಯೂಯಲ್ ಸೆಲ್ಲಲ್ಲಿ. ಓಕೆ, ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಹಿಯರ್ ವಿ ಕ್ಯಾನ್ ಸಿ ಇನ್ ದಿಸ್ ಡಯಾಗ್ರಾಮ್. ಯು ಹ್ಯಾವ್ ದ ಹಿಯರ್ ಕ್ಯಾಥೋಡ್, ಇಸಂಟ್ ಇಟ್, ಯು ಹ್ಯಾವ್ ದ ಆನೋಡ್. ಸೊ ಆನೋಡಲ್ಲಿ ನೋಡಿ ಏನಾಗ್ತಿದೆ, anode is a more oxygen is getting released, isn't it? Electron ಏನಾಗ್ತಿದೆ, it is moving towards the across the cathode part. You can see that across the cathode part ಏನಾಗ್ತಿದೆ, through the external circuit electric current produce ಆಗ್ತಾ ಇದೆ. ಯಾವಾಗ electrons move ಆಗುತ್ತೆ, the electric circuit, the electric current will be produced, isn't it? So this is the actually the anode. Anode ಹತ್ರ ನೀವು ಹೈಡ್ರೋಜನ್ ಪಾಸ್ ಮಾಡ್ತಾರೆ. We are passing the fuel and fuel is been going outside and releasing the hydrogen ಏನಾಗ್ತಿದೆ, ಹೈಡ್ರೋಜನ್ ಇರೋ ಎಲೆಕ್ಟ್ರಾನ್ ನ ರಿಲೀಸ್ ಮಾಡ್ತಾ ಇದೆ. ಎಸ್ ಆರ್, ದಟ್ ಈಸ್ ವಾಟ್ H2. ಯು ಕ್ಯಾನ್ ಸಿ ದ H2 is released with the H plus and 2 minus 2E minus. ನೋಡಿ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಲೀಸ್ ಆಗ್ತಾ ಇದೆ ಇಲ್ಲಿ. ಯಾಕಂದ್ರೆ ಆನೋಡ್ ಏನಾಗ್ತದೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ರಿಲೀಸ್ಡ್ ಅಂಡ್ ಆಲ್ಸೋ ಹೈಡ್ರೋಜನ್. ಸೊ H ಪ್ಲಸ್ ಏನಿದಿಲ್ಲ, ಈ H ಪ್ಲಸ್ ಈ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಮೆಂಬರ್ಸ್ ಏನಿದಿಲ್ಲ, ದ ಮೆಂಬರ್ಸ್ ವಿಚ್ ಹ್ಯಾವ್ ಟೇಕನ್ ಫಾರ್ ದಿ ಟು ಮೂವ್ಮೆಂಟ್, ಓನ್ಲಿ ಟು ಮೂವ್ ದ ಹೈಡ್ರೋಜನ್, ನಾಟ್ ಟು ಮೂವ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಬ್ಲಾಕ್ ಮಾಡುತ್ತೆ. ದಟ್ ಈಸ್ ವಾಟ್ ಐ ಶೋಡ್ ಇನ್ ದ ಪ್ರೀವಿಯಸ್. ಎಲೆಕ್ಟ್ರಾನ್ ಇಟ್ ವಿಲ್ ಬ್ಲಾಕ್. ಪ್ಲೀಸ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ಎಲೆಕ್ಟ್ರಾನ್ ನ ಬ್ಲಾಕ್ ಮಾಡುತ್ತೆ, hydrogen ಮಾತ್ರ ಅಲೋ ಮಾಡುತ್ತದೆ. We will try to allow only the hydrogen from through this membrane. Okay, and it will reaches the oxygen. Oxygen reach ಆದಾಗ ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ H plus ಮತ್ತೆ O2. It will try to combine, it will try to produce the water and also the electrons will get combined. ನೋಡಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗ್ತಿದೆ, ಇಲ್ಲಿ ಬರೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಲ್ಲ ಏನಾಗ್ತಿದೆ, ಇಲ್ಲಿ H plus ಮತ್ತೆ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನೋಡಿ, H plus ಬರ್ತಾ ಇದೆ, 2H plus ಬರ್ತಾ ಇದೆ, ಮತ್ತೆ 2E ಬರ್ತಾ ಇದೆ, ಜೊತೆಗೆ ಆಕ್ಸಿಜನ್ ಬರ್ತಾ ಇದೆ. If you see this reaction, no, so it will try to produce the water. So water will be released. You can see water and the heat is going outside. Okay, so that is what anode hatra ಏನಾಗುತ್ತೆ, ನೆಗೆಟಿವ್ ಪೋಸ್ಟ್ across the anode. You can see this is across the anode. There is a negative post. ನೋಡಿ ಎಲೆಕ್ಟ್ರಾನ್ ಪೋಸ್ಟ್ ಆಗ್ತಾ ಇದೆ. ಈ ಪೋಸ್ಟ್ ಹೆಂಗೆ ಪೋಸ್ಟ್ ಆಗ್ತದೆ, ಪೋಸ್ಟ್ ಆಫೀಸ್ ಲೆಟರ್ ಆಗ್ತಿರಲ್ಲ, ಅದೇ ತರ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗ್ತಾ ಇದೆ, ಹೊರಗಡೆ ಹೋಗ್ತಾ ಇದೆ. ಎಸ್ ನೋಡಿ, ಇಫ್ ಯು ಪೋಸ್ಟ್ ಎನಿ ದ ವಾಟ್ಸ್ಆಪ್ ಗ್ರೂಪ್ ನ, ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಔಟ್ಸೈಡ್, ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ದ ಅದರ್ ಗ್ರೂಪ್ಸ್. ವಾಟ್ಸ್ಆಪ್ ಅಲ್ಲಿ ನೀವೇನು ಪೋಸ್ಟ್ ಮಾಡ್ತೀರಾ, ಬೇರೆ ಗ್ರೂಪ್ಸಿಗೆಲ್ಲ ಹೆಂಗೆ ಹೋಗುತ್ತೆ, ಅದೇ ತರ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗ್ತದೆ, ಆನೋಡ್ ಇಂದ ಅಲ್ಲಿರೋ ಹೈಡ್ರೋಜನ್ ಇರೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಕ್ರಾಸ್ ದಿ electrode of the your anode. Okay, from that hydrogen the electron is been released and electron is posted. Electron it is emitting and is going outside from the electric circuit, right? From the electric circuit load hatra ಹೋಗ್ಬಿಟ್ಟು ಏನಾಗುತ್ತೆ, ಆಚೆ ಕಡೆ ಹೋಗುತ್ತೆ. This electron will again it will come back because it is a it is trying to go with the here chemical. Here it is happening, the what is happening actually, electricity is also it is forming the electrical reactions, also it is happening the chemical reaction. So both it is happening here. Okay, both it is happening, right? So electron is coming here, that is a 2, it is coming here, and hydrogen is released from this. H2 ಏನಾಗಿದೆ, 2H plus ಆಗಿದೆ. ಈ H plus ಏನಾಗಿದೆ, ಈ ಕಡೆ ಹೋಗ್ತಾ ಇದೆ ನೋಡಿ. ಈ ಮೆಂಬ್ರೇನ್ ಗೆ ಮಾತ್ರ ಏನು ಅಲೋ ಮಾಡುತ್ತೆ, ಓನ್ಲಿ ಹೈಡ್ರೋಜನ್ ಮಾತ್ರ ಅಲೋ ಮಾಡುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬ್ಲಾಕ್ ಮಾಡುತ್ತೆ. Okay, electron it is blocking. So that's why we have used the solid polymers of the members. Okay, you can see what is solid polymers of the members we are using here. Okay, I'll show you, no problem. If you not noted down, that is a Nefion we are using, isn't it? ನೋಡಿ, ಇದನ್ನ ಯೂಸ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಪ್ರೋಟಾನ್ಸ್ ಮಾತ್ರ ಅಲೋ ಮಾಡುತ್ತೆ ಅಂತೆ, ಮತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಬ್ಲಾಕ್ ಮಾಡುತ್ತೆ ಅಂತ. ಹಾಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ, ಇಟ್ ಈಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಥ್ರೂ ದ ಎಕ್ಸ್ಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್. ಎಸ್ ನೋಡಿ, ಎಲೆಕ್ಟ್ರಾನ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ದ ಎಕ್ಸ್ಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್ಸ್. ನೋಡಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗ್ತಿದೆ, ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ದ ಎಕ್ಸ್ಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್ ಮೂಲಕ ಹೋಗ್ತಾ ಇದೆ. ಮತ್ತೆ ಈ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗುತ್ತೆ, 2E electrons will try to combine with the hydrogen protons H plus proton ಜೊತೆ ಕಂಬೈನ್ ಆಗುತ್ತೆ 2 electrons 2H plus 2E plus oxygen that makes the release of the water from the outside. ನೋಡಿ ಇಲ್ಲಿ electric ಪ್ರೊಡ್ಯೂಸ್ ಆಯಿತು, ನಮಗೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಯಿತು, ಮತ್ತು ವಾಟರ್ ಮತ್ತು ಹೀಟು ಈಸ್ ಅ ಬೈ ಪ್ರಾಡಕ್ಟ್ಸ್. ದಟ್ ಈಸ್ ವಾಟ್ ದಿ ಬೈ ಪ್ರಾಡಕ್ಟ್ ಆರ್ ಶೋಡ್ ಇನ್ ದ ಅರ್ಲಿಯರ್ ಇಕ್ವೇಷನ್ಸ್. ಅದಕ್ಕೆ ನಿಮ್ಗೆ ಇಕ್ವೇಷನ್ನ ಮುಂಚೆನೇ ಐ ಹ್ಯಾವ್ ಶೋನ್ ಇಟ್ ವೆರಿ ಕ್ಲಿಯರ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್. See, what is the byproducts? Water and heat. Correct? Now you can understand this slide very clearly. It is very understandable for you. This slide will make you to very easier now. ಮುಂಚೆ ನಿಮಗೆ ಅರ್ಥ ಆಗದೇನೆ ಇರ್ಬೋದು, ಇವಾಗ ತುಂಬ ಚೆನ್ನಾಗಿ ಅರ್ಥ ಆಗಿದೆ. I hope you understood this slides very clearly. Okay. See, now we can see the reactants are supplied continuously from the external source. What are the reactants? Hydrogen and oxygen, right? Producing the electricity. As long as hydrogen and oxygen are available. What are the byproducts? Water and heat is the byproducts. Hydrogen pass ಮಾಡ್ತೀವಿ ಆನೋಡ್ ಹತ್ರ, ಆಕ್ಸಿಜನ್ ಏನು ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು ಕ್ಯಾಥೋಡ್ ಹತ್ರ ಪಾಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಕರೆಕ್ಟ್? ಐ ಹೋಪ್ ದಟ್ ಸ್ಲೈಡ್ ಇಸ್ ವೆರಿ ಕ್ಲಿಯರ್ ನಾವು. ಮುಂಚೆ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗದಿನ ಇವಾಗ ಕ್ಲಿಯರ್ ಆಗಿ ಅರ್ಥ ಆಗಿದೆ. ಕರೆಕ್ಟ್? ಸೊ ದಟ್ಸ್ ವೈ ಆನೋಡ್ ಹತ್ರ ಏನಾಗ್ತಿದೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಪೋಸ್ಟ್ ಆಗ್ತಾ ಇದೆ ಫ್ರಮ್ ದಿ ಫ್ಯೂಯಲ್ಸ್ ಫಾರ್ ದಿ ಫ್ಯೂಯಲ್ ಸೆಲ್ಸ್. ಓಕೆ, ಕಂಡಕ್ಟ್ಸ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ದಟ್ ಆರ್ ಫ್ರೀಡ್ ಫ್ರಮ್ ದಿ ಹೈಡ್ರೋಜನ್. ಹೈಡ್ರೋಜನ್ ಅಲ್ಲಿ ಇರೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗ್ತಿದೆ, ಎಮಿಟ್ ಆಗ್ತಾ ಇದೆ, ಹೊರಗಡೆ ಬರ್ತಾ ಇದೆ. ಹಿಂಗೆ ಸೋಲಾರ್ ಪ್ಯಾನಲ್ ಅಲ್ಲಿ ಸೋಲಾರ್ ರೇಡಿಯೇಷನ್ಸ್ ಯಾವಾಗ PV ಮಾಡ್ಯೂಲ್ ಮೇಲೆ ಹಿಟ್ ಆಗುತ್ತೆ ರೇಡಿಯೇಷನ್ಸ್, ಅವಾಗ ಏನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಟ್ ಆಗುತ್ತೆ. ಅದೇ ತರ ನಮಗೆ ಸೋಲಾರ್ ಎನರ್ಜಿ ಟು ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಆಗ್ತದೆ. ಇಲ್ಲಿ ಆಗ್ತಿದೆ, ಇಟ್ ಈಸ್ ಗೆಟಿಂಗ್ ದ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್, ರೈಟ್? ದಟ್ ಈಸ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಸ್ ಕಮಿಂಗ್ ಫ್ರಮ್ ದಿ ಹೈಡ್ರೋಜನ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್. ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಇಂದ ಏನಾಗ್ತದೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಚೆ ಕಡೆ ಬರ್ತಾ ಇದೆ. ಇಟ್ ಇಸ್ ಗೆಟಿಂಗ್ ರಿಲೀಸ್ಡ್ ಸೊ ದಟ್ ದೇ ಕ್ಯಾನ್ ಯೂಸ್ ಆಸ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್ಸ್. ಕರೆಕ್ಟ್? ಅಕ್ರಾಸ್ ದಿ ಆನೋಡ್. ವಾಟ್ ಈಸ್ ಹ್ಯಾಪನಿಂಗ್ ಅಕ್ರಾಸ್ ದಿ ಕ್ಯಾಥೋಡ್? ಕ್ಯಾಥೋಡ್ ಹತ್ರ ನೋಡಿ, ಪಾಸಿಟಿವ್ ಪೋಸ್ಟ್ ಆಫ್ ದಿ ಫ್ಯೂಯಲ್ ಸೆಲ್ಸ್. So what is a positive post here? We can see there is a H plus. H plus it is posting ನೋಡಿ. H plus ಏನಾಗ್ತದೆ, ಈ ಕಡೆ ಪೋಸ್ಟ್ ಆಗ್ತಾ ಇದೆ, ಈ ಕಡೆ ಹೋಗ್ತಾ ಇದೆ ಅದು. H plus ಈ ಕಡೆ ಹೋಗ್ತಾ ಇದೆ, it is posting across the cathode. Yes or no? That is what H plus it is posting. That is across the positive post of the fuel cell. The positive across the cathode there is a positive post, means ion, that is the protons. Proton is getting exchanging from that membrane. It is exchanging from this membrane. Yes or not? It is exchanging from this membrane. So that's what it is called as a proton exchange. Proton ಅಂದ್ರೆ ಏನು, H plus. H plus ಏನಾಗ್ತಿದೆ, ಎಕ್ಸ್ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ. ಇಲ್ಲಿರೋ H ಏನಾಗ್ತಿದೆ, ಈ ಪ್ರೋಟಾನ್ ನ ಲೇಯರ್ ನ ಕ್ರಾಸ್ ಮಾಡಿಬಿಟ್ಟು ಈ ಕಡೆ ಬರ್ತಾ ಇದೆ. ಸೊ ದಟ್ಸ್ ವಾಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಪ್ರೋಟಾನ್ ಎಕ್ಸ್ಚೇಂಜ್ ಮೆಂಬ್ರೇನ್ ಫ್ಯೂಯಲ್ ಸೆಲ್ ಅಂತ ಕರೀತಾರೆ ಇದನ್ನು. ಅದಕ್ಕೆ ನೀವು ವಾಟ್ ಪಾಲಿಮರ್ಸ್ ನ ಯೂಸ್ ಮಾಡಿದ್ರೆ, ವಿ ಆರ್ ಯೂಸಿಂಗ್ ದ electrolyte as the polymer, solid polymers, isn't it? So this will only allow the protons. It will not allow any electrons. Electron ನ ಬ್ಲಾಕ್ ಮಾಡುತ್ತೆ. Okay, electron it will try to block the electrons. Okay, it will try to allow only the H plus. So it will try to come this membrane, from this membrane only the H plus ions will try to move from this through the membrane. It will not allow any electrons. Electrons will go through the electric circuits. Okay, so that will forms the combine with the two electrons. Two electrons in ಬರ್ತಾ ಇದೆ, ಇಲ್ಲಿ 2 hydrogen will combine ಆಗುತ್ತೆ with the oxygen. It will try to produce the waters. So that is the byproducts. Okay, that is the byproducts. Okay, that is what it is happening in the positive post of the fuel cells. Positive post ಹತ್ರ ಏನಾಗ್ತಿದ್ದಾವೆ, H plus ion is going towards the fuel cells. So that is towards the cathode. And the electrons is also combining with the H plus along with the oxygen plus 2 electrons. It will try to release the water, right? So that is, you can see that there is a distribute of oxygen to the surface of the catalyst. Then the catalyst will also be distributed oxygen to the surface of the catalyst. Wherever you have the oxygen across the surface, the catalyst will also try to react. It will conduct the electrons back from the external circuits to the catalyst and will recombine with the hydrogen ions and the oxygen to form the water. So that is what it is happening in the cathode. Correct? So if you see the electrolytes, so proton exchange membranes, right, especially treated as materials, it only conducts the positive charge ions, and electrons it will try to block the membrane will try to block the electrons. I hope it is clear now. Membrane ಏನು ಮಾಡುತ್ತೆ, electron block ಮಾಡುತ್ತೆ, H plus proton ನ ಮಾತ್ರ allow ಮಾಡಬೇಕು. That's what is named as a proton exchange membrane. Okay, only proton ನ ಮಾತ್ರ ಎಕ್ಸ್ಚೇಂಜ್ ಮಾಡುತ್ತೆ ಹೊರತು ಎಲೆಕ್ಟ್ರಾನ್ ನ ಮಾತ್ರ ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಅಲೋ ಮಾಡಲ್ಲ. So that is the reason, that's why it is called as a proton exchange membrane. Okay, catalyst, if you talk about the catalyst now, it will facilitate the reaction of oxygen and hydrogen. You ಎರಡು ಆಕ್ಸಿಜನ್ ಏನು ಸಪ್ಲೈ ಮಾಡ್ತೀರಾ ನೀವು across the cathode, hydrogen what you are going to supply from the anode, it will try to improve the reaction the more faster. Right, it will try to facilitate the reactions to become more and more faster. What kind of catalyst you are using? Platinum powder. Okay, you are using the platinum powder which is very thinly and coated onto the carbon paper of the clothes. So that catalyst it will be utilized. Okay, that's why it is very costlier. Fuel cell is very costlier because of this materials. Okay, platinum powder material. Okay, it is rough and porous, maximize the surface area exposed to the hydrogen or oxygen. The platinum is coated of the side of the catalyst face across the PEM, that is proton exchange member hatra ಏನು ಮಾಡಿರ್ತಾರೆ, the platinum will be coated, okay, to increase the reaction to be the more and more faster. Okay, you can take the screenshot of this of the diagram. Okay, this diagram is clear to you, Sneha and Mamta?
Yes, sir. Yes, sir.
Okay, if you want to take the screenshot, you can take the screenshot. It will save your time. Okay, so that you can analyze the later also. Okay, no problem. So hydrogen, we are passing the fuel here. Hydrogen, okay. Hydrogen we are passing from the anode, and oxygen is passing from the cathode. Okay, at anode, what is happening actually? Hydrogen will try to release the electrons from the hydrogen molecules. Try to release the electron which is moving to the external circuit. Okay. And H plus ions will try to go from through these membranes, and it will combine with the across the cathode. It is more, ions are posted, the protons are posted across the cathode, right? And will combine with your oxygen, and also it will combine with the 2 times of electrons to release the water, the H2O. This is what is actually chemical reactions. Okay. See here you can see it is very simple. H2 hydrogen is there, anode hydrogen pass madidira, hydrogen plus protons na release ಮಾಡಿದೆ, membrane ಇಂದ ಏನಾಗ್ತದೆ ಕ್ರಾಸ್ ಆಗ್ತದೆ, it is going to the across the your cathode part, it is posting toward the cathode part. Okay, so that's why it is a hydrogen is protons is passing to the cathode part and it is releasing the electrons. So these electrons ಏನಾಗ್ತದೆ ಇಲ್ಲಿಗೆ ಬಂದ ಮೇಲೆ through electron circuit, when the battery is been this working under working condition, your fuel cells under working condition, you produce a 0.7 volts. Okay, so once you connect this, once you connect in a stack now, you'll get the more number of voltage. So that's why we are just looking to have the 1.7 volts of the cells. Okay, so that's why this electron electron will try to move over here, right? And oxygen will also come in. You can see in the across the cathode what is happening, half times of oxygen plus 2H plus 2E, because you have to balance the equations. So equation is balanced very clearly. Half times of 2O2 means it is 1. Okay, 2 into 2, 2 by 2 is 1, isn't it? 2 by 2 is 1. So there is 1 over here. You see there is 1 over here on the right hand side. There is a 2H. Okay, there is 2H. Here H2. Yes, sir. The equation is balanced. So this is, we call it as a reverse hydrolysis. Yes, sir. We call it as a reverse hydrolysis. What we studied the inventors we have made, right? This is the fellow who has invented this reverse hydrolysis. But here the William Grew has invented this, where the reverse hydrolysis is possible from the water to electricity back to the water. That is called reverse hydrolysis. But ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ ನಮಗೆ, we are getting only the water. Here we don't find any kind of it is just recombining of the hydrogen is getting combined with again oxygen, right, to form the water, right? So that is how your proton exchange membranes will work. Okay, if you see the operation is also very easier, right? The pressurized hydrogen gas, right? Everything should be pressurized. ಯಾವುದೇ ಗ್ಯಾಸ್ ಆಗಿರಲಿ ನೋಡಿ, ನಿಮ್ಮ ಮನೇಲಿ LPG ಗ್ಯಾಸ್ ಯೂಸ್ ಮಾಡ್ರಿ, ಅದಕ್ಕೂ ಕೂಡ ಹೈ ಪ್ರೆಷರಲ್ಲಿ ಹಾಕಿರ್ತಾರೆ. Okay, that is what we call it as the parts per million, high pressure. If you see your vehicle of your bike also, right, bike vehicle allu kuda ನೀವು ಟೈರ್ ಇರುತ್ತಲ್ವಾ, ಅಲ್ಲೂ ಕೂಡ ಗ್ಯಾಸ್ ಹೈ ಪ್ರೆಷರ್ ಅಲ್ಲಿ ಫಿಲ್ ಮಾಡಿರ್ತಾರೆ. ಕರೆಕ್ಟ್. ಈ ಸಿಲಿಂಡರ್ ಅಲ್ಲಿ ತಗೊಳ್ಳಿ, ಮನೆಯಲ್ಲಿ ಯೂಸ್ ಮಾಡೋ ಸಿಲಿಂಡರ್ ಕೂಡ ತಗೊಳ್ಳಿ, LPG ಗ್ಯಾಸ್, ಅದು ಕೂಡ ಹೈ ಪ್ರೆಷರ್ ಇರುತ್ತೆ ನೋಡಿ. ಗ್ಯಾಸ್ ನೀವು ಸ್ಟವ್ ಆನ್ ಮಾಡಿದ್ರೆ ಹಂಗೆ ಗ್ಯಾಸ್ ಬಂದ್ಬಿಡಿ, ಬಿಕಾಸ್ ದೇರ್ ಇಸ್ ಪ್ರೆಷರ್ ಹ್ಯಾಸ್ ಬಿನ್ ಕ್ರಿಯೇಟೆಡ್ ಇನ್ಸೈಡ್ ದ ಯುವರ್ ಕಂಟೈನರ್ಸ್. ಅದೇ ತರ ಪ್ರೆಷರೈಸ್ ನಾವೇನ್ ಮಾಡಬೇಕು, ಗ್ಯಾಸ್ನ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಶುಡ್ ಬಿ ಪಾಸ್ ಥ್ರೂ ವೆರಿ ಹೈ ಪ್ರೆಷರ್, ರೈಟ್? It will try to hit the cells on the anode side. Okay, when gas is forced through the catalyst by the pressure, when you pass the gas with the catalyst, what will happen? The hydrogen molecule comes on the contact with the platinum catalyst. Right, it will splits into the H plus ions and the 2 electrons it will release. So that is what these equations. Okay, hydrogen jotege enagutte, catalyst combine adaga enagutte, reaction become more faster. It will try to release the protons and the 2 electrons. Okay. Electrons are conducted through the anodes. See, you can see it is very clear. Electrons conducted through the it is conducted through the your external circuit through the anode, right? From the anode it is going to be conducted. Electrons through anode in the release ಆಗ್ತಾ ಇದೆ. So that is what they are telling across the that is electrons are conducted through the anodes. So electron is conducted through the anodes. You can see the electrons moving from the anode to cathodes. Correct. So there is a way through the external circuit. So if once electron is coming, no, so that you have to connect the external circuit and return to the cathode side of the fuel cell. See, you can see across the electric circuit it is going. It is coming back to the cathodes. So after passing from the electrons are coming from over here, right, and a current will flow in this direction from cathode to anode. The current will flow. That is what we call it as a conventional currents. S anode, that is we call it as a conventional current. Electrons will be in one side and current will be in the opposite direction. That is we call it as a conventional current. Okay, on the cathode side, you can see the oxygen is forced through the catalyst. If you see on the cathode side now, you can see there is a oxygen. We are passing oxygen over here, isn't it? Oxygen pass ಮಾಡ್ತಾ ಇದ್ದೀರಾ. Two electrons are coming over here, isn't it? And also hydrogen get is combined. Right, hydrogen plus oxygen will combine along with the two electrons and will try to release the water. That is what they are doing. From two oxygen atoms, each with a strong negative charge. Right, the negative charge attract with the two H plus ions through the membranes. The H plus ions, protons are coming from through the membranes only. That is a 2 H plus ions which is coming from the proton membranes. It will try to react with the 2 oxygen and also 2 negative charge, 2 E minus. Okay, these combinations will make to create the 2 electrons from the external circuit to form the water molecules. Then water will be released outside. Correct? So this is how the working principle of the operation will work for your fuel cells. Is that clear, Sneha and Mamta?
Yes, sir. Yes, sir.
Okay, all right. We'll see about the next. What are the different types of applications we have? Okay, this is actually the PEMC stack. You can see this is a single stack. You can see there is a single stack over here, isn't it? So these are the combinations they have made. These are the configurations they have made to get the enormous of voltage. Correct? So if you see, this is the electrical equivalent circuit of the modeling of your permanent proton exchange membrane fuel cells, isn't it? So you can see there is a cathode, right? This is the anode. It's just like a capacitor and the resistance. Okay, capacitor and resistance kuda idu. Here you can see there is a cathode with just like a capacitor with the resistance. Okay, and this is your cell. This is your battery. Okay, this is where you can have the E cells. Okay, this is the voltage across your fuel cells. Okay, this is actually the electrical circuit models, right? So E cell is a fuel cell, that is a thermodynamic voltage, where you are getting the thermodynamic. When you talk about there is a heat is being produced, yes or not? Along with the water, there is heat also produced. That's why it is a thermodynamic voltage. We cannot say it is not a chemically reacted. Okay, it is not chemically reacted. It is we call it as a thermodynamic in nature. All right. So V act A. So you can see there is a V act A across the anode. There is a voltage, actual voltage, right? V act, and also V act across the C. This is across the cathode. Are the anode and cathode activation losses associated to their double layer of capacitance cell? It is like a CDL. It is a capacitance double layer capacitance cells. Okay, double layer capacitance, that is called CDL. So you can see there is a capacitance, right? And also you have the resistance of the anode and the resistance of the cathode. Every cells will have, if we have this capacitance, no, it will be having the resistance, internal resistance. Okay. How the human being having the resistance in their body, that is we call internal resistance of our human body. That is the resistance of the human body. Right? Like that also the capacitance also will have the internal resistance. Okay. So like this is actually the equivalent circuit of the modeling of the proton exchange membrane fuel cells. Okay. So that is what they have shown very clearly here. This is about the E cells. Okay. This is how we have to understand the internal electrical circuit of the modeling of the fuel cells. Right. So I hope it is very clear for this. We'll go for the alkaline fuel cells. Okay, is that clear? The fuel cell is clear. PEMFC. Is it clear, ma?
Yes, sir.
Do you have any doubt with this? Proton exchange fuel cell.
No doubt, sir.
Okay, we'll go to the alkaline fuel cell. Then we'll go. See, function are almost same. Okay, here the function is almost same. See, hydrogen also you're passing the oxygen. Alright, you can pass any different agent also. Not only hydrogen, you can pass about your other kinds of the liquid as well as the gaseous also, right? The solid. What are the agents are there, you can pass. But function remains same. And also the electrolytes. What kind of electrolytes you're using also will matter a lot for the particular types of the fuel cells. Okay. Here they are using the hydroxide, that is a potassium hydroxide you can use, isn't it? We are focusing more on the hydroxides. Alright, it is almost same like the alkaline fuel cell also same, right? So when you talk about the alkaline fuel cell, no, the operation is also same like, right? So operation it will take the operate with the potassium hydroxide, that is KOH. KOH is the potassium hydroxide solutions as an electrolyte, okay? And can utilize various non-precious metals as a catalyst to the electrodes. the principle is beyond the same, working principle is same, but you are using a different types of electrolytes. So that's why we, if you use the alkaline, if you use the alkaline with the different types of electrolytes as well as the catalyst, then it says the particular types of the fuel cells. Okay, there you are using the platinum as a catalyst, and also you are using a different types of the proton exchange membranes. Here the electrolytes we are using as potassium hydroxides. Potassium hydroxide we are going to use. Okay, and also it will utilize as the metals such as the catalyst for the to the electrodes, make the reaction to be more faster. Electrodes are nothing but the anode and cathodes. So temperature range, if you see the temperature range, it may go up to beyond 100 degree to up to 250 degrees centigrade, right? The alkaline fuel cells operate. Right? The new designs also come, right? It can go up to lower temperature, minus 23 degree to 70 degree. Right? This is about the lowest temperature where the fuel cell will also work for the alkalines. So alright, so it is also a rapid rate of chemical reaction will occur within the cells and achieving the higher efficiency, right? It is used in the, especially in the spacecrafts. Okay, alkaline fuels are used in spacecraft. That is what I given the applications in the earlier, right? And also you can see the cost consideration, right? If you talk about the cost consideration, the cost is less as critical in the remote application like space, right? And AFC must become more cost effective for the widespread of commercial use. They have been demonstrated the stable operation over 8,000 hours, right? The charging and discharge, the charging of the usage may comes to around 8,000 hours. Now, how you decide for the life cycle, no? How you decide for the life cycle? Similarly, you have to think about the operations of this fuel cells. All right. So now we can note down the diagram is very simple, right? Instead of H plus, here you have OH minus. That is a potassium hydroxide. Only we are considering only the OH minus, which is flowing towards from the cathode to anode. Okay, now you please understand the reaction is the very bit little bit simpler. Okay, see everything is same. We are passing the hydrogen over here, isn't it? If you see the reaction, no, you have to understand the chemical reaction of this. Okay, chemical reaction, electrochemical reaction, you have to understand. You have to balance the equation. Then only it is easy to understand the concept of the alkaline fuel cell. Okay, see here you are passing the hydrogen, you are passing the oxygen. Okay, here you are going to pass the hydrogen, you are going to pass the oxygen. There are two things over here. Here you are going to pass the hydrogen, you are going to pass the oxygen, right? So inside this, what is happening across the anode? So across the anode, it will try to release the electrons. See, first you see here, electron release aagta hai. Electron is going to the external circuits, okay, to produce the current, okay. Then electrons is coming over here. So oxygen, when oxygen is also coming over here, these electrons will try to from the cathode, right? It is coming towards the cathode, and oxygen and electrons will try to combine. And also there is a from this H2O, okay, from this H2O, there is a release of only the electrons. Already there is a release of electrons and also the H plus, isn't it? So now when you see this hydrogen oxides, the hydrogen oxides will try to combine, it will try to go from the cathode to towards the anodes. So it is going from cathode to the anodes. So this is electrolytes what we are using for the making the separations, right? Electrons, only the electrons will go from the from here to here, isn't it? From anode to the cathodes. So whereas the oxygen will try to combine with the your electrons, right? Oxygen will try to combine with the electrons, and also this OH minus, right? That is the protons. OH minus will try to combine with the your electrons along with the oxygen, right? And also it will try to produce the water. It will try to have the across the cathode reactions, right? Across the cathode reaction, if you take the oxygen and the water, what will happen? It will try to form the H2O. Okay, you have the H and also you have the O2, isn't it? It will try to form the H2O across the cathode reactions, okay, and also it will combine with the electrons, and also it will combine with your oxygen to produce the hydroxides, isn't it? So once it is the reaction is happening with the in the anode reactions, okay, if you see there is an anode reaction is happening, that is a 2H2, means you are passing the hydrogen, it will try to release the it will try to release the electrons, okay, and it will try to combine with the OH minus. You can see there is a H2 plus OH minus, okay, H2 plus OH minus, it is getting combined, it will try to form the water, understood, and also it will release the four electrons. It is going to the electric circuits from the anode to the cathodes, okay. This will happen across the anode reactions, across the anode electrodes, okay. Now let us see across the cathode reaction, across the cathode electrodes. What is happening across the cathode electrode? You can see there is a water is being there, isn't it? So water is there. You also have the 4 electrons. It is coming over here, isn't it? We have the water already, which is combined with the 4 electrons, and oxygen is the additional agent which is flowing from the past. Okay, so this will try to produce the hydroxide, that is the 4HO minus, it will try to produce. So that is why the hydrogen oxide is trying moving from the cathode to the anodes, cathode to the anodes. So right, that is how the working of the alkaline fuel cell will work, isn't it? So this is the one part, alkaline fuel cell, right? So if you talk about the solid oxide fuel cells, next we'll go to the solid oxide fuel cells, then we'll understand the concept of your combinations of the batteries as well as the ultra capacitors. Okay, so is that clear? Those two, it is clear to you now?
Yes, sir.
Okay, fine. I think Rashmi has joined just now. Okay, is it visible now?
Yes, sir.
So all right, so after learning the your fuel cell technologies, PMC and solid oxide fuel cells and alkaline fuel cells, right? Alkaline fuel cells, same, the working principle are almost same, using different types of the electrolytes, right? And then we'll study the SOFC. Along with it, we'll go with the combining the batteries with the supercapacitor for maintaining the grid and also the load demands, and also to making the integrations of the renewable with the other grids, also conventional, non-conventional energy. We are going to integrate and to stabilize the load balance and now supply and the demand balance. We are going to see how this can be happen if the energy storage is being done for the, that is the solutions. So that is the major solutions where you have to see the hybrid energy storage. But hybrid energy storage combines your battery along with the capacitors. Okay, so this is very the basic things. Most of the question will be asked on your fuel cells, outer capacitors, and also the SOFC and AFC in the examinations. Okay, so any question may be asked on the fuel cell also, right? And also the different types of technology and its applications, right? And also how the designs has been done, what is the new technology has come in the markets, right? And what different types of EVs has been come into the market with the different regions using the fuel cells for their compatibilities. So all right, this is what you may expect in the examinations, right? The supercapacitor and the fuel cells. All right, so we'll see the solid oxide fuel cell, right? That is a SOFC. Right, if you see the SOFC, right, are the type of the fuel cell that uses a solid ceramics, right, electrolytes to conduct the ions, typically the oxygen ions, to generate the electricity. Here, the electrolyte is only the difference, as I told many times. All fuel cells having the working principle are almost same, but when you use the different types of electrolytes, okay, it is just like, for example, if you're using a the Bisleri water bottle, right? You can fill the water also, you can fill the milk also, you can fill the butter also in that. Yes or not? So you can fill the any kind of the juice also inside that bottle. Means the container is same. So fuel cell is same. The working principle is same, isn't it? So we are just changing the electrolytes. How we are changing the water? Sometimes changing to filling the milk. Sometimes changing to filling the butter. Sometimes you're filling the different types of juices, isn't it? So that's why the fuel cell are working same, but only the electrolyte is different. You can see there is a difference in the electrolytes. Sometimes we are using a solid ceramic electrolytes to conduct the ions, typically the to oxygen ions to generate the electricity. Right. The speciality of the solid oxide is nothing but oxide is that it will operate with a very high temperature. You can see there is operation of 6000 to 1000 degrees centigrade, which allows to achieve the very high efficiency and enables the use of the wide variety of the fuel cells, isn't it? So if we talk about the temperature, right, the temperature is very high. It will operate with a very high temperature also. Okay. One thing is that here the operation of the temperature, right, operating at a very high temperature around 6000 to 1000 degrees centigrade, which allows them to achieve the higher efficiency and enables the wide use of the varieties of the fuel cell, right? So that's why the materials which are used for the electrolyte is a solid ceramic, and operation is it is operating at a very high temperature around 6000 to 1000 degrees centigrade, right? So if you see the electrolyte is a solid ceramic materials, you can just note on the materials of the electrolytes, that is a YSZ, right? Ethyl stabilized zirconia, right? Zirconia is a materials which are used in the solid oxides, right? Which will conduct the oxygen ions from the cathode to the anodes. So that's why we are using these kinds of the electrolytes. As we are using electrolytes from the for the proton exchange membranes, right? Only for the H plus ion, proton ions. Similarly, we are going to use these kinds of the materials, that is electrolytes materials, that is zirconia, right? Which will try to conduct the oxygen ions from the cathode to the anodes, right? So that's why there is a change in the electrolytes. So there is only the change in the electrolytes. We are not making any fuel cell. Almost everything is same, but only change in the electrolytes. Okay, then you can see there is a ion migrations. So usually the ion has to be a migrated. That is a exchange of the ion should be there, right, across the electrolytes. The oxygen ions will migrate through the solid ceramic of electrolytes to the anodes, right? You can see there is a migrations of the ions. Okay, you can see there is a oxygen ions, isn't it? It is migrating towards the anode. So oxygen ions will migrate through the solid ceramic of electrolytes, that is zirconia electrolytes. It is moving from the electrolytes, that is your oxygen ions, and it will reaches to the anode. See, you can see there is a oxygen, right? It will trying to reach oxygen through, it is passing through these electrolytes and reaching to the anode. Towards the anode it is reaching, correct? So that is what they are saying, that across the anode, commonly made of the ceramic, that is a composite ceramic and metals, right? Typically you can say it is a nickel wise, that is a nickel stabilized zirconia, right, which facilitates the oxidations of the fuels. Right, here the two things is happening, right? That is, we call it as a there is oxygen reduction at the cathode and oxidation reactions at the anodes. There are two things it is happening over there, okay, across the anode and the cathode. Across the anode there is a oxidation it is happening, right, because oxygen is coming towards the anode. That's why there is a oxidation is happening. At the anode, the oxygen ions react with the fuels, that is typically hydrogen. As oxygen is trying to react with the hydrogen, or you can say carbon monoxide, CO and CH4, CH3, hydrocarbon, CH2, right, to form the water, and also the release of the to form the water and the carbon dioxide, and the electrons will be released. These electrons are then released into the external circuit, generating the electric circuit. You can see there is a electrons has been released. When oxygen is coming towards the crossing this electrolytes membranes, then it is passing towards the hydrogen. Hydrogen will combine with this to form the water, and there is a releasing of the electron which is going to the electric circuits. See, everywhere the working is same. Due to the electrolytes, there is a little bit the reactions are getting changed. The chemical reaction has been changed. Okay, it is almost same. See what is happening, that is called the oxidation is happening, right? What is happening over the anode? Oxygen ions, it is getting combined with the hydrogen, right, to release the water and release the electrons. Correct? It is trying to release the water and it is trying to release the electron. See, across the anode, what is happening? Oxygen. This oxygen is coming from the cathode. Yes or not? Oxygen is coming from the air. You are see, there is air, you are flowing the air with a very high pressure. Yes or not? This oxygen is going with the hydrogen. It is going to combine. Oxygen is coming crossing this electrolyte. It is combining with the hydrogen across the anode. Hydrogen is also coming over here. Then when it is trying to release the electrons from the hydrogen and the oxygen during the chemical reaction, it forms the water and there is a release of the electrons which is going to the electric circuits. Okay, through the, it will pass through the your electrical current circuits, right? Thereby the electrons is coming towards the cathodes, right? So this process we call it as a oxidations. That's what is called as oxidations, right? Oxidation reaction is happening across the anode. If you see across the cathode, cathode is usually made up of a lanthanum strontium manganite, that is LSM. We call it as a LSM, right? Which facilitates the reduction of oxygen. See here, there is oxidation that is happening. Now there is a reduction of oxygen molecules to the oxygen ions. Oxygen in the oxygen ions, it is trying to reduce the oxygen in the oxygen molecules. It is trying to reduce the oxygen ions. Okay, you can see across the your cathode. What is happening across the cathodes? There is a oxygen, right? You have two oxygen plus electrons. This oxygen also coming. This electron is also coming. These two will get recombined. There is a recombine across the cathode, right? So two electrons are combining, will combine with the oxygen. That is half times of oxygen. We already studied in the previous reaction, right? It will try to release the O2 minus, right? That is O2 minus. Then the air will go out like this, isn't it? So you can see there is a that is what it is happening. The reduction. There is a oxygen reduction at the cathodes. See, there is a reduction of oxygen. That is O2 minus. It was O2, right? Then there is a O2 minus. You can see there is a reduction. So the reduction of things is happening across the cathode reactions, right? So that's why it is called as a redox. You can see that this is called the oxidation and reduction. That is we call it RED and OX. That is called the redox. That is what we studied in the very most first slide. I told about the very most first slide of the redox, isn't it? Here I can see. Is it visible now? Redox reactions for the fuel cells. Is it clear? Sneha and Mamta?
Yes,
That's
sir.
why there is a reduction and oxidation is happening. That's why I explained in the very earlier of the fuel cells. Then we studied the types of the fuel cells. Correct? So let us see the fuel cells, the types of fuel cells, right? We have the polymer electrolyte, polymer membranes we are using. Direct methanol is there, alkaline is there, right? We have the solid oxides, right? So these are using the different types of the electrolyte. What are the electrolyte is using? Solid oxide is in the zirconia, right? And here using the, for alkaline using potassium hydroxide, KOH. That is the electrolyte. Here please note down the main points. Fuel cell is the types of the fuel cells. It is using the electrolyte. It is polymer membranes for the polymer electrolytes. For your alkaline, it is using the KOH, potassium hydroxide. For your solid oxides, we are using the zirconia. Okay. What is the operating temperature? It is working at the lowest temperature, right? And it is operating a little bit higher temperature, 150 to 2 degrees centigrades, 200 degrees centigrades. Right? For solid oxides, it will work at the greater than your 500 to 1000 degrees centigrades. Okay, solid oxide will work at the very high temperature. So these are the chemical reactions. That is what, if you don't follow, you can just take the screenshot, no problem. Later again, I make the analysis of the equations, all these equations. We have made the balanced equations of the electrode reactions. Okay, you can take the screenshot, right? So based on the power rating, you can see based on the power ratings, you can go for the type of the fuel cells. Okay, if you want a 6 kilowatt, if you want only the 10 watts, if you want only the lesser range of the power densities, we can select the types of the fuel cells. Okay, so for from maximum from 1 watt to up to 1100 kilowatt, we can go for the proton exchange membrane fuel cells. Okay, if you want more than higher, then you can go for the molten carbonate, right? That is the molten carbonate fuel, which is not there for your syllabus. Don't worry. Okay, so we have not studied the molten carbon fuel cells, right? It is we can go beyond the power density of more than 1 megawatt to 10 megawatt. All right, so that can be used. These can be used for your grids, especially in the grid storage. Okay, grid stability you can use in the power system also, where you can use for the providing the supply to the load side, right? There you can use the MCFC, right? That is a molten carbonate. The electrolyte we are using the potassium carbonate over there also, right? So there you can have this power density from 1 megawatt to 10 megawatt. All right. So if you want to have the with the lower range also, you can go for the from 10 kilowatt to the 10 megawatt. You can go for the SOFC. That is solid oxide fuel cells, right? Which can work at the range from the power density from 10 kilowatt to the 10 megawatt. Okay, this is also used in the especially in the grid also. Right, we can go for with lesser values. You can go for from watt to kilowatt and go for the alkaline fuel cells. Okay, if you want to have the more power ratings, then you can go for the higher densities. You can go for the this one phosphoric acid fuel cells. Okay, you can go for the phosphoric acid fuel cell. So this is what the actual fuel cells, how they are used in the different temperature and different applications and different power densities. Based on this, you can select. In the exams, they may ask in the competitive exams, which is the fuel cells are used in the grids, which is the fuels are used in the electric vehicles, which are the fuels are used in the particular application. They'll ask in the interview or they ask in the competitive exams also, right? So for that, it is better to glance this fuel cells type of the fuel cells types of the electrolytes are used, and also the operating temperature, right? So this is very useful for your competitive exams. All right. So if you see the types of the fuel cells, we'll see the description, we'll see the pros and cons. Okay. So PEM, that is a proton exchange membranes. We are using the polymer electrolytes over there, right? Which is widely developed most of the places, right? What is a cross? We have the life is very good, and so quick response it is there, right? And also the light and weight and compact in nature, right? So what is the cons? If you see, it is very expensive. Right, it is very expensive. Design is very complex in nature, even though it is light in weight. right? And it is uses for specialized fuels, right? Proton exchange can be used for the specialized fuels where it is based on the application you can use. So proton exchange membranes, it is based on the application you have to use, right? It can be used in your cars and heavy vehicles also, right? Your four wheelers or any more than four wheelers you can use, go for the electric buses, electric trams you can use more than for readings of the 10 kilowatts. All right. Alkaline fuel cells, okay, it is used in the most of the alkaline solution for the as electrolytes. It provides a higher efficiency. Cost of manufacturing is very low also, right? If you see the cons, there is a it is bulky in nature, right? It requires the pure hydrogen and oxygen to produce this electricity, isn't it? So next we can go for the MCFC, that is a molten carbonate fuel cell, right? It is uses the molten carbonate as a solution as electrodes, right? And when you talk about the efficiency, it is very high. Almost the efficiency is good, and the fuel compatibility also we have to see, and also there is a chances of the corrosions, right? And the start is there will be slow start, and the lifespan is very short as compared to the molten carbonate fuel cell, right? So if you see the phosphoric acid fuel cells, it is efficiency is good, right? And it has a good durabilities also, right? And also it uses the electrolyte as your phosphoric acid as electrolytes, right? And operation conditions, if you see, it is a operate temperature is very high. That's not higher operating temperature. So phosphoric acid fuel cell, you can see the operating temperature with phosphoric fuel cell is 180 to 200, which is more than the polymer, which is more than the methanol, which is more than the alkalines. Right. Next comes your solid oxide, which temperature is very high. Right. It is work with a very high temperature. That is a drawbacks of this solid oxide fuel cells. Right. Efficiency is good. Efficiency is good. It uses the electrolyte called the solid ceramics. It will use. It will operate with a very high temperature. Right. And based on the application also, you can use, that is a solid oxide fuel cell, right? It is used in terms, it is used especially in the grids also, right? From 10 kilowatt to the 10 megawatt. You can see from 10 kilowatt to the 10 megawatt. All right, it is used in the most of the grids also, right? And also most your electric vehicles also can use. Right, so these are the research from the various industries, right? Where they are going to extract the hydrogen for to produce the fuels, to get the fuels for the automotive purpose. So is that the differences clear for the different types of the fuel cells? Sneha, Mamta, Rashmi, is it clear?
Yes, sir.
Okay, I hope you have joined very late, no problem. You can watch the videos at any time. It will be shared in your WhatsApp group, okay? Mamta, Sneha, is it clear?
Yes, sir. Yes, sir.
The different types of the cells with their pros and cons along with the electrolytes, what types of electrodes are used, and the different applications we have also been seen, right? Next, we'll see the automotive industries where they are going to use the different types of fuels, right? General electric motor, right? The General Motors and other are looking for catalyze the next generation of cars. They are looking for to work more on the hydrogen part, right? On the fuel cells only. They are want to have the more the innovations in the fuel cells, right? Because in the upcoming days, in the 2030 or 2040, most of the vehicles on the road will be on only electric vehicles. This combustion engines, fuel in IC engines will be completely eradicated, right? We are just looking for the electric vehicles in the upcoming days. So that's why you have to do a lot of research on the your fuel cells to make the design of the fuel cells to be work in a very in the proper way and make the novelties in the fuel cells, right? So these fuels are also utilized in the for the electric vehicles, right? So if you see the domestic automotive makers, right? If you see go for any research, no. For example, if you want to use for the domestic purpose, or you can use for the grid also, you want to use for in the electric vehicle, right? So there is a severe factors. One factor is that it is a face serious threats on the bankruptcy, making the large R&D push difficulties. See, when you go for doing any research, no, ನೀವು ಒಂದು ರಿಸರ್ಚ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅಂದರೆ ರೈಟ್, ಒಂದು R&D ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಕಂಪ್ನಿ ರನ್ ಮಾಡ್ತಿದ್ದೆ ಅಂದರೆ ದೇ ಆರ್ ಇನ್ವೆಸ್ಟಿಂಗ್ ಇನ್ ಕ್ರೋರ್ಸ್. ಯಾಕೆ ಹೇಳಿ? ಒಂದು ದೊಡ್ಡ ಪ್ರಾಜೆಕ್ಟ್ ಮಾಡಿ ನಾವು ಒಂದು ವೆಹಿಕಲ್ನ ನಾವು ರೋಡಲ್ಲಿ ತರ್ತಿದ್ದೀವಿ ಅಂದರೆ, ಫ್ಯೂಯಲ್ ಸೆಲ್ಸಲ್ಲಿ ನಾವು ರಿಸರ್ಚ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅಂದರೆ, ಅದನ್ನು ಯುಟಿಲೈಸ್ ಮಾಡಿ ನಾವು ಒಂದು ವೆಹಿಕಲಲ್ಲಿ ಹಾಕ್ತಾ ಇದ್ದೀವಿ, ವಿ ಆರ್ ಬ್ರಿಂಗಿಂಗ್ ದಟ್ ಟೆಕ್ನಾಲಜಿ ವಿತ್ ಮಾರ್ಕೆಟಲ್ಲಿ ಮಾಡ್ತಿದ್ದೀವಿ ಅಂದರೆ, ರಿಸರ್ಚ್ ಆ್ಯಂಡ್ ಡೆವಲಪ್ಮೆಂಟ್ ವಿಲ್ ಹ್ಯಾಸ್ ಟು ಫೇಸ್ ಅ ಲಾಟ್ ಆಫ್ ಡಿಫಿಕಲ್ಟೀಸ್. ಇಫ್ ದ ಸಕ್ಸಸ್ ಫೈನ್, ಸಕ್ಸಸ್ ಆದರೆ ಓಕೆ, ಫೇಲ್ಯೂರ್ ಆದರೆ ಏನು ಮಾಡಬೇಕು? ಥ್ರೆಡ್ಸ್ ವಿಲ್ ಅಕರ್. ನೋಡಿ, R&D ಫೇಲ್ ಆದರೆ ಏನು ಮಾಡಬೇಕು ನಾವು ಇವಾಗ? R&D ಫೇಲ್ ಆದರೆ ಥ್ರೆಡ್ಸ್ ಆಗೇ ಆಗುತ್ತೆ. ದಟ್ ಇಸ್ ಅ ಸೀರಿಯಸ್ ಆ್ಯಂಡ್ ಸಿವಿಯರ್ ಥ್ರೆಟ್ ವಿಲ್ ಅಕರ್ಸ್ ಆನ್ ದಿ ಬ್ಯಾಂಕ್ ಕ್ರಪ್ಟೀಸ್. ನೀವು ತಗೊಂಡಿರೋ ಲೋನ್ಸ್ ಎಲ್ಲ ಏನಾಗುತ್ತೆ? ಇಟ್ ವಿಲ್ ಗೋ ಫಾರ್ ದಿ ಕರಪ್ಷನ್, ಇಟ್ ವಿಲ್ ಗೋ ಫಾರ್ ಜಸ್ಟ್ ಲೈಕ್ ಇಟ್ ವಿಲ್ ಗೋ ಫಾರ್ ಕರಪ್ಷನ್ಸ್ ಓನ್ಲಿ. Bank will come and seize if R&D is not good. Yes or no? If you are running the company, right, in company ನೀವು ಇನ್ವೆಸ್ಟ್ ಮಾಡಿದ್ರೆ ಕ್ರೋರ್ಸ್ ಗಟ್ಟಲೆ ಇನ್ವೆಸ್ಟ್ ಮಾಡಿ, ಯಾಕೆ ಹೇಳಿ? ಯು ಹ್ಯಾವ್ ಲಾಟ್ ಆಫ್ R&D, then you research are doing the things, right, where the fuel cell should become more and more advanced to bring into the vehicles, right, implementation into the vehicles, incorporating the vehicles to make the EV as a more advanced in the upcoming days. ಆಮೇಲೆ ರಿಸರ್ಚ್ ಮಾಡಿದಾಗ ರಿಸರ್ಚ್ ಫೇಲ್ ಆಯ್ತು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? ಆಬ್ವಿಯಸ್ಲಿ ನೀವು ತೊಗೊಂಡ್ರೆ ಬ್ಯಾಂಕಿಂದ ಲೋನ್ ತೊಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ? ಥ್ರೆಡ್ಸ್ ಆಗೇ ಆಗುತ್ತೆ. ಫೇಲ್ ಆಯ್ತು ಅಂದರೆ. ಸಕ್ಸಸ್ ಆದರೆ ಓಕೆ, ಸಕ್ಸಸ್ ಹ್ಯಾಪನ್ಸ್ ಓಕೆ. ಸೊ ದಿಸ್ ಫೇಸ್ ಸೀರಿಯಸ್ ಥ್ರೆಡ್ಸ್ ಆಫ್ ದಿ ಬ್ಯಾಂಕ್ is to making a large R&D push difficulties. So that's why you have to do a lot of research and development. ನೀವು ಅದಕ್ಕೆ ರಿಸರ್ಚ್ ಆ್ಯಂಡ್ ಡೆವಲಪ್ಮೆಂಟ್ ಯಾಕೆ ನೀವು ಪೇಪರ್ ಮಾಡೋಕ್ಕೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ, ಸಮಥಿಂಗ್ ಯು ವಿಲ್ ಟ್ರೈ ಟು ಲರ್ನ್ ಸಮಥಿಂಗ್, ಹೊಸದು ಏನಾದರೂ ಕಲಿತಿರೋದ್ರಿಂದ. ಅದಕ್ಕೆ ವೆನ್ ಯು ಪ್ರೊವೈಡ್ ದಿ PBL, ಪ್ಲೀಸ್ ಟ್ರೈ ಟು ಮೇಕ್ ಸರ್ಟನ್ ಕೈಂಡ್ಸ್ ಆಫ್ ಟ್ರೈ ಟು ಫೈಂಡ್ ಅ ರಿಸರ್ಚ್ ಗ್ಯಾಪ್, ವಾಟ್ ಎಲ್ಸ್ ವಿ ಕ್ಯಾನ್ ಡೂ ಇನ್ ದಟ್. ಓಕೆ, ಕೊಟ್ಟಿರೋ PBL ನಾವು ಏನು ಮಾಡ್ಬೋದು ಅದರಲ್ಲಿ ಅನ್ನೋದು ಸ್ವಲ್ಪ ನೀವು ಅನಾಲಿಸಿಸ್ ಮಾಡಬೇಕು. ಟ್ರೈ ಟು ಇವ್ಯಾಲ್ಯೂಯೇಟ್ ಇಟ್ ಆ್ಯಂಡ್ ಟ್ರೈ ಟು ಕ್ರಿಯೇಟ್ ಸಮಥಿಂಗ್, ರೈಟ್. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಎ ಚಾಲೆಂಜಿಂಗ್. ಅದೇ ಥರ R&D ಡಿಪಾರ್ಟ್ಮೆಂಟಲ್ಲೂ ಕೂಡ ತುಂಬ ಡಿಫಿಕಲ್ಟೀಸ್ ಫೇಸ್ ಮಾಡ್ತಾರೆ. ಬಿಕಾಸ್ ದ ಪರ್ಸನ್ ಹೂ ಇಸ್ ರನ್ನಿಂಗ್ ದಟ್ ಕಂಪನಿ ದಟ್ ಹಿ ಹ್ಯಾಸ್ ಟು ಬಿ ಇನ್ವೆಸ್ಟ್ ಇನ್ ಎ ಕೋರ್ಸ್, ಎಸ್ ಆರ್ ನಾಟ್, that he is expecting the outcome in the market. So if the research and development got failed, obviously you'll be under the threats. Okay, then the bankruptcy will happen. So these are the difficulties General Motors in the automotive industries will try to face, right? So this is what the rivals such as the Toyota and Honda are already ahead with the GM. But the GM kinta munde they are in the leading positions. This Toyota and Honda are in the leading position as compared with the Ford company and the GM, right? Most of the cars also we have, that is where they are going to make a lot of research. They are trying to make the innovations to bring the good things in the market, right? We have to bring the good outcomes. We have to bring the good outcomes in the markets, right? So that is Toyota and Honda are very come forward as compared with the GM. That is what I'm talking about. The rivals of the such as Toyota and Honda, they are combining both together, right? And they want to have to get some innovations in the electric vehicles, right? Their goal is to get the superiorities. They want to get the superiorities. They want to complete the task to be in a very simpler way, right? It is a teamwork. The Toyota and Honda, like how the companies, most of the companies will try to combine, make the collaborations. We are making the collaboration with the other research, right? We can make the collaboration not only with our university, we can make the collaboration with other university who do a lot of R&D department, right? They also can make the collaboration with the industries also, with the companies also, with the other institute or other organizations. We can make the combine. We can start working together to make the outcome, to get the most of the outcome. That is what the most of the peoples are doing, right? Most of the industries will try to combine and they'll make a lot of research. So that is what, this is one of the example I'm just telling you. To Toyota and Hondas are already they are in the come forward, right? With compared with your GM and the Ford companies, right? They are making a lot of inventions in the industries, right? If you see the Honda, they are using going with a negative temperature also. They are operating the fuel cell with a negative temperature, and also maximum temperature up to 95 degrees centigrade. Right? It is more better than your batteries. No, the batteries will work at 45 degrees centigrades. So fuel cell is more advanced. Right, you can operate from -degree also. You can go up to higher level of the degree, that is 95 degrees centigrade, which is far better. You can take the car. You can go to in the Canada also. You can go to the Shimla also. You can go to Jammu Kashmir also. You can go to Kanyakumari also. You can stay in the Davangere also, right? You can go to West Bengal also, where the temperature is around 48 degrees centigrade. You can go to Ballari also, right? If you buy the Honda car of having the fuel cell technologies incorporated in that. Okay, so that's why these are there. They have done a lot of research. Right, that is what they have make the innovations, they have make the novelties in their work. All right, So if you see that this is actually the prototypes. Okay, this is the prototypes where the Honda has been built a hydrogen productions and the filling the station prototypes. So this is the prototypes where it will try to pass the hydrogen from the tank. Okay, it will try to pass the hydrogen to these fuel cells from this containers, right? It will try to build the production of hydrogen and filling this hydrogen into the fuel cells, right, to create the electricities. All right, these are the Ford companies I told, right? These are the your fuel cell technology, right? These are the driving range up to 100 miles, right? And this is another example of the your internal combustion engine with the hybrid vehicles. They're using the hydrogen, right? They are combining with the IC engines. Right. If we take the example of in the Canada, right? In the Canada also, the first in the fuels has been incorporated in the power transist bus, right? Which is made by the Ballard Power Station, right? I hope you remember the concept of the Ballard, isn't it? Okay, it has provided the horsepower of 275 HP for the engine and a range up to 250 miles before requiring the refueling, right? So that is how the invention they have made in the other countries, right? If you see in the Delhi also, no, don't worry, in our India also has been, invention has been made, right? So we are also having the fuel cells, right? Especially for the this one, Toyota is there and Nissan is there. Toyota companies also come forward to make the design of the fuel cell for the electric vehicles. Right. So that's completes here the part of the fuel cell as the applications and also the various types of technologies which have been used in the fuel cell, right? So next we'll go with the sustainabilities, right? So we should plan for the sustainabilities, right? We want to have if you want to sustain your life, right? So we have to do something, isn't it? If you want to sustain your life, what do you do? Start earning. Yes or not? So if you want to get the power supply continuity, right, you have to go for the plan something, right? You have to plan something for the sustainability to get the more energy, right? That is what you have to go for the electric productions. That should be provided to the continuously, right? We should have to get this electricity productions at all the times, right? So without disrupting the actual loads, right? For the any productions in the factories and other things, right? Electricity production is very important. So that's why you should plan for the sustainability, right? Sustainability is a very important factors where you can sustain the most of the things of your electrical energy, where you can use the electrical energy for the various purpose, right? For all the times. So that is what it should be provided continuously over a longer time, and there should not have any the outage. Right, that is the actually what we talk about this as meaning of the sustainable life, the sustainable plan. All right. So if you want to sustain, if you want the continuity of the power, right, you should go for the integrating your grids, right, integrating with the grids for conventional, non-conventional energy both. All right. So what is the purpose of the plan? We have to form the various forms of electricity production. What are different forms of electric productions? Go with the in the syllabus we have the battery technologies and also we have the capacitors, isn't it? So combine those two and store it in terms of megawatt and gigawatt, right? So then when there is a load demand, so when there is a peak demand, then you try to supply it, convert back to the HVAC to HVDC to HVAC, then supply to the consumers, to the loads. Okay. Further, you have to store the energy. You have to store the energy in the batteries and the ultra capacitors, right? So that is what the power management and control is very important. Right, now we can see there is a hybrid energy storage, right? Now you have the wind also, you have the solar also, you have the battery also. So these are the consumers. The combinations of the different energy sources, right, available and the balancer system which provides a stable output from the source and minimize the ಡಿಪೆಂಡೆನ್ಸಿ ಆನ್ ದ ಸೀಸನಲ್ ಚೇಂಜಸ್. ಸಮಟೈಮ್ಸ್ ಏನಾಗುತ್ತೆ, ಸೋಲಾರಲ್ಲಿ ರೇಡಿಯೇಷನ್ ಸಿಕ್ಕಿಲ್ಲ ಅಂದರೆ ವಿಂಡು ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಅವಾಗ ವಿಂಡಿಂದ ಪವರ್ ಜನರೇಷನ್ ಆಗುತ್ತೆ. ಸೊ ವಿಂಡ್ ಜಾಸ್ತಿ ಇಲ್ಲ ಅಂದರೆ ರೇಡಿಯೇಷನ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಸನ್ಲೈಟ್ ಜಾಸ್ತಿ ಇದೆ ಅಂದರೆ ಸೋಲಾರಿಂದ ಪ್ರೊಡಕ್ಷನ್ ಆಗುತ್ತೆ. ಸೊ ಬೋತ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ದ ಬ್ಯಾಟ್ರೀಸ್ ಓನ್ಲಿ. ಸೊ ಬ್ಯಾಟ್ರಿಲಿ ನಾವು ಸ್ಟೋರ್ ಮಾಡಿ ಇಟ್ಟಿದ್ದೀವಿ ಅಂದರೆ ಯಾವಾಗ ಒಂದ್ರದ್ದು ಡಿಫಿಸಿಟ್ ಆಗಿ ಇನ್ನೊಂದು ಜನರೇಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಸೊ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಬ್ಯಾಲೆನ್ಸ್ ದ ಯುವರ್ ಲೋಡ್ ಆಲ್ಸೋ. ಈಗ ಲೋಡ್ ಕ್ಯಾನ್ ಬಿ ಬ್ಯಾಲೆನ್ಸ್, ಯಾಕಂದರೆ ಬ್ಯಾಟ್ರಿ ಸ್ಟೋರ್ ಆಗಿರುತ್ತೆ. ಎನಿ ಒನ್ ಫಾರ್ಮ್ ಐದರ್ ವಿಂಡಿಂದ ಆದ್ರೂ ಬರುತ್ತೆ, ಇಲ್ಲಾಂದರೆ ಸೋಲಾರಿಂದ ಆದರೂ ಕೂಡ ಬರುತ್ತೆ. ಸೊ ಏನಾಗುತ್ತೆ, ಎನಿ ಒನ್ ಫಾರ್ಮ್ ಯು ಆರ್ ಗೆಟಿಂಗ್ ದ ಎನರ್ಜಿ, ರೈಟ್. ಇಫ್ ಡ್ಯೂರಿಂಗ್ ಸಮ್ಮರ್ ಡೇಸ್ ಸೋಲಾರ್ ವಿಲ್ ಟ್ರೈ ಟು ಜನರೇಟ್, ರೈನಿ ಡೇಸ್ ಇದು ಜನರೇಷನ್ ಮಾಡಲ್ಲ, ಅಷ್ಟೇ ನೋಡಿ. ಸೊ ವಿಂಡ್ ಸಮಟೈಮ್ಸ್ ವಿಂಡ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಸಮಟೈಮ್ಸ್ ವಿಂಡ್ ಕಡಿಮೆ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಬೇಸ್ಡ್ ಆನ್ ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಬ್ಯಾಲೆನ್ಸ್ ದೀಸ್ ಟು. ದಟ್ಸ್ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಹೈಬ್ರಿಡ್ ಎನರ್ಜಿ. Yes or not? We are storing the energy, right? This system is trying to store the energy by making the taking the renewable energy, that is a non-conventional energy resource. That is a renewable energy use ಮಾಡಿಬಿಟ್ಟು will try to store the energy in the batteries. That is a battery bank, so that it can be used, then convert back to the HV AC convert ಮಾಡಿ ನೀವು loading provide ಮಾಡಲೇಬೇಕಾಗುತ್ತೆ. Okay, so this is how the system has been incorporated, right? Production from the renewable energy sources, store into the battery, make the backup and convert into the inverters, right? And with the help of the power electronic circuits. So you know how the IGBT MOSFETs will go, right? Voltage controlled, current controlled, and switching ಮಾಡಬೇಕು IGBT ಇಂದ DC ಇಂದ AC ಮಾಡಿಬಿಟ್ಟು ನೀವು AC ನ ಏನು ಮಾಡಬೇಕು, ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. then give it to the load for the consumers, right? So that is what we can minimization the dependency is also possible during seasonal change. ನೋಡಿ, ಒಂದ್ಸಲ ಇದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಬೇಕು, ಒಂದ್ಸಲ ಇದ್ರಲ್ಲಿ ಡಿಪೆಂಡ್ ಆಗಬೇಕು. ಪ್ರತಿ ಸಲ ಒಂದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಯ್ತು ಅಂದ್ರೆ ಸೋಲಾರ್ ರೇಡಿಯೇಷನ್ಸ್ ಇಲ್ಲ, ಬರೀ ಮಳೆ ಬರ್ತಾ ಇದೆ ಅಂದರೆ for a period of 6 months, there is no battery charging, isn't it? There is no charging of the batteries. So that is what the difficulties we are facing. ಅದಕ್ಕೆ ಏನು ಮಾಡಬೇಕು, ನೀವು ಸ್ಟೋರೇಜ್ ಮಾಡಬೇಕು. ಯಾವುದು ಬ್ಯಾಟ್ರಿ ಬ್ಯಾಂಕಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಐದರ್ ಇನ್ ಒನ್ ಫಾರ್ಮ್ ಯು ಸ್ಟೋರ್, ಟ್ರೈ ಟು ಸ್ಟೋರ್ ಫ್ರಮ್ ದಿ ಎನಿ ಒನ್ ಫಾರ್ಮ್. ಓಕೆ, it will try to give the continuity of the power supply. That is, we can have the reliabilities. Okay, it will try to balance the system. The complete system ಏನಾಗುತ್ತೆ, ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡುತ್ತೆ. Either from this grid or either from this grid, you try to balance the system which provides the stability output. You see, there is a stable output. Battery storage ಆಯಿತು ಅಂದರೆ in terms of megawatt or gigawatt, inverter will try to make the HV DC to HV AC, it will try to provide the supply to the consumers at all the times. Okay, is it clear the battery sources, how the battery hybrid energy can be done?
Yes, sir.
Sneha?
Yes, sir.
ಓಕೆ, ದಟ್ ಈಸ್ ವಾಟ್. ನೀವು ಯಾವಾಗಲೂ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಒಂದು ವಿಂಡ್ ಇದೆ, ಸೋಲಾರ್, ಎರಡನ್ನ ಏನು ಮಾಡಬೇಕು, ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ಯಾವಾಗ ವಿಂಡ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಸೋಲಾರ್ ರೇಡಿಯೇಷನ್ಸ್ ರೈನಿ ಸೀಸನ್ಸಲ್ಲಿ ವಿಂಡಿಂದ ನಮಗೆ ಏನಾಗುತ್ತೆ, ಪವರ್ ಜನರೇಷನ್ ಮಾಡ್ಕೋಬೋದು. ಯಾವಾಗ ರೇಡಿಯೇಷನ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ವಿಂಡ್ ಕಡಿಮೆ ಇದ್ದಾಗ ಇದರಿಂದ ಕೂಡ ಜನರೇಷನ್ ಮಾಡಬೇಕು. ಪ್ರತಿ ಸಲ ನೀವು ಜನರೇಷನ್ ಮಾಡಿಬಿಟ್ಟು ಏನು ಮಾಡಬೇಕು, ಯು ಹ್ಯಾವ್ ಟು ಸ್ಟೋರ್ ಇನ್ ದ ಬ್ಯಾಟ್ರೀಸ್. ಬ್ಯಾಟ್ರಿ ಬ್ಯಾಂಕಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಅದನ್ನು ಏನು ಮಾಡಿ, ಇನ್ವರ್ಟರ್ನ ಮಾಡಿಬಿಟ್ಟು ದೆನ್ ಯು ಗೋ ಬ್ಯಾಕ್ ಟು ದ ಕನ್ವರ್ಷನ್ ಫ್ರಮ್ HVDC to HVAC using the power electronic devices, right? To make the inversions, then give it to the load side. Okay, that's why it makes more reliabilities. There should have the hybrid energy system. This is the solar energy, this is the wind energy. Both are integrated. That's what is called a hybrid. Okay, next we'll make the hybrid of batteries. That is what the actual topic comes here, right? We have to make the hybrid of the supercapacitor, nothing but the what, ultra capacitors. Okay, and also energy storage, hybrid energy storage, batteries. This is called hybrid energy storage. Okay, this concept tells about hybrid energy storage. Okay, ನಾವು ಸೂಪರ್ ಕೆಪಾಸಿಟರ್ ಮತ್ತು ಹೈಬ್ರಿಡ್ ಎನರ್ಜಿ ಸ್ಟೋರ್ನ ಎರಡು ಕಂಬೈನ್ ಮಾಡಬೇಕು ಇವಾಗ. ಓಕೆ, ಎರಡು ಕಂಬೈನ್ ಮಾಡಿಬಿಟ್ಟು ಏನು ಮಾಡಬೇಕು, ಸ್ಟೋರ್ ಮಾಡಬೇಕು. ದೆನ್ ಯು ಗೋ ಫಾರ್ ದಿ ಡೆಲಿವರಿಂಗ್ ಟು ದ ಕನ್ಸ್ಯೂಮರ್ಸ್. ಓಕೆ, ಸೊ ವಿ ಟಾಕ್ ಅಬೌಟ್ ದಿ ಎನರ್ಜಿ ಸ್ಟೋರೇಜ್, ದಟ್ ಈಸ್ ಆಕ್ಚುಲಿ ಸ್ಟೋರ್ ದ ಎನರ್ಜಿ, ದಟ್ ಯೂಸಸ್ ದ ಸ್ಟೋರ್ಡ್ ಎನರ್ಜಿ ವೆನೆವರ್ ದ ನೀಡ್ಸ್. Whenever you want the energy, you can store the energy, you can reuse it. Correct? Okay, energy can be stored to provide the stored electricity to the grid and the stable power output from the renewable energy sources. Okay, here also you can see there is a PPT is not visible. PPT is not visible, right? So is it visible now, PPT?
Yes, sir.
Okay, you can see there is a solar radiation from the sunlight which is having the insolations of 800 to 1000 watt per meter square, where you're going to generate the electricity. It is stored in the your batteries, isn't it? So the charge control is stored in the batteries, then it is used the inverter, then you're giving power supply to the load side. Okay, this is actually the hybrid energy storage system, right? Here we have the battery energy storage and we have the supercapacitor. You can say there is supercapacitor storage. So these are the two things. We have the hybrid storage, we have the battery storage, we have the supercapacitor storage, right? Where the solar panels have been used, one is connected to the rechargeable battery lithium batteries, and here you are using the supercapacitor batteries. We are supercapacitors. Okay, these are the types of batteries which has been already studied. Your lithium batteries, right? Nickel, cadmium, sodium nickel cadmium chlorides, right? So if we make the comparison of the different types of batteries, we have the specific energy based on the lead acid. We have the 35 to 60 megawatt, right? Nickel cadmium may have the 75 megawatt. We talk about the specific energy, that is watt per kg, right? So if you see the demonstration of the upper limit of the power in terms of the megawatt, lead acid will be in terms of megawatt, with tons of megawatt for nickel, right? We see the lithium ion, it is a tons of kilowatt. It is very, very less, right? You see the solid nickel chlorides, it is around low of hundreds of kilowatt, isn't it? See the specific energy, right? The specific energy is to be around 35 to 50 watt hour per kg. And similarly for the sodium sulfur also you can see 50 to 240, right? And sodium nickel is 125, right? The specific power also 75 to 300, right? If you see in the sodium 92 or 230, and the lithium having the 200 to 315 the power density. Life cycle, if you see the life cycle, it is for lithium, it is around 1000 to 10,000 plus. And if you for the sodium nickel, it is chloride with 2500 plus, isn't it? So these are the life cycles where you can have the charging discharging cycle also. Efficiency, right? In the previous session I also showed the various types of the batteries, and it's a life cycle, specific power, energy density, specific life cycle, and charging discharge energy, charging and discharge energy efficiency have been shown, isn't it? So this is how the battery and the battery plus capacitor will look, right? So charging very slowly and charging very speedy and discharge very slowly. For the supercapacitor, we make the combining of the batteries and the supercapacitor. Sir, if you see the technology, right, the most of the flow batteries, sodium sulfur and lithium batteries, we can have the generation of in terms of the megawatts. If you see the percentage, right, the lithium having the 41%, because lithiums are used widely used. Lead acid is also widely used around 28%, right? And flow batteries will be very, very less. And sodium also we have the 8.1% of the usage for the. This is how with respect to the world electricity consumption, right? So consumption is becoming more and more, right? With respect to the year, if you see from 2025, because of the population density, what is happening? We are going to be in terms of kilowatt hour. The consumption is 26,000 or 18 kilowatt hour in the year 2025. Yeah, as the consumption is being increased, then the generation should also be should be increased. Yes or no? So you can see there is a in terms of kilowatt hour in the y-axis, in terms of year in the x-axis. See day by day, no, year by year, what is happening? The consumption is also getting increased. Then how to compensate this? Right? How to compensate? Consumption is more. See, there is a consumption in the India energy balance. No, the consumption is more over British thermal unit, right? And production is very less. See, to compensate these two, there is a gap. No, you have to compensate this. For that only, we are going for the battery management system. Sorry, storage of the hybrid. So that's why we are going for the hybrid energy storage. Yes or no? That's why we're going to fill that gap. We're going to for the battery capacitor and hybrid energy storage. So, all right. So that is what we have to fill this gap. Consumption, production should be more, should be equal to the consumptions. If consumption is more, the production is very, very less. You can balance the supply as well as the load demands. Okay, that will make the difficult. So to see the from the smart grids, right? If you see in the smart grids, whenever the load comes, please we have to intimate the demand management. It is very, very important. in the hybrid energy storage system, right? There should have the load levelings, right? And also the peak shifting. Whenever the maximum demand comes, you have to remove the loads. So load can be removed automatically when you have the smart energy meters. And also your power system should be falls under the smart grid technologies. Then the load levelings and the peak shifting, it is only possible, right? So we are not going with the smart grids, right? So if we use these battery technologies where we are going to have the storage in the enormous when during the peak demands, right? To store the energy in the peak demands and try to supply. Okay, so that is what you have to go for the demand management, right? Whenever there is demand, please try to store the energy. Try to store the energy whenever there is a demand is excess. So all right, so this is how the battery management, demand management of the load leveling and peak leveling can be done in a very easier way, right? During when there is a no usage, right? You try to store the energy, right? When there is a peak demand, you try to discharge the energy from the batteries. As when there is demand. So during this time, we can make the load leveling and the peak shaving is also possible when there is a load and peak demand occurs, right? When there is a maximum demand, so you try to charge and store it, right? When there is a low demand, try to charge and store. When there is a peak demand, you try to supply from the batteries, right? So these are the various technologies for the energy storage system, right? Some are already deployed. The pumped hydro has also been deployed, right? And batteries also been deployed in most of the grids. If you see the demonstration, most of the technology has been demonstrated for the superconductor magnetic energy storage also. That is what we studied in the last sessions. And also we have the advanced PB and acid flow batteries. We have the new technologies, nothing but the adiabatics, right? The energy storage. We have the synthetic natural gas also, right? So this is how actually your battery super storage capacity and energy storage will look, isn't it? You have the power station, you have the bus bars, isn't it? You have the transformers also, right? Along with the after the transformers, if you want to satisfy the load, please store the energy for the demand, for the load demands. You can satisfy the load demands. Wherever the load, if you connect to the load, no? If you connect to this load, right? You can satisfy the demand from the ESS, that is the energy storage. If you have the hybrid energy storage, no? Battery with the capacitors, battery with ultra capacitors, then if you, so for example, ನೋಡಿ ಇಲ್ಲಿ power station ಅಲ್ಲಿ power generation ಆಗ್ತಾರೆ, it is not satisfying these loads. ಅವಾಗ ಏನು ಮಾಡ್ತೀವಿ ನಾವು ಎಕ್ಸ್ಟರ್ನಲಿ ನಾವು ಲೋಡ್ ನ ಲೆವೆಲ್ ಮಾಡಬೇಕಂದ್ರೆ ಲೋಡ್ ನ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡಬೇಕಂದ್ರೆ we are going for ESS extra ನಾವು ಸಪ್ಲೈ ಮಾಡ್ತೀವಿ. We are going for the extra supply. This DC HVAC ಮಾಡಬೇಕು ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಇಂದ through this grid, through this bus bar we are transporting to the especially to the loads. ನೋಡಿ ಎಲ್ಲ ಕಡೆ ESS ನ ಹಾಕಿದ್ದಾರೆ. ಯಾಕಂದ್ರೆ ನಾವು ಲೋಡ್ ನ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡಬೇಕು. ಜನರೇಷನ್ ಕಡಿಮೆ ಇದೆ, ಲೋಡ್ ಜಾಸ್ತಿ ಇದೆ. ಸೊ ಅವಾಗ ಏನು ಮಾಡ್ತೀವಿ, ಜನರೇಷನ್ ಬರ್ತಾ ಇರುತ್ತೆ, ನೀವು ಬ್ಯಾಟ್ರಿ ಸ್ಪಿನ್ನಿಂಗ್ ರಿಸರ್ವ್ ನೋಡಿ ಇಲ್ಲೆಲ್ಲ ರಿಸರ್ವ್ ಮಾಡಿರ್ತೀವಿ, ಸ್ಟೋರೇಜ್ ಮಾಡಿರ್ತೀವಿ ಆಲ್ರೆಡಿ. ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ದಿ ರಿಸರ್ವಾಯರ್ಸ್. ಮೀನ್ಸ್ ವಿ ಆರ್ ಸ್ಟೋರಿಂಗ್ ದ ಎನರ್ಜಿ already reserved, energy being stored. So that energy should be stored and it should be given to the loads whenever there is a demand comes. Peak demand ಇದ್ದಾಗ ಏನು ಮಾಡಬೇಕು, ನೀವು ಎನರ್ಜಿನ ಬ್ಯಾಟ್ರಿಯಿಂದ ಕಳಿಸ್ತಾ ಇರಬೇಕು. HVDC ಇದೆ, HVDC ಮಾಡಿ ಲೋಡಿಗೆ ಕಳಿಸ್ತಾ ಇರಬೇಕು. ದಟ್ then it can satisfy the load demand. You can see everywhere ನೋಡಿ, ಇಲ್ಲೂ ಕೂಡ we have the ESS, it is satisfying the industries. If you see here also you have the ESS along with the bus bars and the transmission lines with the from power grids. ಎಲ್ಲ ಕಡೆ ESS ನ ಹಾಕಿದ್ವಿ, ಯಾಕೆ ಹೇಳಿ, to satisfy the load demands. Okay, so that is how your these are the various technologies of configuration. You see photovoltaic ಕೂಡ ಗ್ರಿಡ್ ಅಲ್ಲಿ ಇದೆ, wind ಕೂಡ ಗ್ರಿಡ್ ಅಲ್ಲಿ ಇದೆ, hydro ಕೂಡ ಗ್ರಿಡ್ ಅಲ್ಲಿ ಇದೆ, and also the generating sets, all are in the grids. So all are connected with the, your battery technologies, and along with the inverters, batteries and the supercapacitor. That is how you can satisfy the energy demand for the consumers. Okay, so if you see the conclusions, right, we'll conclude this. Hybrid energy storage, hybrid electrical energy storage is a technology which contributes to the rise the efficiency at every stage of energy chain. Right, it will try to improve the efficiency of the all electrical energy being used. ಯಾರು ಎನರ್ಜಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಎಲ್ರಿಗೂ ನಾವು ಏನು ಮಾಡಬೇಕು, ಲೋಡ್ನ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ದಟ್ಸ್ ವೈ ಜನರೇಷನ್ ಜೊತೆಗೆ ನೀವು ಬ್ಯಾಟ್ರಿನ ಸ್ಟೋರ್ ಮಾಡಬೇಕು. ಅದರಿಂದ ಕೂಡ HVDC ಮಾಡಿಬಿಟ್ಟು ಯು ಕ್ಯಾನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಟು ದ ಲೋಡ್ ಆಲ್ಸೋ, ರೈಟ್. ಸೊ ಆ್ಯಂಡ್ ಆಲ್ಸೋ ಯು ಕ್ಯಾನ್ ಹ್ಯಾವ್ ದ ಪವರ್ ಕ್ವಾಲಿಟೀಸ್ ಆಲ್ಸೋ ಕ್ಯಾನ್ ಬಿ ಇಶ್ಯೂಡ್, can be solved. Voltage frequency ಕೂಡ ನಾವು better na monitor, regulations can be possible, right? And interruption also happen, you can overcome from the, you can improve the power quality from your this kind of the systems, right? So it will try to give the reliabilities of the energy for specific load. Every time you can give the supply, If the grid is not operating, you can give grid from the ESS, you can provide the energy. If the grid, along with the grid also, if excess of load comes, you can give from the ESS also. That is called the reliability of the energy to satisfy the specific load, right? So this completes your actual hybrid energy storage. So we have to make them more sustainably, right? Every life is very, very important. Every wants the power. Everybody wants to use their power for the particular applications, right? So that's why we should go for the sustainabilities. So is that clear? Sneha, Mamta, Rashmi. If you have any queries, you can ask.
Yes, sir.
So shall I wind up the class? If you don't have any queries. Sneha, Mamta, Rashmi.
Okay, sir. Thank you, sir.
Okay, thank you.
Yes, sir.
Thank you, thank you.